A warm good morning to all our eminent guests, Honorable Chairman Sir Sunil Sharma Sir, Honorable Chief Mentor Dr. Sudhanshu Sir, Honorable President Dr. Jagdish Rai Rutra, Dr. Shruti Kanga, Coordinator of Center for Climate Change and Water Research, Dr. Suraj Kumar Singh, Coordinator of Center for Sustainable Development, faculty members, and to all who are present here from different institutions and country. I, Priyanka Roy, welcome you all on behalf of Suresh Gyan Vihar University for the inaugural ceremony of 7th Annual International Convention on Climate Change and Water Research. This year's perspective of convention is sustainability in current scenario, challenges and solutions. It is with the view of building sustainable society for future. We are very delighted and eagerly looking forward to have you all involved in the quest of embracing the knowledge. Now, on this thought, I would like to call upon Dr. Shruti Kanga, Coordinator of Center for Climate Change and Water Research, to take forward today's event with a welcome address. Madam Shruti Kanga.
Thank you, Priyanka. Good morning, everyone. Greetings to one and all present here. I, Dr. Shruti Kanga, Associate Professor and Coordinator, Center for Climate Change and Water Research, welcome you all. It gives me immense pleasure to grace all of your presence in the interest of the entire committee. It gives me tremendous happiness to present the welcome speech among the most esteemed people present over here. Before we begin the 7th Annual International Conference or Convention on Sustainability in Current Scenario, Challenges and Solution, C3W 2020, I would like to express my heartfelt gratitude to all of you who sincerely committed this event to make it a great success. From this platform, I would like to now brief about the university and the Center for Climate Change and Water Research. Suresh Gyan Vihar University is situated in Rajasthan, India. It is the first private university in the state of Rajasthan that has been accredited with NAC A grade. The university has students across the world in the field of engineering, sciences, management, pharmacy, liberal studies, hotel management, education, agriculture, and healthcare sciences. About the Center for Climate Change and Water Research, it basically aims at research and development activities and has publication as various books, research papers, etc. in reputed publication houses like Springer, Taylor Francis, Wiley, Elsevier with high citations. We have faculties from IITs, NITs, BIT, Central University, Wiley Institute of Himalayan Geology, etc. The center has also various courses starting from graduation level up to PhD level, that is from BSc Geology Honours, MSc Geoinformatics, MTech and BTech program in Geoinformatics and PhD in Geoinformatics and allied fields. The center has active participation and also involved in conducting various conferences, webinars, workshops, seminars, etc. So that the various academicians, scientists, research scholars, and various organizations got a platform where they can exchange their research and finally they can come up with a solution which can be helpful for the community and sustainable development and various sustainable management activities. The convention are organized or conducted for the general audience to gain insight and the information that remain effective throughout their lifetime and their work progress. Present convention was chosen, taken care the mind and need of the youth. Resources like air, land, forest, and water underpins all the progress in the society, and it is a prerequisite for any kind of sustainable growth towards the achievements of maximum sustainable developmental goals. In order to end hunger, ensure the good health, build sustainable cities, and fight against the climate change, we need a reliable access to the most fundamental resources of all. The aim and the purpose of the convention is to share and disseminate knowledge, information, and the experiences on all the resources and their sustainable management, and to finally promote collaborative and uh, cooperative activities in the field of sustainable resources or development of the resources. With this, I would like to now call Priyanka for continuation of the program. Thank you so much.
Thank you, ma'am. Thank you for the introduction of the convention as well as our university and our center. And now, on this note, I would like to invite Dr. Suraj Kumar Singh, from coordinator of Center for Sustainable Development, to give a brief information of sustainability in current scenario, challenges, and solution for 2020.
Thank you, Ms. Priyanka. Myself, Dr. Suraj Kumar Singh, Coordinator Center for Sustainable Development and convener C3 2020. On behalf of Suresh Gyan Vihar University, Jaipur, I am pleased to welcome you all to our annual International Convention on Climate Change and Water Research C3 2020, which is being held during 5th to 7th November 2020. The title of the conference is Sustainability in Current Scenario, Challenges and Solution. This conference follows the success of pioneering C3W 2002, 12, 13, 14, 15, 18, and 19. Inspired by our past 6 events, we hope to build on the community that comes together and fosters a connected, a collaborative, and creative international network of adaptation, researchers, decision makers, and interested citizens. The event holds a high repute as an amalgamation venture where climate and water leaders from various backgrounds like government, industrial, social, and scientific community meets at one place and delegates their thoughts and work to influence decisions and policies. The International Convention aims to bring together leading academicians, scientists, industrial experts, researchers, students from India and around the world to exchange and share their experiences and research findings on all the aspects of climate change, sustainable development, natural resource management, green cities, disaster risk management and reduction, geoinformatics, all meeting at the same place and having an exchange of knowledge. For the current convention, there will be 3 technical sessions comprising 6 renowned academicians, scientists, researchers, disseminating their experience in the above mentioned themes. Apart from each theme, we have got a question answer session where the queries related to pertaining to the various aspects of climate change and solutions can be discussed directly with the researchers who are working in the field of climate change. Followed by the technical session, we'll have 4 sessions of paper presentation comprising 16 presentations in each sessions daily. The total registration for the conference are 1,220 participants have registered from various prestigious institutions of India and across the world. I'll list some of them. The prestigious institutions who are participating in our conference are IIT Mumbai, IIT Kharagpur, Guwahati, Roorkee, Banaras Hindu University, NIT Warangal, NIT Karnataka, Surathkal University of Kashmir, Indian Institute of ISRO Bhopal, University of Delhi, Aligarh Muslim University, Indian Institute of Remote Sensing, Punjab University, Chandigarh, Central Soil Salinity Research Institute, Regional Remote Sensing, Lucknow, Jharkhand, Bihar, Indian Council of Agricultural Research, Indian Institutes of Farming System Research, Kurukshetra University, and there are many more from India. Not only from India, we have got participation from University of Science, Malaysia, University of Malaya, University Saints, Malaysia, Wuhan University, University of Copenhagen, Denmark, University of Twente are also participation, and we have got participants from across the globe, from Southeast Asia, Africa, Middle East, South America, from the countries like Nepal, Bhutan, Bangladesh, Sri Lanka, Philippines, East Timor, Fiji, Myanmar, Afghanistan, Iran, Brazil, Albania, Morocco, Nigeria, Ethiopia, Uganda, Algeria, Mali, Cameroon, Kenya, Zimbabwe, Tanzania, and Sudan. And these are the few countries that I have listed. There are many more to be listed. About the total abstract that we received near about 130 abstract, and from which the editorial team has selected best 80 abstract, and all this 80 abstract are included with for a publication with a ISN number in the Journal for Climate Change and Water Research published by Suresh Gyan Vihar University. With this, I wish that from this international convention, we'll be able to serve the main motto of the event towards the sustainable development and management of resources. And with this, I hand over my talk to Ms. Priyanka for further processing. Ms. Priyanka.
Thank you, sir. Thank you for the brief introduction of the convention and all the invitations and the overwhelming response we have got all over the world and from various institutions. Thank you, sir. Now, on this thought, I would like to give a brief introduction of our Honorable Chief Mentor, Dr. Sudhanshu. He has, to his credit, extensive research paper regarding distinctive environmental concerns and issues. He has 14 years of rich experience as a great administrator with a diversified vision. He is a great thinker, great motivator, and with an incorrigible capacity of working in multitasking dimension. Under his competent leadership, Gyan Vihar University has developed by leap with an excellence of being identified and recognized as one of the foremost technical institution of our country. He devoted all his time, efforts, and energy in constantly planning on how to boost and develop every facet of this university, be it academic, which is his prime grit and concern, or infrastructure or campus facilities or placement or any other aspect that affect the smooth running of and growth of the university. He always finds spare time and juncture for his commitment towards the social obligation. He has been actively and effectively involved in various social political organizations for the past 20 years. Now, on this note, I would like to invite Honorable Chief Mentor Dr. Sudhanshu sir to address the convention. Sir, please grace us. Sudhanshu sir, please, I invite you to grace the convention, sir.
Thank you. Thanks a lot, Priyanka. It's really great privilege that I am going to join 7th convention of climate change of Gyan Vihar University. Most esteemed chairman, Honorable Shri Sunil Sharma Sahab, convener of the event, all the professors and faculties of Suresh Gyan Vihar University, and more of it, reputed professors of various organizations of the across globe, learned society, participants, media persons, and my dear students. It's really a great occasion, a plegarious moment for me annually when we conduct this event. We have a commitment that Gyan Vihar University will fight, will come ahead with new technologies, will come ahead with the innovations, especially in the field of sustainability and climate change. And the topic of this year's convention, Building Sustainable Society, is really very much relevant towards our goal, towards our commitment with the society. And I'm really thankful for the organizers who have done their best efforts for organizing this event. When in the beginning of this event, I was listening Dr. Suraj that there are more than 1,200 participants. It's really great occasion. It is true that it is because of the technological innovation. Now the world is on one
मैं कर रहा हूँ तो अगर किसी का फोन आ गया तो क्या हुआ? ओए इधर आ.
I think we are facing little technical issues. Sir will be again continuing. So yes, sir. So please continue, sir.
I'm sorry. There was a probably some technical error.
Yes, sir.
I'm continuing again, and I'm really sorry for this disturbance.
No issue, sir.
I'm audible.
Yes, yes, sir.
So I was talking that it's really something great that the organizers of the event, they had done a hard labor, and there are more than 1200 plus participants who have shown their interest to participate into this convention. They have uh, provided a good number of the abstracts, and again we have certain very great professors with us as a keynote speakers. And I have gone through with the literature provided by the organizers that we have a vast areas of the topic where we are going to discuss, we are going to share our knowledge with the other guys. So it's really something great. And through this moment we are going to start our convention. I just want to put this thing before all the participants, all the listeners, that I believe that when we are doing here at India, uh, basically in the current scenario of the world, we understand that in the previous decades or in the previous centuries, when people were not globally aware about the sustainability, most of the westward and countries on the eastern coast of the Pacific, they had attained their development level. And during that time of the development of these countries, we had lost many things. We had disturbed our biosphere, our environment at a very great extent. And after getting the observations of those developmental activities, so-called developmental activities, which Western world and East Coast of Pacific countries has done, we had faced that we are now disturbing the sustainability of the globe. And this new word, this new awareness, this new concern was arise in the past 2 decades. Now this is the time of India. India is now shifting from a developing country to a developed country, and especially the youth of India, they are doing very great, and we are coming like anything. And the major share of the world's growth is now on the shoulders of the India. So this is a really something very important time for the technocrats, for the people who are the student of the sustainability, that this is the time we can not only uh, maintain, we can not only building sustainability, but also we can devise a knowledge, devise a process that how world should move ahead, looking with sustainability things. In the future of the society, like the African countries, undeveloped countries, countries which are still developing, they will learn from India. So this is an important time. People who have already done, now they cannot come behind. US, Korea, Japan, China, and Germany and Britain, they cannot come behind. But we can show a good path. We can show a right way how to move ahead with maintaining the sustainability. This will be something great contribution to the society, great contribution to the world, not only, but this will lead the future generations how they should move ahead, and what method should be there to move ahead. So I believe the role of India is really on the higher side. India have to prove that India has done certain actions. Because of those, we may able to save the biosphere, we may able to save the sustainability and the society. So I wish during the various sessions of this convention, we will not only share our thoughts and views, but we will also try to motivate, we will also try to initiate certain new things which will lead towards development of the new innovations, new technologies, and all other requisite things where we can add something for building sustainability. So I wish my wishes to all the participants, all the keynote speakers, that we will come out after this convention with something new, something great, and we'll try to add some a bit addition to the sustainability. And my best wishes to all of you. Thank you very much.
Thank you, sir. Thank you, Dr. Sudhanshu, sir, for such insightful words in attaining our sustainability and motivating us to go further on. Now, on this thought, I would like to present brief introduction of our Honorable Chairman, Sir Shri Sunil Sharma. Ji. Apart from being a chairman of Gyan Vihar University, he is also the vice president of Satyaswat Samiti and various non-government educational organizations. Despite the fact that, of cumbersome task of administering a busy university, he takes out time for dedicating his time to social commitments, predominantly responsible for the state of Rajasthan. He has emerged as an invaluable and responsible asset of being a rare resource person of value-based ethical leadership. He has predicates of reading, writing, and enormous amount of appetite for reading various disciplines that has made him a virtual potpourri of information covering a wide spectrum of topics ranging from history, economics, metaphysics, Indian philosophy, and Indian Indiology. So on this thought, I would like to invite Honorable Chairman Sir Shri Sunil Sharma to declare the start of 7th Annual International Convention of Climate Change and Water Research with his blessing. Sir, I invite you, sir.
Thank you very much, Honorable Dr. Sudhanshu, whose brainchild is this convention. Honorable delegates from all across the globe, professors, researchers, students, media persons, and dear viewers. Dear viewers, like it's for the climate change is concerned, we have already wasted our very precious time. Like at the initial time, we wasted this thing that whether the climate change or the related things are real or hoax. A lot of people started talking about these things that, okay, as far the climate change is concerned, it's a very natural thing. Reason is being since billions of years. The Mother Earth has faced a lot of glacial and interglacial eras. And the glacial eras does mean when the whole of the Earth is being frozen. And the interglacial era is a bit warmer climatic conditions. So people started talking about one thing that is for the climate change is concerned, the global warming is concerned, that is very natural and that is part of glacial and interglacial cycles. But dear participant, after some contemplation on different forums, especially in the United Nations, we reached on the conclusion that, okay, as for the present climatic conditions are concerned, that is anthropogenic, that is man-made conditions. Reason is being within 4 or 5 decades time, that the climatic conditions are abruptly changing. And never in the history of the earth, such changes got occurred in a such short duration. So now, anyway, now we are at least on this conclusion that, okay, the climatic condition which we are confronting, that is man-made conditions, that is conditions which are made by us. Now, the biggest challenge is this, that whether this beautiful planet, the Mother Earth, can we hand over to our future generation as beautiful as we received from our forefathers? This is the biggest challenge. And this is the point where the sustainability is come. Arise in the center of the picture. But dear participant, the basic problem is that within for the Homo sapiens are concerned, the race which we belongs to, our history of 25,000 years. Like before 25,000 years, the first Homo sapien came on the crust of the earth. But since the first emergence of Homo sapien, we took 25,000 years time to become 1 billion population. Like in 1804, we become 1 billion people. And within 120 years time, somewhere around 120 years time, we become 2 billion people. Like the 1 billion people, the first 1 billion people converted in 25,000 years time. The next billion people added simply in 120 years time. But dear participant, then after you just think about last 32 years time, like last 32, I'm talking simply of last 3 decades time. Within 3 decades time, we have added 2.5 billion people in our population. As for the geographical area of Mother Earth is concerned, that has limitation. It is nowhere it is going to change. But in the population which is being increased, like within 30 years time, we have increased by 2.5 billion people. And that's why the whole problem arises. But unfortunately, when United Nations were developing as SDGs, like the Sustainable Development Goals, that time this most important aspect was left behind. So I think with this convention, certainly we should send our recommendations to the United Nations. So when they develop their next SDGs, like Sustainable Development Goal, the most important thing is to control the population. Unless or until the population is being controlled, whatsoever efforts we are doing, whatsoever contemplations we are doing, whatsoever debate and discussions we are doing, that will convert in vain. That is useless unless and until we really control the population. The most important thing. Dear participant, the another thing which is very much important thing, you once spoke one thing, that if Earth is concerned, it has sufficient power to satiate our needs, but it really can't do anything with our greed. The whole Mother Earth, the whole climatic condition, this beautiful planet is really being succumbed to our greed. Now just think how we are utilizing the resources. How we are utilizing the resources. Believe on me, 1/3 of the food production is getting waste. We are not utilizing it. We are not consuming it in a very rational manner. So 1/3 food product are being waste, and at the same time, 82 crore people, 82 crore people are malnourished. So this is an oxymoron that is for the production of cereals are concerned, we are having more than sufficient food. But what we are doing, the richer people are utilizing those people, those resources very ruthlessly. So now we have to give a communication to the society at large that when they are utilizing the resources Mother Earth is producing, that should be done in a very rational manner. And if that thing is not being done, if we are really keep wasting our resources in such a manner that 1/3 food is being wasted, at the same time 82 crore people are malnourished, they are not being supplied with the proper diet and nutrition. So this is certainly a very unfortunate situation. Dear participant, we have to focus on the poverty elimination. If the poverty is not being eliminated in a perfect manner, there is disparity in the development. There are certain countries, like let's talk about the United States, what they are using, how they are utilizing their resources. Now let's talk about the developed countries, how they are utilizing their resources. And at the same time, in the developing and the underdeveloping countries, still they are not being fed properly, they are not giving proper education, they are not giving proper employment, they are not giving proper shelter, they are not giving proper attires, and they are literally donning like so these things are there, and this should be the basic focal point of any convention, anything. Like if you are not contemplating in all those things, certainly what we are doing, what United Nations are doing. United Nations they have pinpoint 7 uh, goals, 7 sustainable development goals. So now let's talk about those goals. Reasoning the quality education is a basic thing. If we really give a quality education, and especially our fairer sex, that's the gender, and we also focus on this gender equality. If we really succeed to educate our female children's, then believe on me, most of the problem will be solved. We have seen one thing in the state of Kerala, that if the female literacy is concerned, that has direct relation with the population control. So we have to focus on these things. Like gender equality is again very big problem. It's for the planet where we are staying. 1/3 females are being abused, physically abused. Do you really think that the growth which we are talking, that is the really inclusive growth, where 1/3 female population is being physically abused, where more than 82 crore people are malnutrition, where 1/3 population, like the children population, are not looking the doors of good schools and college education. How you think that what sort of development we are doing that is really having that is going to produce a egalitarian society? And if the society is not being going to become egalitarian society whatsoever we are doing, so then that development is insignificant. So with development we will also have to focus inclusive development. Inclusive development does mean the dividend of the development is really being uh, poured down to the last in the line. If the last in the line is not being focused, then what sort of development we are doing, that is useless. Dear participants, another thing which is very much important, that is the water. Like there are certain philosophers who are predicting one thing, who are projecting one thing, that the next world war will be done, will be organized for the water. Water is really being like let's talk about India. Let's talk about India. The most pious river Ganga, that is really being contemplated. And there are certain projections who declare one thing, that within next 2 decades, the most of the glaciers will be dry up due to climate conditions. Just think about one thing. Ganga, which is giving subsistence to more than 500 million people, if that get dry up, what their population will do, how they will sustain in future. So these all things are really very much important thing. And another thing, reason is being, we are living in the era of a pandemic, and that's why we are communicating on this platform. But dear participant, one thing which is very much important, that is the vaccination. Let's talk about the vaccination. Like if we talk about the vaccination of measles, within 20 years time, within last 20 years time, 80% death which used to occur due to measles has got stopped due to vaccination. So we have to focus, the whole human population has to find out different vaccination of different elements. And then again, if those things are being confined for simply for the developed world, what sort of researches are being done in the different university and different labs, that is being done in vain, that is useless. So the main focal point is this: that the whole 7.5 billion people, the population, the whole population of the Mother Earth should be supplied with all these amenity, whether it is education, whether it is vaccination, whether it is quality and potable water, whether it is malnutrition. If we are doing all those things, then only what sort of contemplation we are doing, what sort of contemplation which is being done in the different parliament of the different countries, or in the highest forum of the human contemplation, that is the United Nations, that is useful. So I really congratulate the organizers, and especially Dr. Sudhanshu. Reason is being this great convention is basically brainchild of Dr. Sudhanshu. So I really congratulate that year by year. The reason is being, if you are going to organize any convention in 1 year, there is not that much significant. But year by year, if you are organizing such a successful event, then certainly all accolades, all congratulations goes to you. So I really congratulate the organizers. I really congratulate the participant, and I'm very much confident about one thing, that these sessions, the session which you are going to organize either today or tomorrow, that will be approved a turning point for all of you. With this note, I declare this convention open. Thank you very much.
Thank you, sir. Thank you for such insightful words in attaining sustainability through the, controlling population, poverty, needs, and various socio-cultural and economic approaches that you have shown us the path that we can go forward with. Thank you for your blessings and motivation, sir. Now, on this note, I would like to invite all the dignitaries for the release of the C3W Abstract Journal. So this is the virtual release of our abstract journal of 7th Annual International Convention Climate Change and Water Research, Sustainability in Current Scenario, Challenges and Solutions 2020. So taking forward of the courses of this convention, it is time to take forward with our technical session. So these are the abstracts, and they were these are the selected abstracts that had been published. Thank you. Thank you, sir. Sir, I seek permission to take the session forward, sir, for the technical session. Okay.
Yes.
So, taking forward the course of our convention, it is time to introduce our first keynote speaker of the day, Dr. Prakash Singh. He did his master's in environmental science and ecology from Purvanchal University, MTech, and he did his MTech in remote sensing from BIT Mishra and doctorate in environmental science from HNGU Patan. He joined Space Application Center SAC ISRO Ahmedabad in the year 2002 and is currently a scientist in biological and planetary science and application group of SAC. He played key role in various prestigious projects related to satellite remote sensing application in the field of environment, ecology and forestry. A first of its kind Himalayan Alpine Dynamic Research Initiative for a long-term ecological monitoring in Indian Himalayas has been established under his leadership. He has presented India in various international forums. He was part of a recent 39th Indian scientific expedition to Antarctica conducted in the year 2019 to 2020. He has also credited with more than 100 publications, out of which 40 of his publications are in peer-reviewed journals and book chapters. He is active member of many professional societies, including Indian Space Science Congress Association, Indian Society of Geomatics, Indian Society of Remote Sensing, Indian National Cartographic Association, Indian Linkology Society, Meteorology Society, Astronomical Society of India, and Indian Society of System and Science and Engineering. Now, on this thought, I would like to invite our first keynote speaker, Dr. Prakash Singh. Sir, please grace us.
Thank you, Priyanka, for introduction. Can somebody make me the presenter?
So you can share this screen, sir.
Just a minute, sir. Just a minute.
Yeah, thank you.
Yes, sir. Now you can share, sir.
Hope my slides are visible. Yeah, slides are visible. My presentation is visible to all of you?
Sir, not yet.
No, not yet.
Okay.
Sometimes it takes some time.
Yeah. Yes, sir. It's coming. It's visible.
Okay.
It's visible.
Thank you. And thank you, Priyanka, once again for introducing me. And before I start, I want to thank Dr. Sudhanshu, Dr. Sunil Sharma, Dr. Shruti Kanga, Dr. Suraj, and all senior delegates, speakers, presenters, and students who are joining today to deliberate on the very most important topic of sustainable development and climate change. I'm thankful to organizers of Suresh Gyan Bihar University, especially Dr. Suraj, for inviting me to this convention on climate change and water, popularly known as C3W. And I'm happy to know that this is the 7th year for this particular symposium, and it should grow and continue, and it should widen its base. And I'm happy to see that it's happening, and large number of participants are already there. I wish this virtual conference or convention a great success, and hope that people will share their experiences and research findings on all aspects related to sustainable development, climate change, natural resource management, and disaster risk management, all these important topics. And I'm thankful to Dr. Sunil Sharma and Sudhanshu ji for making my job easy. I don't need to give a lot of introduction or importance of sustainability and climate change importance per se. And since this particular topic that has been allotted to me, that is remote sensing for biodiversity and habitat modeling, this is very wide topic. If you see, each keyword can take a day for deliberations. So what I will do, I'll skip some of the introductory things about remote sensing. I think there are experts already available in this panel, which will be during the course of time, they will be talking about remote sensing per se and geoinformatics. So what I will do, I'll talk more on biodiversity and habitat modeling, how remote sensing can help us. And I'll showcase some of the case studies. I won't give you a wide literature available on these subjects, but I will showcase what exactly we have done in last 1 to 2 decades. So let's go ahead. But before we move ahead, we should just touch upon these particular keywords. Though all of us are aware about it, it's important to brush up some of the key terms like biodiversity, habitat, ecosystem, which I'll be talking about all through my presentation. So biodiversity, what is biodiversity? Biodiversity is variety and variability of life on Earth. Basically, wherever if you go, but the scales can differ. Look, like it can go from genetic level to species level to ecosystem level, and wherever the variability is found, wherever the variety of flora and fauna at various scales are found, that is basically known as biodiversity. Okay, so per unit area, how many number of species or variabilities are existing? So there are a lot of indices to compute biodiversity, like Shannon Index, and many such ecological indices are there. Okay, coming to the next topic, next keyword, that is habitat. Habitat is a type of natural environment in which particular species can thrive and sustain its life. So habitat is a kind of envelope, which provide support for the life. So that is called habitat. So you can see that aquatic habitats are there, deserts, forests, grasslands. And then when we talk about ecosystem, the same thing is there. Only difference is there that we talk about the biotic and abiotic interaction of the environment as well. And then we talk about ecosystem. And when we talk about ecosystem management, means we are talking about all the elements of ecosystem, whether it is abiotic or biotic, its environment, its nutrients, and all the elements of the environment. So just to recapitulate on the scales of these particular things, when we mention species, this is the finest scale at which we are talking about, where a particular species of whether it's a grass or it's in terms of biodiversity, whether it is even you can say the microbes, those are also species. And it's a very finer level of scale when we talk about the biodiversity. And then when the species numbers are more, it makes population, and then particular population of various species can form a community. And then when various communities are thriving at a particular place, which is enveloped in a particular environment, then it becomes an ecosystem. And when we try to see ecosystem or ecosystems in a holistic way, let's say for a structurally distinct geographic space, which can be a kilometer wide, then it becomes landscape. And then biome is for the larger area where climatic, edaphic, and other factors are also counted there. And then biosphere is the limited zone on the Earth which supports life. So these scales are important when we talk about monitoring from remote sensing perspective, what we want to monitor, right? So somebody says the species level classification can be done through remote sensing, then you need to visualize the scale at which you are talking about. Coming to the remote sensing again, and talking about adding to one more element, that is time. So when we observe certain phenomena or thing in environment, there are two dimensions, okay? One is the spatial scale at which you are trying to observe a phenomena or features, and then second is the time, what time you are observing and how frequently you are observing a particular phenomena. So that becomes important as well. So as you can see in this view graph, you can monitor things at canopy level, to landscape level, to regional level, and to global level. And from this view, you can see that there are certain satellites which can observe very frequently, and every day you can get global pictures. But there are certain satellites which can give you very coarse level or medium coarse level resolutions, and which is good for observing things at regional level. And there are certain satellites like ResourceSat, LIS3 cameras are there which can observe things at landscape level as well. And then you have certain satellites which are capable of observing things at sub-meter level. And then you can talk about even if it is having capability of observing things at very hyperspectral level, then you can think of classifying things at species level. And it becomes important to know the time temporal resolution as well, because the vegetations or the phenomena or the ecosystems are dynamic in nature. If you are observing a pond ecosystem during a period when there is a drought, probably you may not be able to do justice to that particular pond ecosystem. And then same way it may happen that forest, if you're trying to observe during leafless season, that is the senescence period, you may miss to observe the forest in its healthy conditions, or you can say in full vigor, and you may miss those parameters which could have been helpful to classify it at species level. So that's the message from this slide. And when we try to relate certain aspects observed on the ground to remote sensing, then we should be having tools and techniques ready with us in terms of translating the ground information to the spatial scales. Okay, so for that also you need to observe things in totality in terms of its time temporal resolution and spatial resolutions as well. So you need to have plots designed in such a way that it can be translated back, or whatever parameters you are trying to retrieve using remote sensing data, that should be translated back. And for that you need to do a lot of modeling efforts needs to be done, whether it is in terms of additive transfer models or ecosystem models, which can be translated back. For example, if I say leaf area index on the ground, it may appear different, but if you're talking about remote sensing based LAI, that will give you a landscape level or a plot level information. So that has to be aggregated. The ground level information has to be aggregated. So how you can aggregate, that's a important research element these days, and people work on that. There are many other such ecosystem parameters, whether it is related to tree height, leaf area index, or the vegetation indices, the health indices. All these things becomes very important when we try to extrapolate information from the ground to remote sensing based information. So these are some of the list of applications in forest ecosystem management, which some of these are being operationally done these days because remote sensing has come a long way now in the country and in the world. And so area under the forest and tree cover is operationally being monitored by Forest Survey of India, Dehradun, where even the crown cover density class of forests are being monitored. Forest type, vegetation type mapping has been done in the country. Forest monitoring for reforestation, deforestation, and encroachments are being done. There are certain systems which are even giving us alarms whenever some forest cutting or degradation is happening. Alarm is set, and people are informed. Concerned people are informed, and management is informed about these changes. And on the ground, it is being checked whether it is because of some kind of encroachment or official cutting has happened. Sampling frame for growing stock and tree outside forest assessment are being done nowadays because of availability of remote sensing data at a higher spatial resolution. Forest biodiversity at landscape level, there was a project which was done a couple of decades ago, and this project has given us impetus on information about the country. We have done assessment of biodiversity at landscape level, how in the country, what is the status of it, and some information is available at BIS portal as well, and one can register there and get the information about the country biodiversity at landscape level, which was done using remote sensing. Then there are certain elements of disturbances to our ecosystem, for example, forest fire, pest and diseases. So all these information also can be very well monitored using remote sensing. Wildlife management inputs can be given using remote sensing parameters. Why remote sensing is important for wildlife management? Because it can give you synaptic coverage of the habitat in which a particular wildlife is supported. And watershed development, action plans and monitoring can be done. Biomass mapping and carbon assessment these days very important for negotiating your climate change footprint with the countries. And biodiversity conservation as well. As you are aware, you may be aware that we are losing almost 1 to 5 species per year. So it's very alarming, and every species in the ecosystem is having its role to play. And as we are losing species one by one, we are going into great danger. And habitat loss is the prime reason for these kind of species loss, where we are due to population explosion, as Shri Sharma ji was saying, that habitat loss is mainly due to deforestation, overpopulation, and pollution and global warming. And climate change is also because of our anthropogenic activities. We are becoming a major driver for change, and that's why the habitat destruction or fragmentation is happening. And why fragmentation is very important, and fragmentation can be noticed using remote sensing data. And fragmentation is the most important thing to be monitored in natural ecosystem. If you see in this view graph, particularly intact patch of ecosystem may look like this, where a contiguous patch of forest or vegetation or pond ecosystem is there, where suddenly due to anthropogenic disturbances or encroachments, you can start seeing that the particular intact forest is now getting fragmented. So lowest to highest level of fragmentation, and here the chances in highest level of fragmentation, there are chances that you will lose a lot of species, and you can't be having sustainable forestry happening here. And there is another parameter in ecosystem that is known as porosity. So within the same patch of forest, if there are holes, again, it's not fragmented, but inside it, there are a lot of pores which are available, and that is also creating problems. And these kind of problems will happen because you will not get corridor for the movement of the animals. And if any human activity is happening along these lines, there can be human and man and animal conflict happening here. So these are the problems for the species loss. There are many species which are getting lost because of these conflicts, and we are even losing a lot of human lives because of these conflicts. So to avoid these conflicts, we need to think about the corridors, and where remote sensing and geospatial technology can help us in giving us scientific clues from which places to which places can be connected very well. And a development plan should be made accordingly. So as I was saying, biodiversity characterization at landscape level was done a decade ago. There are maps available, data available on which further people can work upon and create corridors using these kind of data sets. Further, if we talk about the habitat status mapping, there are many segments in which remote sensing can give inputs, as well as it's already giving, in fact, in some or other way. Like carbon management, there are a lot of satellites which have come up these days for giving us assessment about the carbon in terms of biomass. Like JEDI is there nowadays, the biomass satellite is there. And then I said glass LiDAR is there. Many SAR sensors are, L-band sensors are being designed. ISR from ISRO and NASA is being made, which will be giving us assessment for the biomass and carbon information. Invasive species can be mapped using hypertemporal informations. Pollution is already being monitored with the satellites which are sensitive for the particular pollutants and gases. Disaster monitoring is being done, which is also natural and human-made disasters, which are being monitored using remote sensing satellite data. Water management, very useful for through remote sensing. Biodiversity loss is being monitored. Meteorological applications are being done through remote sensing. There are a lot of climate change informations like indicators of climate change and impact of climate change is also being monitored using remote sensing. We can do energy flux modeling, wildlife monitoring, coastal management, and ecological forecasting as well. So what I'll do, uh, just to show you that we are talking about India per se, if about the management of the habitats and ecosystems, you can see that very vast natural ecosystems are available in India itself, where from alpine ecosystem, snow ecosystem, desert, crop, mangroves, forest to plateau ecosystem to grasslands to corals, whatnot. Everything is available in India, and it's a very complex ecosystem, and it's a challenge for the natural resource management people to see that these complex interplays and finding the drivers, factors of these changes, and giving particular solutions to stop these kind of degradations into these kind of ecosystems. And some of these ecosystems are very fragile, and we need to especially take care of them because of non-resilient nature of these ecosystems. We need to especially take care of them, otherwise we'll be losing a lot of biodiversity from this planet. So what I'll do, I'll touch upon some of the case studies which we have done, and I'll rush through because the time is also less for you people. Other speakers are going to speak. So what I'll do, I'll talk more in detail about the alpine ecosystem, some of the phenological components, forest fire as a disturbance to the ecosystem, how we can monitor the forest health, and some of the ecosystem products as an example, and some of the concept of biodiversity mapping, which is like upcoming concepts, and then wildlife habitat monitoring. I'll just showcase some of the studies. And so starting with alpine ecosystem, this is my pet project where I've been working for almost 8 years. And why alpine ecosystem is important? Because they are the life zones which are temperature sensitive. In fact, these alpine ecosystems are limited by temperature. If we global warming is more and more there for a long time, you will find that alpine ecosystems will be actually benefited. They will be growing more and more. But in terms of benefited means it's growing in terms of area, but you may be losing a lot of specialized species which are thriving at the, you can say, at the niche area where other warm temperature loving plants are not coming. So though they may come, and there can be summit trap phenomena in the mountains, and we may lose those kind of species which are very specialized and in less in number. So that kind of loss of biodiversity can be there. However, the area, green area may increase. So there is a trade-off. You should think about both the things. And these alpine ecosystem, why we started studying? Because this is kind of a natural laboratory to understand impact of climate change. And initially through remote sensing, we proved that tree line has shifted upward in terms of elevation. And we started further investigating upon it and trying to prove this particular phenomena which is happening there from various other angles. Okay. And we also found that if we try to model using future climatic model simulations, if we try to do, we again find that the similar kind of trends are coming. So we started further investigating. It becomes very exciting, and we started filing our hand for and prove that these dynamics are happening, and in response to the global warming. This is the Himadri thing, which in my introduction, Priyanka was saying. This is Himalayan Alpine Dynamics Research Initiative, which we started in 2013 now from SAC, and then we partnered with many institutions which are working on the ground. And we have a great team since 2013. We are working in phase 2 now. And as you can see, we are having monitoring stations all across the Himalaya. And we have permanent stations. Those are called LTERs, that is long-term ecological record sites, where we are monitoring in situ informations of these plants, as well as some of the parameters which are important for the growth of alpine plants, like soil temperature. And then we are observing these biodiversity as well as the movement and changes in this biodiversity at the ground level using the multi-summit approach, which was defined by Gloria. We have adopted that, and we are using it so that our data also becomes comparable globally. So these are the sites which is powered by temperature logger, as well as some places we are having phenocams, and phenocams are also giving us important information, like this year rhododendron flowering has not happened. So why it has not happened, we are trying to investigate that. Okay, so this is the kind of setting that we do. We go to the summit top, and from there we lay a plot, or you can say the contour at 5-meter interval, and then we lay the plots for monitoring, and then we dig soil temperature logger, and that's it. And then every year you have to go and monitor whether the biodiversity in these plots have changed or not, and what about the temperature, whether the temperature is going up or no, not. That can be monitored. So we have recently concluded from our long-term study that yes, thermophilization is happening. The plant species which are thriving below in the warmer conditions, thermophilic plants are going up into the cryophilic areas, and they are replacing them. So we are losing some of the species. We can confirm it in coming years whether we have lost them permanently or not. Coming to the new concept of spectral biodiversity, as you know, I was saying in the beginning that there are a lot of indices for monitoring biodiversity, like Shannon-Wiener. Shannon-Wiener is nothing but an entropy equation, right? So that entropy equation can be applied in physics, any other phenomena. Similarly, if you talk about the spectral biodiversity here, the concept is a little different. What we do, we try to see each and every band as a one end member, and try to see them as a species in terms of, so we are taking in 3 dimension, the number of bands, as well as on the ground, the pixels, how they are varying. So you can define a kernel size and move this entropy equation to generate Shannon equivalent indices, and you can compute really the spectral biodiversity. But we have found, we have tried to compare with the ground biodiversity information and the spectral biodiversity, and we have found and concluded that number of bands and spatial resolution play an important role. So you should have more number of bands as possible as for deducing the unique spectral biodiversity, and especially also to be ground comparable, you should have highest possible spatial resolutions. So these are important, and for landscape level monitoring, regional level biodiversity, spectral biodiversity monitoring, these tools and techniques can be used. And further, coming to my alpine ecosystem response, in future, we try to do modeling using IPCC scenarios, and we found that yes, again, it was indicating that you can see the eastern Himalayan region is going to have more changes in terms of alpine ecosystem going up in mountains. And we have started observing such signals early on the ground as well. And then we thought of going back in past and see whether the key species of alpine tree line, which is nothing but the Betula utilis, which is also known as Bhojpatra. In our Sanskrit scriptures, you must have known about the Bhojpatra, on which people used to, the bark of which used to be used for writing ancient scriptures. So that particular tree is available, and it's a leading tree line species in India. And we have found that the Betula utilis in the last interglacial period was much below. In current situations, now it has gone up to 3,800 to 4,000 meter, and in future it may again go up, and it may reach up to 4,400 meter. So that kind of scenarios we have generated, and it has been recently published. Similar thing is happening for the apple. Apple is also a species, you can say it's an orchard. Apple orchards are there in Himachal and Jammu Kashmir, and they're also facing problem in terms of production now because of the global warming, because particularly the chilling unit which is required for ripening of the fruits, that is not getting available in the orchards which were earlier giving good fruit quality. So now the farmers are moving upward. They are getting chilling units in the higher altitude than the current ones. So this is also published recently. Further, what we have done, we have designed a framework for observing the alpine ecosystem from various scales, So Earth observations and landscape level observations and in situ observations. I gave you a lot of clues that what kind of in situ observations we are doing, but you can also see that we are trying to do a lot of experiments on the ground in terms of climate change scenario, what will happen to the plants which are native to that place. So you may be aware that in mountainous region, when you go, you find that the air is very thin. Even you start getting problems like breathings and things like that because oxygen is less and less. Similarly, other gases are less because the atmosphere is basically thin. But now due to these, because these gases are very well mixed, you must have seen that this carbon dioxide concentration has crossed to 400 ppm, and the same ppm you will observe in the mountains as well now. So basically what is happening in the mountains, the carbon dioxide enrichment is happening. So if I assume in IPCC scenarios, like let's say if this carbon dioxide concentration can become 600, a priori, if you want to know what will happen to the physiology of the alpine plants, what kind of experiment you can do. So that experiment is called open top chamber experiment. So you can set up a chamber where you can keep on feeding CO2 at an elevated level and see the response of the plants for 1 or 2 years, and then see what kind of physiological changes are happening. And then especially you can model such changes once you get the clue from these kind of experiments. So we are doing such experiment in Tungnath, which is having high altitude plant physiology research center. In collaboration with them, we are trying to do such kind of experiments. We have in fact done quite a bit. We have made headway on some of the plants. And now in this year, we are planning to do a lot of in situ experiments like photosynthesis, leaf nitrogen concentration, chlorophyll A, B, xanthophyll concentration along this mountain range. So from let's say 2,500 meter elevation to 3,500 meter elevations, what are the changes which are happening? So what kind of stress conditions these plants are facing, and how they will behave in future. Similarly, how their physiognomic conditions will change. When I talk about physiognomic conditions, means their appearances, how they will start growing in a different way, apart from their physiological changes, how the you can say the outer changes will look like. So that kind of modeling and 3D modeling we are trying to do. We are trying to understand how that particular landscape will look like in future. Okay, so and there are many tools available nowadays for landscape level observations like phenocams. We have installed a couple of phenocams through which we are observing these changes happening every year, and in long term it will be very helpful to deduce the drivers of the changes. The biomass, the information like terrain laser scanners are available these days, which will give you information at the leaf level to the branch level. You can generate information like extinction coefficient of the light when it is coming from the sun, reaching to the ground, how much light can reach. So these kind of detailed information you can compute from the terrain laser scanner, apart from the tree height, CBH, DBH, clumping factors, leaf area index, canopy area index, and all those things. And there are thermal cameras available these days, which we are having. We are trying to use for thermal mapping, how these gradients are thermally distinct from each other and why they are behaving differently because of the thermal regimes that can be monitored. Then hyperspectral images, UAV based monitoring can be done, because these mountain regions are sometimes, if you go for trekking and then you may not be able to go to the nearest peak possible because of the gorge available there. It's very deep gorge is there, so you can't go there. So it's better to have a UAV in the field and just map that area, come with the information and do the analysis. So Earth observation, UAV based observations, that is all possible these days, and we should be harnessing these technologies and tools to get more and more information about our habitat and ecosystems, and particularly those ecosystems which are very fragile. So this kind of, I'll not go into details of science of defining such kind of protocols, but just to give you a message that we need to design very scientific protocols if we want to answer questions related to climate change, because climate change impacts can be seen only when you have a proper design, and you should have a kind of design which can give you a particular answer to the particular problem in your mind. Coming to the disturbances, that ecosystem level disturbances which can come up, that is, one is forest fire, in which I'm working very actively these days. I'm responsible for making algorithm also for active forest fire detection. When we talk about remote sensing in general, what kind of applications can be done? For students, this is I'm just trying to give clues to you if you're interested in this particular phenomena. There are a lot of opportunity for doing research is there, like not only detection and monitoring of active fires. You can do assessment of burnt area, how much scar has been there. So area burnt versus what was the temperature of the fire. So that kind of thermal modeling can be done. Estimation of combusted biomass carbon. So if you know the a priori the parameters of the forest, like specific gravity of the wood and the type of wood which was available, you can even compute gas emission from the fires, how much gases have liberated and what kind of you can say heat was generated around, and even people can do ecosystem modeling, that how much microbial biomass you have lost or what kind of ecosystem changes has happened. Even estimation of forest fuel load for generating risk map for the forest fire is also a very active area of research where people are contributing a lot using both optical as well as microwave remote sensing data. And of course, ecological impact analysis can be done. So I'll just give you an example of INSET 3D. Very few people may be aware that INSET 3D, which is a meteorological satellite of India, and 3DR is also capable of giving information on forest fire at large level, at coastal level, compared to the MODIS and VIRS. As you may be aware that MODIS is a workhorse for the world. It's giving information on the forest fire all across the world, and any place there are 4 passes are available in India also put together, Terra and Aqua satellites. But the problem with the MODIS is it can't give you in between. So in between you are, apart from the 4 passes, you are missing those fires which are short-lived fires. And you don't have information whether a particular fire which was detected by Terra is still on, or it has been curbed, or it has been managed. So INSET 3D, the power is, it is hypertemporal. Put together INSET 3D and 3DR in a separated mod, 15-minute interval, you can monitor forest fire, because it is a geostationary. All the time it is looking at the 1/3 of the Earth. India is centered around that. So every time, every 15 minutes, you are observing whatever is happening can be captured very fast. So I call it hypertemporal monitoring of forest fire. The only problem with this monitoring is it has a very coarse resolution data, like 4 kilometer, as compared to MODIS, 4 times more. So, but still, it is very useful in this case. In Uttarakhand, we found that it was sometimes, better than the MODIS, because some of the fires which was missed by MODIS was captured by INSET 3D. But also it has problems like smaller fires, which is the case mostly in India, because all the fires are not as big as California fires. So you may miss some of the fires in INSET 3D. But yes, we can do improvements in next satellites, and with the better configurations, with better sensitivity of the bands, we can curb these problems, and we can come up with the systems which are more capable. And this is just an example of showcasing like Jammu Kashmir fire, Bandipur forest fire, and Uttarakhand forest fire, how well it was captured by all 3 satellites and how they are different from each other. It's a good case study for doing geospatial analytics of what kind of bands configuration and what kind of sensitivity can lead to what kind of detection of active fires. So if some of you are interested to see the forest fire results from INSET 3D, you can go to the mosdec.gov.in live, which will keep on giving you information about the forest fire, whichever is detected. Sometimes you may feel like, in this particular season, why a fire is being shown in this particular region. In some cases, it can be false fire, but in most of the cases, it may be fire because fires are decidedly anthropogenic in nature. 90%, more than 95% fires in India is anthropogenic in nature. And it has been, again, proved in this pandemic situation when people were locked down, the number of fires were brought down very drastically. This is a new concept which we have just tried to research upon, is pyroecology, using the concept of active forest fire detection. As you can see, the forest fire detected by all 3 satellites. As I was mentioning, INSET 3D at 4 kilometer resolution, MODIS at 1 kilometer resolution, and SOMI and PPVIRs at 375 meter. All the satellites, if I try to see from the habitat heterogeneity index, habitat heterogeneity index is nothing but Shannon-Wiener index, which was computed by scientists, and the data was published. So I've used that data for the entire India and try to see that each fire, whichever has happened, what kind of habitat heterogeneity index or Shannon index is there in that particular fire, and try to plot that. And it's a very interesting information. All the satellites are giving the same curve, and that denotes that if you have Shannon index of around, you can say 2.2, then after that the forest fire drastically comes down. So this is the inflection point at which 2.2 Shannon comes. And if you have, so this gives a message in a way that if you have biodiversity, more biodiversity in an area, you are less likely to have forest fire. And it looks logical because the fire breaks can happen because of the presence of the new kind of species. So if you have only eucalyptus plantations or teak plantation or pine plantation, it will, if it catches fire, it will catch fire in all the forest areas. But if you have forest break in the form of the fire resistant tree species, it will be stopped there. So it looks logical that if you attain biodiversity index of 2.2, so it's a good message for the forest managers that they should go for mixed plantation than the monocultures. Sorry, anybody wants to say anything?
No, sir, continue.
So please continue, sir.
Okay, thank you. Okay, so there is another aspect of forest fire. We can do monitoring of forest fire risk as well, using static as well as the dynamic factors which are responsible for the forest fire. And we can alert the forest departments for managing the area, or informing people well in advance that this particular forest patch is very risky for forest fire. So people should not do unwanted activities like throwing the cigarette butts or partying and then not curbing the fire before they leave. So this kind of information is important, and where the topographic information, meteorological information is put together can be used very well. And we have demonstrated for an area in Kanha National Park, and then we have shown that this kind of methods works very nicely. Full load characterizations using hyperspectral data has been done. So you can think about doing it the same way from the microwave satellite data also, because microwave satellites, as you may be aware, they are very sensitive to the dielectric behavior, and dielectric constant of the water is highest, and presence of water means fire, chances of fire will be less. So dryness can be computed very nicely with the microwave data, and that can also act as a nice tool to compute forest fuel load. Only thing is that in India, what is happening? The surface fires are more. Canopy fires are, you can say, the top canopy is never burning most of the time because the cigarette butts are thrown on the surface and then leads the forest floor because of the presence of the fuel. And if moisture is more, that means the chances of lighting the fire is less and less. But in terms of remote sensing, what you're observing, if you're having C-band microwave data, only you can observe at the canopy level. You can't penetrate to the ground level. So you need to have L-band data, which can penetrate L-band or P-band data, which can penetrate on the ground and see the moisture conditions of the floor. So it becomes very important to choose a particular band for doing a particular method of mapping or particular phenomena to be monitored. This is another element where habitat parameters as you can see, can be monitored. It's a dynamic habitat parameter, that is phenology. Many things are depending on this phenological behavior of the forest. Even for the flora and the fauna, they depend on the nutrient release and many other factors for based on the phenology itself. So we have taken a very ambitious project now for monitoring the entire India's forest phenology using remote sensing, and phenological products will be computed in later times. And a lot of science aspects is also inbuilt using the sensors which are computing soil temperature, soil moisture, air temperature, humidity, canopy height, level, power, rainfall, and other parameters, which can be embedded into your models to forecast the phenology in future. Once you're able to get a phenomet model for the phenological product, you can forecast in future what will happen to the leaf fall situations. So basically in phenological curve parallels, if you see this curve in climate change scenario, what is going to happen for this phenological curve? You just try to concentrate on one curve, and what can happen, either it can shift. The curve, the shape of the curve is same, and it can just shift leftward or rightward in terms of its time temporal shift. But in sometimes in some forests, the curve may shrink. Okay, so the total growing degree itself may be very less now, or it can expand also. So all these situations can be observed in climate change parallels. If you have, you can say you can have handle, if you have handle of forecasting the phenology. So for getting that kind of handle, we are trying to do a lot of scientific research in this direction, where start of the season, maximum of the season, end of the season, and length of the season can be predicted and monitored using remote sensing and geospatial modeling techniques. So in this validation and calibration can be done for such products using phenocams. So phenocams can give you information like this. Every day, one pictures can be taken, and you can monitor 365 days monitoring can be done for using the phenocams. Whereas satellites can give you maybe not daily, so at least weekly kind of data sets. So that kind of extrapolations you can do, and from the ground to the satellite level. This is for a species level phenology. If you have very high resolution data and if you are able to map for a species, you can very well understand from the hyperspectral data that what is the status of the phenology on the ground. Forest health can be monitored using various indices which are sensitive to carotenoid and chlorophyll A and B and other stress factors like water. This is a newer dimension of monitoring, basically the photosynthesis using fluorescence techniques. You may be aware about NDVI, Normalized Difference Vegetation Index, which is sensitive to based on the basically the near infrared and red band contrast. Okay, but that is not very accurate in terms of whether the plants are doing photosynthesis or not. It can give you whether the plant is green or not, but it can't give you guarantee that photosynthesis is happening and it is not under stress. So chlorophyll fluorescence, that is solar induced fluorescence techniques are coming into place, and it is being promised that it can give us better results in terms of whether the photosynthesis is happening properly or not. And we can do you can say the gross primary productivity estimation of the forest ecosystem. This is one example how we have done using advanced wide field sensors, and we have computed for India around 2.40 gram carbon per meter square per day kind of a GPP estimate have been done. This is basically based on the the light use efficiency model. And this is another way of getting to know about the net primary productivity of the forest ecosystems using the large integral approach of the phenological curve. So here you can see the phenological curve itself is there. So basically this is demonstrating the growth of the plant. Okay, so from this is the maximum growth, and after that it is going down, and then leaf senescence is happening. What is happening in between? This area under the curve is nothing but the accumulation of the you can say the carbohydrate in the system. So this is giving us the net primary productivity. So if you can get handle on this large integral of this growing curve, you can compute NPP from the curve itself. But there are other techniques like process-based models are there, which can be used for doing the net primary production estimations as well, and global estimations as well can be done. Biomass mapping using microwave satellite data can be done. Coral reef macroalgae species level classification can be done, though it is a little opportunistic because corals are generally submerged, but during low tide conditions, you can do mapping and you can compute macroalgae species, which are very medicinally important sometimes, and this is catching a lot on pharma companies. Coral bleaching alerts are very sensitive. Less degree of change in the temperature itself can play havoc in terms of the health of the corals, and such bleaching alerts are being made. SAC has also made one such system. Mangrove monitoring, it's a very ambitious project where country level mangrove mapping at 1:25,000 scale is being done. Not only the mangrove mapping, but the health of the mangrove is being monitored. Stress detection is being done. Wetlands are, as a component of the habitat, are being managed and mapped through remote sensing technology nowadays. Ministry of MOEF NCC has a very ambitious project through ISRO for mapping all the wetlands of the country, and they are being used for management purposes in terms of notifying them for around them no development can happen. So now it will become a norm for future that wetlands should be conserved and they should not be filled up and for the constructions and things like that. If some of you are interested in doing vegetation modeling or phenological kind of modeling, there is an online tool available nowadays with SAC, that is a Vedas platform is there, vedas.sac.gov.in. You can go there and you can play with the data. You can do a lot of online computations and you can get the results. You can download and use it in your dissertations using WebGIS based functions available. Now, the last topic of my today's talk on the wildlife management, remote sensing use. Since we are talking about the habitat and ecosystem management, a lot of things can be done using remote sensing, like habitat suitability analysis, monitoring vegetation status of the national parks, carrying capacity analysis, which is very important because the number of animals that you are having in a national park, whether the grasslands are having enough carrying capacity for them. So that kind of analysis can be done using remote sensing. Remote sensing inputs for the national parks, wildlife conservations, their management plans, we can improve using them. Monitoring corridors for the wildlife migration can be done. So there's a lot of modeling components available, and I'll just give you a few examples, case studies which we have done, like habitat mapping for the grassland integration. In Kanha National Park, what was the case happening? Being a national park, you can't touch a single tree there, but the woody trees are were ingressing in the grasslands, and grassland is an important component of the Kanha National Park because of availability of the large amount of herbivores like deers, barasingas, and these woody plants are encroaching the grasslands, means the carrying capacity of the Kanha National Park for the herbivores is getting declined. So we needed to prove scientifically that it has happened, this phenomena has happened, and government should allow them to increase the carrying capacity of the grasslands through cutting of the woody trees. There was another important thing which we did was habitat modeling for barasinga in Kanha National Park. You may be aware that this particular species, which is known as subspecies, which is known as Rucervus duoceli branderi, this is the only species which is living on this planet in Kanha National Park only. If it is eradicated from this place, we will lose this species from the ground, from the earth. So what the management wanted us to search for another area where this animal can thrive. And for that, what we did niche modeling using genetic algorithms, climate space models. Basically, we used, you can say, the machine learning algorithms for testifying that which area can be good for these particular animals based on its current record and past records. So for past records, we searched and we found that Scheller 1967 published one map which showed that the barasinga used to be available on these places in various years. So we use these places and association of these places with the various ecosystems, and try to model for the current, and we found that it is matching very well. Now the only thing was that those ecosystems which were available in 1960 are no more available. Now most of the things have become croplands. So we need to do the corrections using present land use, and we did those corrections, and finally we brought out this map and suggested them that they can take up these animals, and it's a very successful story of the ecosystem modeling approaches using remote sensing. Now actually these animals are having second home in Satpura Tiger Reserve, and they are thriving there. So if anything happens to the Kanha population, at least we have second gene pool where it can be saved. So we won't be losing so soon. There is another animal which was earlier not seen in MP, but there was one spotting happening. They wanted us to show another area where they can be spotted, because random sighting cannot be done in the national parks. Very few people are employed in, they can't be roaming all the places. So we did this modeling, and we inform them through a map that these are the places where likelihood of this particular animal can be there. In this particular exercise, we also used ISET class LiDAR data, where tree height information from remote sensing was directly used. Why I'm saying this, that you should be, when you're using a particular technique, you should understand the demand of the subject. In this particular thing, this particular animal is arboreal animal. When I say arboreal animal, means it is living on height, and it is basically living on the tree height. A height of the tree should be more than, you can say, the 20 feet or so. So because it don't want to get predated by those nocturnal animals which are living on the forest floors. So the ISET LiDAR data was used, and we also had information which is very pertinent for this particular animal. And we, you can say, with the 90% accuracy, we could predict that these are the areas where these animals can be sighted. And they did a combing operation, and they found many drays, or you can say the nest of the animal, and many sighting also happened. Recently, we have done a landscape connectivity, like corridor mapping activity for sloth bear in Gujarat, using remote sensing and ecological modeling techniques. When we talk about forestry, in which direction the remote sensing is going? So basically, it's going into the third dimension. 3D forestry is happening. On the ground also, we have terrain laser scanners, and from satellites, like from ISS, International Space Station, also there is a platform sensor which is called JEDI, which is also operating and giving us beautiful information about the tree height and things like that. This is an example of the Tungnath area where we have done surveys, and this is the picture of that particular area. LiDAR can give us three-dimensional information about the trees, and this is the example of JEDI, which is having 25-meter footprint, and the spacing of 60 meter, and across track 600 meter is there. So using this data, you can do interpolation, and tree height information can be gathered. We are working on this data nowadays. This is the last topic I'm trying to touch, because initially I said lichenology is very important for climate change perspective. Why it is important? Because if you're going for doing carbon dating, the errors can be of how much? 500 years. But if you want to see the climate change impacts, you have to talk about long term also, and less than 500 years, then you have to rely on such techniques which are giving you better results in alpine ecosystems. So what is happening? Alpine ecosystem, we find these lichens growing. These are basically, the lichens are algae and fungi symbiosis relationship. Okay, so lichen is nothing but algae plus fungi, and the thallus grows on the rocks. It grows on the tree barks. Wherever undisturbed areas are there, it can grow. So glaciers movement can be monitored using them, because the glaciers, wherever there, if you go down below in the transect, you'll find the lichen thallus are increasing in terms of its diameter. So if you can monitor the diameter, and the growth rates are known, like 0.2 millimeter per year, so you can actually compute that when this particular rock or substrate was open from the glacier. So you just walk through the up to the glacier, and you can know that what is the rate of the retreat of the glacier. And rate of the retreat of the glacier is also linked to the rate of changes happening in the alpine ecosystem in terms of the alpine tree line ecotone changes. So we have done such kind of exercises, and we are also trying to map lichens wherever plants are not available, because their signals are something similar to the plants because of presence of algae, which is having chlorophyll A. So the area which is devoid of, you can say, the higher plants, these can be mapped very easily, and that this exercise has been done. And then precisely for this activity, I went to the Antarctica also, because in Antarctica only vegetative component is lichen, and some of the places you can find algae, and only in the, you can say, the western peninsula only you can find some of the higher plants. So mostly we are concentrating towards Indian station region like Maitri and Bharati, and trying to map lichens in this area. I did a lot of sampling there. In you can see this map where Lasman Hill area was covered by me for spectra, ground spectra signature bank creation. This is for the Maitri area. And this is some of the glimpses of the lichen spectroscopy work that I did in Antarctica. And Grouper Mountain area, Eulia frigida lichen, you can see Xanthoria elegans, Candelaria flower. And this is how the reflectance looks like for various species. I have collected more than 100 spectra of the species, and samples are also being brought to India. So as you can see, the maximum variability between lichen species is found around 950 nanometer. Okay, the most lichen showed a more gradual increase to 400 to 1300 nanometer, with the maximum inflection point at about 680 meter, because 680 nanometer, because of the presence of the red edge. Algae is having chlorophyll A. So I'll try to conclude here because the time is less. Since we are talking about the biodiversity and sustainability, now you may be aware that in 2010, Convention on Biological Diversity was announced, and 20 HE targets were also set in. And to your surprise, that none are actually achieved properly. Only few, only 6 of them are partially achieved, and most of them could not be achieved. So again, new negotiations are happening, and going to be starting from the 2021, and maybe for 2050 and 2030, the new goals will be there. And I believe that now we should be becoming wiser from the earlier learnings, and we should be smart enough in terms of setting the goals for us, because these goals are, if not very obvious goals, it is misplaced. It is like misinterpreted, and people are using for their own, benefits. So as for the Godard's law, when a feature of the economy is defined as a measure of the economy, then it can be misused. Sometimes people game for it. So ultimately, I would like to say from Ratan Tata's statement that if you want to walk fast, walk alone. But if you want to walk far, walk together. So if we want to save biodiversity, we have to come together, and then only we can go far. Thank you.
Thank you, sir. Thank you for giving such, wonderful presentation on ecology, habitat, and how the researches are going on. And I hope all the participants have also learned through this process. Now, due to the time constraint, we are not putting up the question answers round right now. So it is requested to all the participants that whatever your queries are, you can send it through the mails, and our to the various keynote speakers, and they will respond you to through the mail. Okay, so now taking forward to this session, I would like to invite and introduce our second keynote speaker. Our second keynote speaker is Professor Devesh Walia from Environmental Studies Department of Northeast Hills University, Meghalaya. He has completed his MTech and Applied Geology and PhD in Geological Science with 30 years of experience in teaching research, and has contributed in several research papers in reputed journals nationally and internationally. He has completed number of research projects funded by various agencies, for example, like Northeast Council, DST, and also DST joint project also he has conducted. He was also lieutenant and second lieutenant in NCC officer and head of the Department of Geology in Mizoram University. He has several academic affiliation under his belt, such as Institute of Physics of Earth, Russian Academics of Science, Moscow Earth Observatory of Singapore, Indian Institute of Geomagnetism from Navi Mumbai, National Geophysical Research Institute, Hyderabad. So on this note, I would like to invite Professor Devesh Walia to take the session forward with his technical grace. Thank you, sir. Sir, please unmute yourself, sir. You're not audible. Professor Devesh Walia, sir, please unmute yourself.
Yeah, can you hear me?
Yes. Now you're audible, sir.
Okay, then let me shift. Right. You're able to see the. Just wait 1 second. There's something picking up. Yeah, are you able to see the screen? Hopefully,
Yes,
yes.
sir. Yes, sir.
Yeah, so good morning, everyone. After really good, exhaustive, excellent presentation by Dr. C.P. Singh, now I'll be there. I'll share with you some of our thoughts, some of the things which I expect that all the younger people presently just growing up, budding scientists, should know these things which are of importance and definitely will take them forward in their life. Basically, we are here in a very scenic, picturesque area, which is the northeast and especially the Meghalaya, or you can say, call it as Luang. But I'll take you to a a very different aspect which you all should know before we enter into the science of climate change or thinking about the climate change. The first thing is that the global climate change basically doesn't mean too many things. It means only one or two important aspects are there, which I'll cover in the course of the time. The first thing is increase in the surface temperature of the earth, and we must understand that what are the reasons which brings in increase in the surface temperature of the earth, and that's what is one of the target of mine, to make you understand that that whatever climate change or the global climate change indicates or means, are we really entering into such phase, and accordingly, like that only I'll be moving ahead. And second thing is as per the predictions, it is that if the human activity, if we consider that human are the major factor which is contributing for the climate change, then it is very important for us to know that if the human activity, whatever way it is going on, if we just predict it, then within 5 to 6 decades later, around 50 to 60 years later, the life may be in danger. That's what the predictions are. And although these predictions are based on number of experimental observations and simulations thereof. All right. So the global climate change basically, once the surface temperature changes, so the anything which is associated with the temperature is ought to change. Whether it is melting of ice, or because of the melting of ice, there is an increase in the sea level. So now, again, before moving on, we must understand a few important things, that what are the scientific evidences for global climate change. We know it has been worked on, so but all of you as a aware citizen should be responsible to understand what are these, and basically what are the anthropogenic or man's contribution, contribution in this natural phenomena, and what happens, that how the global climate change is going to take us forward in the future. That's what is very, very important for us to be prepared for it. And one more thing, that I said that some predictions are there. So we always should be very cautious about the predictions. We need not follow them blindly. And although we should be prepared for remedial measures and all, that's what is important thing. And so when we go on, we must understand that the science of climate change is one of the most important subject under scrutiny, and because the stakes are very, very high, because climate change, as we have said, that if the climate change with the same rate it changes, around 50 to 60 years there may not be any life. So that's why the stakes are very, very high. There have been arguments for and against the process of climate change. That's what is another thing is there. And there have been several publications. Don't think that if you have not gone through some of the publications against the climate change, then everything is saying one side only, that the climate is changing. So you need to see both sides of the things, because some of them, they are taking it as a real warning. Some of them, they say that they are trying to ignore also, because lot many things are there. So lot many perspective, they do come forward. But from a positive perspective, positive in a sense that the climate is changing, with that perspective, if I take you on, then you can understand that there have been lot many scientists and environmentalists and the people, those who are in favor of global climate change, or you can say that global warming, in other words, because it has got direct implication, direct relationship with the increase in the temperature. And lot many people have done extensive research. Even you can see that we are also involved into receding of the glaciers and all such studies. But we are seeing from one small window. We need to see it from all different windows, so that we understand it in a better manner. While talking about the global climate change, the scientists or the environmentalists, they have considered lot many sampling errors, and with all those errors, they have moved on with a thinking that the global climate is changing. So the discrepancy using the surface measurements and the satellite measurements, everything is noticed. The global warming, which is considered to be induced by human activity, within 2-3 slides I'll try to make you understand also why we consider it as human induced, because of certain reasons. I'll talk about it. So although it is a part of the natural variation also, because the earth being part of the solar system, so there are some natural variations too, they are taking place. And what happens that, especially for the global warming, the role of solar radiations is too much. So that's what we need to understand. And we also need to understand the reliability of the data for preparing different climate models. Now, as we move forward, we must understand little 2-3 terms, that climate and weather. You know that actually climate means the average of at least 30 years on specific day. If I expect what should be the pressure, temperature, or the rainfall today, then I'll have the 30 years of the data, means 30 points are there of this day, and then I can calculate what my expectations are for today. That's what is climate basically means, because we very often we use it so loosely that in life we try to get confused. So that's why I thought that you all, as a budding people, budding scientists, you should know. Second thing is that weather is actually what we are getting today. May not be due to the climatic thing, but the weather is whatever today is there. So as such, the climate, which is the statistical average of the weather events, because if I'll record it today, then it will become part of those 30 years or 30 readings that way. So basically the climate variables, they are the mean annual temperature and the mean annual rainfall, which is directly dependent upon the temperature of the area at a given location. That's what is important. Now, just to broadly understanding, by now you know, already you must be knowing, most of you must be knowing, that the climate change basically refers to either increase or decrease in the Earth's surface temperature. All right, and because of increase and decrease of the Earth's surface temperature, there are a lot many environmental or lot many atmospheric agents. They start becoming behaving variably. So that's what is of importance. And once we calculate the mean state of the climate, so its variability and all those things, they become very, very important. And because of the temperature variation, because it has got direct impact on the availability of the water, so that's why it becomes one of the biggest threat. So whether you believe it or not, whether you are for climate change or not, because it is one of the biggest threat, so you need to think about it, you need to take it forward, you need to integrate it into life and living or livelihood. It is said that before the industrial revolution, when the industrial revolution started, there have been changes in the Earth's climate after the formation of the Earth, and we know that the Earth was formed around 4.6 billion years ago. After that, there have been lot many phases. Although the industrial revolution, which began in around 1760s and all, it means from that time onwards, the various human activities, they started contributing substantially uh, for the changing of the climate, and especially the human activities which substantially impacts the climate change is by addition of carbon dioxide, because carbon dioxide is one of the gases which doesn't allow the solar radiations whatever falling onto the surface of the earth to go back. So what happens that it acts as a greenhouse gas, and it starts trapping the heat, and the change in heat is only the basically the global warming or the climate change. And these greenhouse gases emissions by human activities, those are ones responsible for increasing the Earth's temperature, and which has even given rise to increasing temperature. If the Earth system, we know that it is considered to be as a closed system. It doesn't gain energy, don't lose energy, and like that, it is considered to be as a closed system. But if something comes in, keeps coming in, say the radiations or the things which may increase the temperature. So in the closed system, the glaciers, whatever is there, they are supposed to be melted. So they'll start retreating, going back, getting reduced. And as the water remains more or less the fixed, or remains the fixed within the Earth's atmosphere. So what happens that it will go on adding, because the glaciers are melting. So it will go on adding. So the sea level rising will be taking place, and because the sea level has risen, temperature is more. So more transpiration is there, hence leading to the more precipitation. At the same time, parallel to that, the world will become warmer. So again, before moving on, you must understand that the controlling factors for the climate change. You can divide them into two. Some of them, they are the external factors, but they are the most important factors which have got potential to change to many degrees. Whereas those are orbital variation in the Earth, or the obliquity of the Earth's, or eccentricity of the Earth, or precision of the Earth. Those are some of the external factors. And the internal factors are within the Earth. You know that the core is very, very hot. The mantle is lesser heated, and then the crust is there. So because of this, lot many active activity is there within the Earth's surface. So there are some internal factors also. So both these factors basically they control the the the, the climate. So that's what is important. Now, to our understanding, where we are able to contribute, although most of the changes they take place in the climate due to the internal or the external factors, but human being which is there on the surface of the earth also has got the potential, but it may change maximum of 1 degree centigrade per in one in 100 years or so. All right, so it doesn't have too much potential, but still that much potential once we are at a critical stage is of importance. Definitely, it is of importance. So because by definitely increasing the greenhouse gases, which may trap the outgoing radiations, and because of that, the earth may get hotter. Now, why we talk specifically of carbon dioxide? Because the lifetime of carbon dioxide is very long, and say the other gases, whatever we talk, their lifetime is lesser. But carbon dioxide, once it is generated by any method, by burning or by even breathing or by any method, by the plants releasing, but as its life is long, it remains at around 5,000 years or so, because the life is long. So what happens that once it is generated, it remains in the atmosphere. And second important thing is that once we generate by whatever method various aerosols, just 1 second, just little later. So whatever way, or just wait 1 second, friends. Just wait 1 second.
You write it, please. There's no question. Enclosed, but you didn't enclose anything, sir.
Are all enclosures were sent?
No, sir, only this one, sir. We receive only like this.
Are no. So many papers. Oh, this one?
Yeah.
Oh, this is very sorry. This madam said that she has got this.
No, sir, we have only this one, sir. I have zero from minutes. We have only this one.
Ah, that's what?
Yeah, but this one, sir, we can.
Which one?
That first one.
The first one. This one includes regulation.
Regulation, we don't have.
Actually, regulation, this is what is the regulation. And he has this RC, na? He told me that the new regulation. Candidates having graduate degree in geology. That's what is the regulation. Candidates having a graduate degree with major.
Only that one, sir.
That's what that line is there. All right. I thought you had brought my that project. Yeah, sorry friends, something very urgent thing came. So very sorry for taking 2 minutes. So basically, what happens that these whatever aerosols are there, by whatever method, whether the vehicle is burning and then giving some carbon and all. So these aerosols also, they are once we add up the human activities, they add up in the atmosphere. Then they all one of the important thing that which impacts the climate change in the region. So we know that there have been a lot of studies that about the increasing carbon dioxide in the atmosphere, and you can see that although, just remember one more thing, that the carbon dioxide is produced by cellular respiration of vegetation and all, or you can say that by biological decomposition, or even by the evaporation from the oceans. These are produced definitely by the fossil fuel combustion, but by the normal process also, the carbon dioxide whose lifetime is around 100 to 200 years by chemical destruction. All right, they can become non-reactive after certain time. They may remain in the system for longer time, but they become non-reactive. Now they are being consumed by a number of methods, even by the rainfall when it is there, when it is falling, they get absorbed and they become part of the water drops, whatever they are falling, or they they go into the sea and they start reacting with some other elements which are being carried out by the river waters and all. They react and they form some carbonaceous or some material like limestone or calcium carbonate and all those things, and they keep on depositing uh, in the sea. So it means there is a natural system. And second thing is that these carbon dioxide, it is primarily due to the fuel emission. Means the most important thing, you can see that as we use more and more fuel, more and more petroleum, coal, and natural gas, it definitely adds up to the total amount of carbon dioxide, and that's what it is the main driver of the global warming in the times to come. It has been predicted by IPCC data that the global mean temperature in the past 200 years or so has increased by zero point 0.7 degrees centigrade. So you can understand that even increase of by 0.7 degrees centigrade can be so much of importance, and is supposed to be taken seriously, because it has got direct impact on melting of the ice of the glaciers, and finally it leads to the increase in the sea level. And because of that, some of the countries, some of the important locations which are there as island, they become at a risk. So that's what is very, very important for us to understand. But the terminology from where I started was climate change is normal talk, but in my topic, impact of climate variability is there. Now the climate change means it needs to have a gradual change in the climate. All right, climate, normally we are talking of the temperature, but along with the temperature, the rainfall also is one of the important parameter. So the gradual change, but the normal climate variability means daily natural swings are also there. There is a daily increase or decrease, or there is a slight variation. So it is not a smooth curve. So now what happens that actually the climate variability means that the gradual increase with those variability including in it. So hopefully you can understand this. That's what. But before again I move on, you must remember that there have been variation in the temperature, because there have been phases when lot of volcanic eruptions they take place. So lot of carbon dioxide by natural processes, it gets mixed to the atmosphere, and then it brings in lot of warm and cool phases. All right. So in the geological past, if you go, then you can see that there have been, if you just see the last 2 billion years, then you will see that there have been lot of time frigid ice has been there, lot of time steaming hot house has been there. So a lot of temperature, you can see that the temperature has varied. The present day temperature is around 17 degrees centigrade, so it has gone up and gone down almost 10 degrees up and down. It has varied. But leaving aside whatever things have been told, now we'll come towards the climate projections, and then what is its impact on, especially on water resources of Meghalaya. You can see that the projections are, although we are going slowly chasing 2050, but we should know that the projections were that it is going to increase from 2 to 4 degrees centigrades. All right, and what happens that this 2 to 4 degrees centigrades, it is going to change the monsoonal rainfall. We'll try to understand in the later slides why I said monsoonal rainfall, because as such India is dependent upon the monsoonal rainfall more, because we are agro-based economy is there, wherein we are more dependent upon the rainfall, because very less area is irrigated. And then the changes in the monsoonal months are expected, and then even during the non-monsoonal months also they is supposed to change, and the non-rainy days they are set to decrease, means the variability is going to increase, or the intensity of the rainfall is supposed to increase by as per the climate projections by 1 to 4 millimeter per day. It means if the intensity increases, then the total amount of rainfall may increase, but the distribution of the rainfall gets decreased. And because of that, if the changing scenario is there in the Earth's temperature, by changing 2 to 4 degrees centigrade, there are supposed to be more frequent and more intense cyclonic storms. Cyclones which are in India, they are known as cyclones, in Japan, typhoons, or in America, they are known as the hurricanes. Now, coming to the climate change, if we accept whatever predictions are there, and if there is a change in the monsoonal months or the total availability of the water, then definitely the land use is supposed to get changed. All right. Now, the moment climate change occurs, the natural resources, which incorporates the groundwater and the surface water, they are there, and their imports from the ground to surface when by the natural processes, they get affected directly. And once the land use changes, on the other hand, the the water supply or the farmers or the industries or the environment, tourism, everything gets affected. All right, because of the climate change and because of the interrelated land use change, the supply and demand of natural resources and the consumers, they changes, and because of that, it brings in the demographic change. And once the demographic change is there, whole of the system changes. So you can understand that global climate change or the global warming, they are of so much importance, because in a river basin, wherever such demand and supply function changes, it brings in, it influences lot of changes. So that's why in the beginning I said that global climate change also has got a political overview. The political relationship is there. We know that, also we know that the increased greenhouse gases, the moment increased greenhouse gases are there, it will definitely have the increased radiative forcing, means the global warming. And because of the warming, the increase of the temperature is there. As the temperature increases, the increase in the evaporation is also there. So finally what happens, that the increase in the moisture content in the atmosphere may be more, and the because of the increased temperature, the water holding capacity also in the atmosphere will be more. So both these things basically, they indicate that the specific humidity will increase, and similarly the saturation of the specific humidity is also be there, and which directly has got impact on the enhanced precipitation rates, means enhanced rainfall. And once the rainfall is enhanced, more rainfall is there, then the water is there on the surface. So the water to get evaporated or transpirated, evapotranspiration, the water has got certain latent heat. So what happens, that this system starts becoming active, and because of that, it brings in more and more intense cyclones, intense storms, and all such things are there. And finally, it leads to the intense runoff also, intense flooding also. So what happens, that these the increase in the temperature has got lot many interrelated fallouts, which are very, very important for the human beings to understand. Because whether it is changing or not, if, as we practice, we have seen that the temperature is changing, so we need to be prepared with reference to the to understand the consequences for the human societies and the ecosystem. Now we have come to the climate change. By now, if I'll ask you, you all know that climate change will bring in the temperature change. Temperature change will definitely bring in the precipitation change. Precipitation will have direct impact on the sea level rise, and sea level rise and the temperature change will direct have impact on the mega events. So everything is now clear, provided we think that the climate is changing, and in our lifetime only it is going to change. Now the moment the temperature rises, if any place temperature rises, it means the chances of drought, because the water is there, it will evaporate, it will be there in the atmosphere, but it will not be in our hand, or not, it cannot be used. So it brings in the conditions which forces us to move towards the drought. And because of such conditions, you can understand that if the more temperature is there, more drought-like conditions are there. So it will give rise to the crop failures or loss of fresh water and all such things. If the precipitation changes, all right, which has got direct bearing, temperature rise changes the precipitation levels. So it increases in the annual rainfall, And what happens that occurrences of short duration heavy rainfall. We have noticed in the past few years the rainfalls are of short durations and they are definitely heavy, and they'll also be there at the unexpected time, like in the winters and all. The more rainfall events are taking place, and which also brings in definitely the crop failures, or due to the say the floods and the fresh water and all such things, they start getting affected. We know that sea level rise is there. Because of the sea level rise, especially in the Indian terrain, the important thing is, as the sea level rises, it will start intruding the land. All right, and because of the once the salinity increases or the sea level intrudes into the land, then from there the fresh water doesn't enter, because the sea water leaves the salinity or leaves the salts into the pore spaces, or it may bring in the riverbank erosion, coastal erosion, whatever you say, and because of that, the direct impact on the freshwater supply or degradation of the agricultural land, at least in the coastal areas, they become very evident. Or it will bring in the mega events like crop failures, loss of fresh water, especially in the coastal areas because of cyclones, more storms, more variability, means more drought-like situations and all. Now, one thing with reference to the India, with reference to the availability of the water, we know that annual average precipitation is around 4,000 cubic kilometer of the water is there. And this availability of the water over the Indian terrain is huge. It is unparalleled to any other country in the world. And this rainfall, although it is very, very highly spatial, is there because we have got Rajasthan, from where you belong to, or we have got in Meghalaya, where is in the spatial variability is there. The temporal variability means the rainfall is not distributed all over the year. And there have been, you know, that Cherrapunji and Mausimram, which are considered to be the highest rainfall places in the world, you may be surprised to know that they also face shortage of water during the non-rainy seasons, means in the winters and all, they also face. So because of this high rainfall in our Indian rivers, approximately 1,953 cubic kilometer of the water flows in the river, and out of this total 4,000, around 432 cubic kilometer of the water is able to recharge the underground waters, as per the studies carried out by a number of people. And so, and out of the total water, we have got good amount of water available as a utilizable flow. All right. So, but still, you can see that because the rivers have got this much water, still in India, in our country, we can have more such methods wherein we can store water and we can use it. We can reduce the temporal variability or even the spatial variability. All right. So that's what is very, very important for us to know. Just to show you the spatial variability of the rainfall, you can see that in these areas in Rajasthan or say in Gujarat, these areas it is say 15 to 20 centimeter or so, whereas some of the areas at the coastal region and or in the northeastern part, we have got very good amount of rainfall. And this temporal, just to tell you, spatial and the temporal variation, we all know that in January, February, March, we have got minimum rainfall, and as July, August is there, the maximum rainfall is there. And with as we are moving, our population is increasing, the per capita availability of the water is decreasing. So we need to understand that with the times to come, the total availability of the water is going to reduce. And say the total amount of water available in 1951 and in around 2020, it is slightly more. So that's what it is projected. So the way the availability of the water is going down is also important for us to understand. And we know that although they are, as compared to the world, India has got still up to this time is around 1,545 cubic meter per capita per year is there. But as we are going down, it is the time is not far that when we become the water stress country, and then slowly we may turn into the water scarce country. So we need to be very cautious, especially with reference to the climate change and with reference to the global warming studies. Okay, so now the important thing is that these the variability of the water available in the region is too much. Although we have been endowed with great network of rivers in all the places, and we have got vast alluvial basins, but still the availability of the water, it is time is not far that when we may have the shortage of the water. India as such is very lucky because of our shape and nearness to Bay of Bengal and Arabian Sea, uh, uh, that we have got the onset of monsoon and then the retreating monsoon. Means the monsoon retreats 180 degrees. So that's what it is. We are very, very lucky to have such monsoons. Now we have Government of India, through Government of India and the hydrologists and scientists, they have done lot of such studies, water availability at the basin level, and you can see that some of the areas, they are very, very rich, and they have got good amount of water available at various purposes, where various regions you can see, and some of the areas water available is more than 1700 cubic meter annually. So you can see that lot of river basins are there. There are some studies which are carried out which have seen that there are there are few vulnerable river basins are there, which have got, some of them they have got the acute shortage, and some of them they have got the rare shortages. All right, and lot many areas are still to be covered, still to be studied. Now, before moving to specifically to the Meghalaya, we must understand that whenever we talk of the availability of the water, we have to talk with reference to the watershed. We need not generalize it. This is very, very important for you all to know, you all to understand in the future of the work also, because many people, they talk of the availability of the water or the climate change or anything, but they don't consider watershed. So, but remember, because each stream has its own watershed, so whenever we are talking of the availability of the water or discharge in the stream, then its watershed needs to be to be taken care of. And because some certain watershed only, the stream is actually draining out the water from there. And what happens that finally these streams only, they gather to each, they converge, and then they gather and they form the bigger rivers or the biggest rivers finally, as they are flowing downward at the base level. Now we have come to an end of our lecture, especially with reference to water resources and its availability in Meghalaya. We know that if you want to study any area, like whether whatever, wherever your J.N. Vyas University is there, or whatever place you are living uh, in the world, the first thing starts, as I told you, that along with the watershed, the first thing starts, you should know that what is the climate. Climate means it is the average variability in the of the region where you are living. So we are talking of Meghalaya. So you can see that the Meghalaya, basically it falls, this is the standard classification with reference to the various climates. So it falls under the tropical monsoon climate and tropical savanna climate as per the distribution. And don't think that one area like Rajasthan will have only one climatic conditions. No, it will have composed of different various situations, various topographic features, due to which it will have the different climate altogether. Or say in Meghalaya in general, we have got hot, humid, subtropical climate. But once you will come to the Shillong, you may not find like that. You may find warm, humid, subtropical climate. So these are the climatic zones which are important for you to know. We have carried out the land use, land cover studies. We prepared the elevation map. But the important thing is that we prepared the average monsoon precipitation of the last 30-35 years. And the monsoon, whatever way the monsoon brings in the rainfall, because this is what is the highest rainfall regions. So we have found out the variability all along uh, the the Meghalaya, and then the total precipitation over the Meghalaya, and then the average change in the monsoon precipitation, that in the past 30 years, how the monsoon has changed over the years. All right. And then on the basis of this 30 years, we try to find out, project that in from 2020 to 2050, how it is going to change. There are different models are there, RCP 2.6 to RCP 4.5 or RCP 8.5. Accordingly, the variability is being projected, that how true it may be. So on the basis of using different models, you can see it. I'll not go into the details, that the variability in the, or the projected change in the monsoon precipitation in the next up to 2050 is being was carried out. Similarly, the average daily mean temperature, that the highest and the lowest temperature, what is that is what is calculated for the last 30 years, and daily mean temperature of 1 year, and then of 30 years, past 30 years, what is the daily mean temperature is there. And then on the basis of the average change in the daily mean temperature was prepared all over the Meghalaya, and then the projected change, that how much it is going to change, which comes out to be around zero point 0.5 to zero point 0.7 degree. Then we calculated for 100 years, and it matches with the trend. So that's what it is. It is changing. But for only for 1981 to 212, if you just plot and then just draw the line, because the variability is there, then the slope is around 0.031 degree centigrade per year. It means practically, when you measure it in the past 30 years, how the temperature has changed. Why 30 years? Because the 30 years is considered to be the minimum data which should be there to predict the climate, or to talk of the climate change. So we could find out that it is changing. It has changed in the past 30 years with around 0.031 degrees centigrade per year. All right. At the same time, the variability over the months is also plotted, and you can see that how the temperature is getting changed over it. And because of the changing pattern, then we calculated the monthly mean precipitation over this area from the year in the past 30 years, and then the total precipitation whatever has occurred in the past 30 years, and then we calculated. So you can understand, with just by seeing these two variations, that 0.031 degree per centigrade per year change, which we recorded, has got the potential to change 11.56 millimeter per year. All right. So if you just see, it is 1 centimeter approximately per year. It has got the potential to change the average water availability in Meghalaya region. So just to tell you, dear friends, to be concise, that water resources, the impact of climate change on the water resources is that there is supposed to be decline in the rainfall frequency. So what happens that which will bring in or which will reduce the availability of the fresh water. And second thing is that high amount of rainfall in a short period of time, which results into the flooding or even the contamination of the available water. So these two important parameters, they are supposed to change. Or if we just talk of whatever I said in the past half an hour or so, so you can understand that these variabilities finally they may bring in the drought, changes in the precipitation, or the increased temperature, or the storms, or the sea level changes. But also, as we are the agro economy, or we are based on the water. So if we'll use if the water the climate, because of the climate variability, if the water availability also varies, then we'll be more dependent upon the use of the underground water, and that's what it may lead to the excessive withdrawal. And if we withdraw too much of the water, finally we may add up the soil to become alkaline or more saline or whatever. And with the time, with the climate change, further higher variability and the over the space and the time, and the low rainfall is going to occur within such variability. And then because we are not using the water efficiently, so what happens that, and we don't have the proper agriculture practices and all. So and at the same time, whatever water is there, delivery systems are there, which are very, very poorly managed. So what happens that we have got lot of factors, places where we need to work, and accordingly the new water policy is there by the government of India, wherein we need to contribute whatever best way possible for furthering the cause. And so one important before ending my lecture, I thought that we also should know that with the climate change, once we foresee the climate change, then there have been a lot of such strategies working, and internationally at the UN level, at the international level, a lot of such long-term strategies have taken place. And the last one is, you just I'm not taking long time. The last one is that in the 2015, the Paris Agreement is there, which we have adopted. Before that, the COP15, this Copenhagen Accord is also of great importance, where we have given a lot of our inputs for its improvement, so that we can understand it in a better framework. After the United Nations framework convention on climate change, lot of such studies have been carried out, and you can see that the COP21, the Paris Agreement in December, wherein around 195 countries have adopted a universal understanding, and as per this Paris Agreement, which was signed by the government of India, our representative, on 4th November 2016, wherein we have agreed to see to it that the temperature, where, say, if you remember, the projections were 2 to 4 degrees centigrade by 2050. So where we have agreed that we'll not allow it to be any case, we'll keep it below 2 degrees centigrades increase, and try to strive for 1.5 degrees Celsius, for which the government of India is very vigorously working. So with this, I have come to an end of my lecture. Now the important thing is that I would like to thank the organizers, all participants. If you have got any query, anything, you are most welcome to discuss. So thankful to the organizers to have given me time to share some of our findings, some of our studies, and some of our mind. So with this, thank you very much.
Thank you, sir. Thank you for walking us with the cause and effect of climate change and the change in climate in India. So I'm very sorry to announce you, due to the time constraint, we will take question answers and all the queries through mail, and we will send the queries to the the concerned speakers, so that they can answer their queries through mail. So going forward, I would like to announce our third speaker. Now introducing him, Dr. Sreenivas Bulusu, Senior Principal Scientist at CSIR-National Geographical Research Institute, Hyderabad. Dr. Sreenivas obtained his BSc degree from Andhra University and MSc degree from Acharya Nagarjuna University. He completed his PhD degree from Osmania University and did his postdoctoral fellowship from the University of Tokyo, Japan, where he was awarded by the Japan Society of Promotion of Sciences. Dr. Sreenivas is currently working as senior scientist at CSIR National Geographical Research Institution. His research area includes stable isotope geochemistry, non-traditional stable isotopes, Precambrian redoxite evolution, Precambrian sedimentation, and tectonic plates. His work on carbon isotope excursion from Paleo-Proterozoic Aravalli supergroup is well received internationally among the scientific communities. Dr. Sreenivas participated in many global Smith conferences and has been an annual member of Geochemical Society. He has been a recipient of Young Scientist Award by the Indian Science Congress and has been elected as Associate Fellow of Andhra Pradesh Academy of Sciences. Recently, CSIR has awarded him with a Raman Research Fellow. Now, on this note, I would like to invite Dr. Sreenivas Bulusu to take this technical session forward. So, please.
Thank you very much, Priyanka, for a nice, kind words of introduction. Let me share now. Is it visible? My presentation, I think, is visible. Yeah. Thank you very much for this invitation to be part of this C3W conference, and it's very welcoming not to deviate from my regular research and then to talk about something about climate changes. Of course, my interest is in climate changes of very past, distant past. So my topic of today's presentation is drastic changes in climate conditions during Earth's history. So why did I...
Sir, sir, sorry to interrupt. Sir, I think the presentation is not coming on the screen, sir.
Okay. Okay.
So you need to... yeah.
Is it visible now?
No, yes, sir. Now it is coming. Yes, sir.
Okay.
It is visible, sir.
Yeah. So the topic of my presentation is drastic changes in climate conditions during Earth's history. So as has been told in the introduction, my interest was basically to look at how the Earth's climate or Earth's atmospheric compositions basically changed over the Earth's history. So I thought it would be very important to know what really happened in the geological past to really understand what is happening in the present and what may happen in the future. And that's the reason why I thought it would be very pertinent to talk about these very distant past events of the Earth history and how it impacted the whole evolution of the Earth itself, and try to understand more about our Earth system during this talk. So in this talk, I am going to touch upon these following topics, like a brief history of Earth and the climates and how atmosphere formed and etc. and etc. So I'll go into the details of this. So this is like a brief history of the Earth. Like, you know, Earth, you all know that formed around 4.6 billion years, close to 4.6 billion years back, and then it has seen a very violent first 500 million years of Radiant period, followed by Archean, Proterozoic, and a large and the Paleozoic period. And we come as human beings very late in the Earth history, like almost like last 600,000 years, 6 lakh years back into the picture. So we are very late entries into the Earth history. So, and then Earth is punctuated by very many events in the in its geological history, such as it has undergone tremendous amounts of in the very beginning, tremendous amounts of melting at the beginning of the crust. It has witnessed a heavy bombardment, and then it evolved into a more passive, more habitable planet at later stages in the beginning, at the beginning of the Archean. And then there were glaciations, almost snowball kind of scenarios, and then oxygen started evolving into the atmosphere, and then life started evolving, and life started, sort of co-evolving with the climate at the surface of the Earth, altering the surface of the Earth. And in fact, it's very interesting to note that the surface, as if it is behaving in a single unit, and it is evolving, everything is co-connected and then interlinked, and then they're all evolving, they're climbing the co-evolutionary ladder together. So it's kind of a Gaia hypothesis, you may all aware about it, but that's the kind of interesting thing about the Earth's, the unique planet that we are living on, is that the surface in itself is very behaving cohesively. So look at as I said, I'll just go very briefly into the, like, how this solar system evolved where a protostar, a solar nebula contracts, and then a protostar forms, and then all our planets, the asteroids which are revolving around this protosun, started condensing and forming various planets, both internal and external planets. And then it's not as if that was the beginning of Earth. And Earth was really, as I said, in the very beginning witnessed an extreme violent history. For example, you can see that there is a giant impact of on the Earth forming, leading to the formation of Moon, which is our only lone satellite. So you see that it's not easy to form these planets, because in the beginning, the asteroid belts, the asteroids which are running around the solar system, hitting each other, and then also colliding with major planets that are forming. So extremely violent conditions which are not really conducive for life or anything on any planet. But yet we are here discussing about this beautiful planet. So I just want to bring up that this is not a simple story of Earth. So to highlight that, I brought this important event. Now, how does this Earth's very early atmospheres could have formed? Like, we all know that the Earth in the very beginning has a kind of, magma ocean on its top. Like there's nothing, no solid rock to start with. At 4.54 billion years, there was a magma ocean. And then this magma ocean, and then the chondrites which are delivering, icy chondrites, which are being bombarded in the Earth's surface. And that led to a kind of atmosphere, which is H2O, and that is water vapor and carbon dioxide to start with. And then what really happens is that how then the gases got accumulated in the atmosphere. It's basically two processes. One is degassing, the degassing of the Earth's accretionary process, that is core mantle segregations, and then the outgassing that is happening through volcanoes. This is one of the recent volcanic eruption. You can see how much of degassing is taking place out of this volcanic eruption. In fact, this interrupted the travel between Europe and US for a few months, actually. This is an Icelandic volcanic eruption. So you see that huge amounts of degassing takes place at the surface of the Earth, and that is enveloping the Earth as an atmosphere. And the other important factor is the input from the chondrites. These are icy chondrites, and then these bring a lot of water and the gases along with them. When they hit the surface, the gases gets released and accumulated into the atmospheric system. So now what really is important is that that Earth is unique in the sense that we are the only planet having a very distinct atmosphere surrounding us. And what is enabling this is the magnetic field of our planet. And without this magnetic field, the solar winds would have simply swept away the whole of the atmospheric gases. That would have initially happened, but once the liquid core has formed, the metallic outer core is formed with its distinct magnetic field around our planet, and that is when you see that we started having our atmosphere. So again, I would like to emphasize that Earth has to go in very important internal reorganization to form this magnetic field surrounding it, so that it can preserve, it can hold to its atmosphere, and which is a very crucial step for all subsequent events in the Earth's history. Now, again, that story is not that we have formed the Earth and we have formed the atmosphere now at around 4.4 or 4.3 billion years, and perhaps the ocean started forming at that time. Does it end the story there? No. You can see that Earth was bombarded heavily, what we call a late heavy bombardment or a late veneer, at around 3.9 to 4.0 billion years ago. So, as I said, it has to really suffer. The Earth has suffered a violent story, and it was bombarded by several meteorites between 3.9 and 4.0 billion years. Again, churning the whole surface of the Earth, and out of that you have formed whatever perhaps the present day kind of crusty fragments that we have seen at the face of the Earth. Incidentally, the oldest rock that we find on the Earth's surface is around 4.0 billion years. So this event is perhaps the key which translated the Earth's surface into what is habitable to present day. Now let us look at the evolution of atmosphere. So as I said, initially it is only hydrogen and helium, and then with very little of ammonia and methane. So this is probably the first atmospheric composition. And from there, during the Archean, it is perhaps the carbon dioxide and methane, which are greenhouse constituents. I'll tell you the importance of these, as the two other speakers, at least Devesh Walia has pointed out that these greenhouse constituents are very crucial because the protosun or the young sun at around 4.0 billion years was very faint. It was not as bright or as luminescent, giving away all the energy that we are receiving today. It was not the case. It was very faint young sun. So we are not actually receiving that much of solar radiation. And what really happened is that how then our Earth's surface remained hot, or how we are not frozen, and why the Earth's surface was not frozen, and why we have running water and why we have the oceans, is because of these greenhouse constituents were so high in the Archean atmosphere, and that was holding all the radiation back at the surface and keeping the Earth was warm, although we have a very faint young sun in the beginning of the Earth history. And from there onwards, now we have arrived at a present stage where our atmosphere is completely filled with nitrogen, almost 80%, close to 78%. And we have, of course, the most important gas, which is oxygen, which we are breathing every minute and every second, and we're living on it. So now the story of atmospheric oxygen is the story of atmosphere itself. So from no oxygen during very early history of the Earth to a 21% of oxygen-rich atmosphere is our story. And with that, we evolved. And with that, the surface of the Earth has become habitable. So now, as I said, it's because of the story of the Earth is the story of atmospheric evolution is the oxygen evolution. So how do we decipher this? How do we look for the evidences? So as geologists, we all look for, several different rocks, which are like archives of this important event in the Earth history when this oxygen started accumulating in the Earth history. And we use several of these indicators or proxies to understand this event. So in this are stromatolites, the Canadian formations, the red beds, Yuei-An Liou. Yeah, so reductions to elements and paleosols, which are like soils of the past.
Sir, sorry to interrupt you, sir. So the slides are not changing, sir.
My slides are not changing?
No, sir.
Is it changing now? Are they changing now?
No, sir.
Okay.
Can you go for full screen mode, slideshow mode?
This is slideshow mode. Can you see now?
Yeah.
Okay, I think I should quit the. Okay. So is it not visible from the beginning or?
Yes, sir. The first slide was visible.
Okay. Okay, right. So can I continue from here or? Okay. So can I continue now?
Yes, sir.
Yeah. Okay.
Please, sir, please continue, sir.
Okay. So yeah, thank you. So the geological evidences, the proxies that we look for are banded formations and stromatolites and etc. So the most important reaction that takes place as far as oxygen evolution is concerned is the photosynthesis. The photosynthesis which converts which splits the hydrogen or the water molecule to produce the inorganic molecule and free molecular oxygen, and that releases into the atmosphere. This is the key reaction that has enabled oxygen-rich atmosphere at the surface of the Earth. Of course, we have the photochemical dissociation of water, like water is dissociating under the ultraviolet radiation and releasing OH and H molecule, and OH molecules combining together to form water and oxygen. But then this process is, very slow process because this hydrogen has to escape back into the space. Otherwise, we may not get this back reaction to form the oxygen here. So this is a very slow process. But what really enabled this story of oxygen is this photosynthesis. So this is one of the most wonderful reaction in which water molecule easily splits and then produces oxygen. And if we can mimic this in laboratory, our fuel problem is solved forever on the Earth history. So the nature can do this job very easily, and we are still struggling with all our chemical engineering and with all our chemistry behind us and our technology behind us, but we are still not able to mimic this process that easily in the lab. So that's what is the uniqueness of nature, as you all agree. So these are the like modern stromatolites, like in Lake Kitties, and this is Shark Bay in Australia. So you can see that these cyanobacterial mats, which produce oxygen out of combining carbon dioxide and water molecule, is the most important things that have existed in the Earth's past, almost from 3.5 billion years. These are some of the old stromatolites. Like this is very near to Jaipur. This is from Jamarkotra, Udaipur. The Aravalli supergroup. These are phosphatic stromatolites. These are about 1.7 or 1700 million years. One of the very famous, gigantic phosphatic stromatolites, and which is now being used as a phosphorite mine to produce phosphate out of this. So very interesting. Like, at that time, around 1700 billion years back, these cyanobacterial mats used this phosphate and then became whatever the stromatolite mats that we see there at Jamarkotra. And now we are retrieving that phosphate and recycling it to produce more and more for agricultural purposes, and then so as a fertilizer. So, it's a very interesting cycle how nature plays out, and then how we use the resources of this sort. Now, when did oxygenic photosynthesis started in Earth history? It's a very, very tricky question. Like we have, as I said, from 3.5 billion years, we have the very early photosynthetic mats in the form of stromatolites are preserved in the rock record. But is it the time when oxygen started evolving into the atmosphere? Then why it was not there during the entire Archean period, and why we are seeing only sometime during Proterozoic period onwards? So this is a big question. Earlier, people started believing that the cyanobacterial mats are there perhaps around 3.0 or 2.7 billion years, but then now definitive algal fossils are only occurring around 2.0 billion years. This is as latest as we can get into the evidences for oxygenic photosynthesis. So until then, perhaps the oxygenic photosynthesis has not initiated, and that is perhaps the reason why oxygen increase was delayed. I'll show you in the subsequent slides how oxygen evolved during the history. Now, these are the banded iron formations. These are like what we call BIFs. And one important thing about them is that these are the source for iron ore in the entire world. The entire iron that we have converted, we've used in several of our industrial revolution and our daily use, and then even today our present infrastructure is all based upon this very unique rock type. Very interestingly, this rock type occurs from about 3.8 billion years in the Earth history to almost Neoproterozoic, end of the Neoproterozoic period. So with a peak around 2.5 billion years, this is how the peak of the banded iron formations at this period, they peaked around this. The model for how these very intriguing rock types have formed is that you form ferrous iron and silica due to hydrothermal interaction at the mid-ocean ridges, and then you supply this ferrous iron and silica to the shallower parts of the ocean, and where it combines with the oxygen produced by perhaps the photosynthesis that is happening at the shallow surfaces, and combine the iron and the oxygen, and you form the iron oxide layers, and the silicon and oxygen, and you form the silica layer. So that's what you see the interbands here, the iron oxide and silica chert bands, alternative bands, and these are supposed to be seasonal. Whenever there is an upwelling of this iron-rich waters, whenever there was more availability of oxygen, you start precipitating them. So very intriguing rock types and very interesting rock types. So you can see that they were all, started, disappearing around 1.85 billion years. And for about 1 billion years, they're conspicuously absent in the Earth history, what we call a boring billion in the Earth history, like 1.8 to 0.85 billion years. We call them a sort of boring billion years because, nothing seems to have happened during this period, but it's not so. It's a very important period. Later again, we started finding that it is again very important period. But what I want to drive out is that see, you can see that when the oxygen was depleted during the entire Archean period here, the iron supply was very much more, and whenever there was that little bit of oxygen that was available due to photosynthesis, it started depositing, and then the maximum peak that comes out is this around 2.5 billion years. And this is perhaps the Hammersley of Western Australia. That is the largest supplier of iron ores for the entire world. And in fact, in India, we have the 2.7 billion year banded formations, and some of them are 3.5 in the Singh craton of eastern India, etc. But then we don't have this peak. If we consider the Biodilla is close to this, perhaps we too have this peak. So this is the one which supplied all the necessary iron that is required for the industrial revolution that happened in the past. We talked about phosphorite, how it was recycled to get into our green revolution, and now you see how the banded formation which deposited due to some very intricate interactions between the hydrothermal process and the kind of photosynthesis that is happening at the shallow places, and now supplying the metal that is required for the industrial revolution that happened in the recent human history. So, and then you can see that there are what detrite, I also mentioned there are detrital graninites and pyrites. Like in the rivers, we see a lot of heavy mineral species, and some of these heavy minerals gets oxidized if the oxygen is available. But if that oxygen is not available, they remain as unoxidized. So in the entire Archean conglomerates, which are like fluvial deposits of the past, we find these detrital pyrites, which are FES, and then uraninites, which are like uraninite can get oxidized to hexavalent U6 place state if there is an oxygen availability is there. And if there is no such oxygen availability is there, they will remain as uraninite. So there is clear-cut signature that Archean is not having enough of Archean periods, or prior to 2,500 million years or 2.5 billion years back, there is no oxygen in the atmosphere. Now again, red beds, these are very important things. Again, red beds start appearing in the Earth's history around 1.9, 2.0 billion years or 2.1 billion years. These are like red colored sandstones. We can see that in several places in Rajasthan, Proterozoic sandstones. And then these red colored is nothing but the iron in them gets oxidized and become iron oxide. So now coming to paleosols, what is a paleosol? Paleosol is nothing but a soil of the geological past. Between here it is a soil developed between two successive volcanic flows. There is an intermediate period of no activity, no volcanic activity. So the bed below, the volcanic rock below has weathered to produce this weathering profile, and on which the subsequent volcanic flow came and sat, and then hence this is preserved as a sandwiched soil. So this can give very important clue when it was developing. It can give important clues about the composition of the atmosphere at that time. So there were several models. I will not go into all of those details, but then based upon the paleosol compositions, Professor Holland suggested very long back in 1988 and 1990s that there was a drastic rise in the atmospheric compositions at around 2.2 billion years, from about very less oxygen concentrations to about 10% of present atmospheric levels. It has drastically increased. So this is the model they have given, and what we did is that we refined this model using kind of advanced modeling of the paleosol data, and we came up with it's not really drastic. It's not one day event that that oxygen increased between 2.5 and it gradually increased between 2.5 and 2.0 billion years, and this model is more or less now accepted. So I want to show that to change from one condition to the other condition, it's like less oxygen condition to a very high oxygen levels. It really takes a lot of effort for the Earth system to evolve into a into a more matured kind of situation. These spikes which we are shown here is because of the global glaciations. I mentioned about snowball Earth kind of scenarios, and the first kind of solid evidences for snowball Earth starts happening at the beginning of the Proterozoic. So this is also the beginning of the oxygen rise, which we call great oxidation event. This whole thing is a great oxidation event. And so during these glacial events, perhaps the oxygen levels have drastically swung from very low to high levels. So you see that what is happening in the Earth system is that it is like, as a new system is emerging, it is also inducing changes on the climate, and then inducing a lot of pressure, so that it is going into a kind of snowball-like scenarios, and then it is evolving back to the high levels again. So such kind of scenarios are predicted or estimated from the past. Now again, coming to the sulfur isotopes, again, I'll not go into the technical details of this diagram, but I can, what I want to bring to your notice is that you can see that the entire Archean period up to 2,500 million years, these data points show large variations. This is nothing but a mass-independent fractionation in sulfur isotopes. So don't worry about what really it is. I mean, you're not experts in this field, but I would like to say that this period is large fractionation, and from this period there is no fractionation. The explanation for this is the formation of ozone layer. If you have ozone layer, then the ultraviolet radiation is stopped by this ozone layer, and hence this mass-independent fractionation does not happen. But if there is no ozone layer, that is when there is no oxygen, then there is no ozone layer, so hence no ozone layer. So the ultraviolet radiation penetrates into that stratosphere, and then this mass-independent fractionation occurs. So this explains that this is the period when oxygen and ozone were present, and this is the period when ozone protection for the Earth's planet was not there. And incidentally, this is the period, the Proterozoic period from 2.5 billion years onwards is the period when very dramatic changes in Earth's life systems have started happening. For example, the first eukaryotes, as I have shown earlier, started appearing around 2.0 to 2.1 billion years. Eukaryote is like, it breathes oxygen instead of, like cyanobacteria releases oxygen, but eukaryotes require oxygen to sustain, to live. So, dramatic changes started happening. So all this is because of formation of oxygen around beginning of this Proterozoic period at around 2.45 billion years, and then formation of ozone layer, stopping the UV radiation from the sun, and etc. So, and that also incidentally led to the global snowball Earth kind of scenarios here. So, in a nutshell, we can see that there is this now what we call great oxygen transition during Paleoproterozoic, or great oxidation event, what we call. And then this great oxidation transition also led to a sort of overshoot at around 2.0 or close to 2.2 to 2.0 billion years. And then it became sort of mild during this boring billion year period. And again, there is a stepwise increase during the Neoproterozoic, end of the Proterozoic. And then, so there is a double rise in the atmosphere. And then you can see that the carbon isotopes, incidentally, this carbon isotope record we contributed from Aravali, from a place called Ghasiar near Udaipur. We found such high delta 13C carbonates from that region. So suggesting that our Indian rock record also contributes to this understanding of how oxygen increase took place during the Proterozoic period. So the summary is that oxygen increased during the Paleoproterozoic very gradually. Took around 500 million years from no traces of oxygen to about 10% of present atmospheric levels. It took about 500 million years. So, and very interestingly, what is important is that for eukaryotes, you require oxygen, but for the prokaryote world, a little bit of oxygen would be very toxic, in the sense that its outer membrane will start burning, so they cannot live in oxygenic environments. So if the oxygen would have increased very drastically, dramatically overnight, then it would have led to a sort of disaster for the life on Earth, because life would have been wiped out entirely. Entire prokaryotic life would have been wiped out, because oxygen is a toxic to this prokaryotic life. So you can see that things have really, favored the preservation of life at the surface of the Earth. The geological process, like the oxygen evolution, has not, detrimental to the life on Earth. It is actually encouraged the evolution of Earth. That's what I want to bring out. Now, again, there were a lot of, associated structures with it, like how the margins of the global oceans have transformed with the time. And this is during the Archean period, and then and the present day, like entirely oxygenated oceans. Wherever you go into the ocean right now, even to the deepest part of the ocean, up around 4,000 meters or 5,000 meters deep, you still get oxygen today. But that's not the case. Even the marginal oceans or shallow oceans do not have such kind of oxygen at the time in the Archean times. So now, in a summary kind of things, if you look at how things have changed, the atmospheric constituents like oxygen, carbon dioxide, methane, nitrogen, etc. Now you can see that this is the great oxidation event that we spoke about all along. And this is the carbon dioxide levels. This is also be estimated using several of these proxies. And it seems the carbon dioxide, which was very high during the Archean period, gradually decreased and the oxygen increased. And then nitrogen again, sort of, we don't have those many indications of how high oxygen, nitrogen was during Archean and during Proterozoic, but we have a guess here that sort of, nitrogen levels have established since the Proterozoic onwards. Now, the methane, which is again one of the very important greenhouse constituent during the Archean period, started sudden depletion during the Great Oxidation event, and this is because of this, you have started having the global snowball Earth kind of scenarios, where you deplete the greenhouse constituent, so it will go into a runaway effect and forming entire snowball Earth. So this is what the summary of how this is all evolved. So I'll skip this slide because this is not relevant. Now, again, I said, coming to this is our latest paper on Proterozoic gross primary productivity, how it varied during those boring billion years. I told that sometime between 2.0 to 1.0 billion years, we call that a boring billion years. But then it's not so boring that, things have really, we estimated how PCO2 varied and then how gross primary productivity varied during this period. And this is also a very crucial period for sustaining life during this period. Now, coming to the snowball Earth, this is how a snowball Earth would have looked like. Like entire Earth was covered, even tropical, even equatorial part of the Earth was covered with snow. So, it's like, as if Earth was shut down for a brief period of Earth history. Now we have dramatic evidences or drastic evidences during what we call Startian glaciation at around 720 million years, and then a Marinovan glaciation at around 640 million years. From several continents, several parts of the world, we have the evidences for this. And this is what I plotted here is the carbon isotopic record along with it. And there are carbon cycle twists and turns, and that led to the global snowball Earth scenarios. So you can imagine Earth was really undergoing a sort of, dramatic changes at the end of the Proterozoic. So it is going into a sort of snowball or freezing kind of condition. Again, it is coming back. It's still not understood why and how these things have happened. Obviously, it has a link to the carbon cycle, how carbon dioxide and methane have participated. I want to bring to your notice that the most important thing we have to understand is, for example, the role that gas hydrates would have played here. For example, we know that gas hydrate is a major source of energy for our future. We all look forward for exploiting these gas hydrates, but what I try to say is that by capturing methane in a hydrate form and preserving it in the shallow parts of the ocean, we're actually locking a devil. We have locked up a devil, which otherwise could have led to a disastrous greenhouse effect and leading to extreme warming events. So this co-evolving nature of carbon cycle with the glaciations during the Neo-Proterozoic period warns us that we should be very careful on how we proceed with these devils that are there in the projects. So do we want to awake them? Do we want to play with them? Do we want to really make them kind of runaway effects where we don't have any more control over how climate will start responding to such things? So that's the kind of question I want to pose to the youngsters. They would have to look for answers for such things. Now, coming to the Phenrozoic part, now I covered the Precambrian part, like from Archean, we came to Proterozoic, beginning of the Proterozoic, and then we came to the end of the Proterozoic period where I've shown these snowball Earth scenarios, and the remaining part, that the recent 500 million years or 550 million years of Earth history, is also equally dramatic. Like, for example, there is huge variations. There is a big purge during the Paleozoic period in the oxygen levels. And then interestingly, many of these important events are correlated with these global oxic and oxic events of the Earth history. For example, here you can see that the insect gigantism or gigantic insects, formation of the gigantic insects, and the origin of flight is coinciding with the highest level of oxygen that is in the atmosphere. That's about even higher than what is there at the present. Present we are around 21% here, and during this period is probably touching 35%. So you can see that it has impacted the way the life evolved on the Earth, and even not only the forms of life that evolved on the Earth it is controlling, it is also controlling the volume, the bio-volume of the Earth during the Paleozoic. As the oxygen started evolving more and more during the last 250 million years, we started having much of the higher bio-volume what we are having at present. So it is like, as I said in the beginning, climbing together the ladder, the both climate and the life. Now coming to the very latest, sort of history. So I want to bring down to the last few hundred thousands of years of history, a few thousands of years of history. Even our hominids, we have migrated around 200,000 years back from the African continent, and our cousins Neanderthals were there in the Central Asian and then Europe and in other parts of the globe. And there was a conflict between our Homo sapien race and the Neanderthals race, and Neanderthals have vanished around 40,000 years. We all know these stories. But then what is very important is that even these migrations have been influenced by climatic changes. I would just bring that story here and then end my talk. So what I would like to say is that we know that the last ice age ended around 12,000 or 11,600, 12,000 years back. So this is actually the period after 12,000 years back, all the civilizations, human civilizations have started flourishing for the first time at the surface of the earth. Before that, we were more like animals and more like, hunter-gatherers without much of an access for our survival. But then suddenly, the retrieval of the last ice age around 12,000 years back, what really happened is that during the ice age, all these red areas are the accessible land, because now the sea level was very low at that time because of the global, the kind of glaciation at that period. But then these are the blue parts are like, ice, known ice sheets. So ice sheets have spread almost up to here during the last ice ages. So these are the only habitable places. The green colors were the only habitable places during that period. And soon after the end of the ice age, people started migrating, humans started migrating, and they migrated to several different places. And now you can see that how this climate record was obtained. This is a Sahia cave work which is done by, and then using oxygen isotopes. They rebuilt how the temperatures have varied for last 6,000 years. And then you can see that, very importantly, this is the oxygen isotope curve, and then this is the temperature anomaly of 0.7 degrees. So between the 6,000 and almost 4,000 years, the temperature was higher than about 0.7 degrees, and then it started decreasing around last 2,000, 3,000 years. And what is important here to note is that this is the period when Harappan civilization has, the mature Indian Valley civilization took place. But unfortunately, it ended around this. And the significant part is that because of this global warming, the reduced monsoon rainfall, their way of living, like for example, they were started living on wheat and barley, and because of that, which requires a lot of water, and they of course shifted to rice at later stages of the IVC, but then the change in the rainfall, the change in the river courses because of, and then the coupled with tectonics that is happening at the Himalayan trend, all this together have put tremendous amount of conflict and pressure on this civilization that they started migrating towards west, towards east. So this is on the Birana site phosphate record. This is by Anand Sarkar of IIT Kharagpur work. And they did again oxygen isotope on this Birana curve. And they again come to a very similar conclusion much earlier than this recent work on the cave deposits. They also found that around late stages of mature Harappan and late stages of Harappan period, you start having a higher temperature and lower rainfall. And that's because of the reason why the humans, the people started migrating towards east, abandoning the entirely well-developed civilization, abandoning the civilization, they started moving towards east. So what is most important takeaway message here is that nothing can be taken for granted. We are not, omnipresent, or we are not like invincible. A simple change in climatic system that led to a decline in rainfall and some river migrations have pushed one of the greatest civilization of the known history to simply abandon their economy, their culture, their extreme advanced technologies. Like, you all know that Harappan civilization have wonderful drainage systems, wonderful architectural issues, and the cultures. Basically, their way of living, they have to abandon. They're forced to abandon their way of living and started migrating, abandoning and starting afresh. So this has perhaps delayed the subsequent developments that would have occurred much earlier had that civilizations continued for a few hundred years more, or few thousand years more. So we would have witnessed all this development perhaps 2,000 years back. So that is not the case, because the climate has forced the evolution to take a break, to take a pause, and then evolve afresh and then go into. So we have to be completely aware of how this climate system can put stress on us. And then just to conclude, this is what I want to say, that climate induces a conflict, and then conflict causes migration, and this is happening in the present globe. In this figure, I'm showing you the 2006 and 2015 data, how the migrations in the present day, in our modern times, happening from Southern Asia, and then Western Asia and Africa into Europe and other places. And perhaps this is all related to the conflict arise because of the climate changes. So I don't want to give a kind of message or any such thing, but I just want to say that we cannot save Earth. That's not possible. But we can only survive with it. So this is the take-home message I want to give, that we need to understand thoroughly how Earth systems behave and how Earth systems respond to various geogenic, anthropogenic, and even extraterrestrial events, and then make a kind of wise decision on how we survive along with our planet. So thank you for a patient listening, and any questions, you're welcome to.
Thank you, sir. Thank you for walking us through the drastic change in the climatic condition of the Earth in past history. And it was a very informative presentation, sir. Thank you so much. Now, on this note, I would like to introduce our fourth keynote speaker, Professor Chai Chang Tan from School of Management, Mae Fai Long University, Bangkok. He has completed his master's and PhD in mechanical engineering from the University of Wisconsin-Mallory. His area of interest and expertise exists in business strategies and strategic management, social entrepreneurship, consumer behavior, consumer engagement, social media, consumerism behavior, tourist behavior, tourism sustainability, and so on and so forth. He has several research papers in reputed journals, nationally as well as internationally. Now I would invite Professor Chai Ching Tan to take this session forward. Sir, you are most welcome.
Thank you. Okay, thank you very much. And I assume that everybody is able to see my slide now. Are you?
Yes, sir.
Yes, yes, your slide is visible, sir.
Okay, because of the time constraint, I have taken away a couple of pages and sort of go straight to the point, and I will shift the discussions from today's on sciences and all those very important scientific and experimentations and remote sensing issues to more humanistic, anthropologistic issue, which is about social psychological issue. The topic that I would like to share is use of balanced scorecard. And scorecard, everybody is already very familiar today, because scorecard means measurement. So from the scientific perspective, it means that we take measurements, we take observations and understandings through the figures and numbers, so that we can manage based on facts. And balance means that we have to consider the measurement in a balanced sense, not skewed towards one dimension or one domain and then ignore or neglect the other dimensions. So that is called balanced scorecard in the strategic management or in the social sciences perspective. And strategy mapping is really nothing but a map of taking advantage of the scorecard in a balanced, holistic manner, and present it into a way that it becomes that it demonstrates that it makes strategic direction sense, that it gives inspiration, it gives explorations, it gives understanding, it gives meaning to the communities. And I would shift the focus of today's discussions to sustainability in the sense of livelihood. We know from all the the experts today discussing about the important things on the sustainability issues and things that we have to be aware of and taking care of. Otherwise, it would deteriorate the sustainability capability. But again, livelihood is also very important. In the meantime, we still have to live our life. So livelihood developments that I would present today would be based on a balanced scorecard, strategy mapping, and business model is just nothing but a model of you operating of the community members attempting to present the livelihood, operate the business in a particular way. And I would draw the particular attentions to the community-based tourism as a part of the initiative for livelihood developments of the community. It's apart from agricultures like planting coffee, teas, and so the community that I have that I will present to you in terms of case studies would be from the coffee and tea in the highlands, about 1,500 to 2,500 meters high. And I will demonstrate to you what their concerns and how we can bring them to be a part of the sensitivity to the sustainability issue. At the same time, helping them to develop their business model, inviting people to come and visit the community. And so when we invite people to come to visit their community, the tourists can also learn about how they sustain our community, ecologically speaking, social-wise speaking, cultural-wise speaking, business model speaking, and so in a sense that we not only allow livelihood to be maintained or supported in the community, but also most importantly, we are teaching the tourist community, the tourists overall, in terms of how important it is to get engaged in the sustainability. So in a sense that I'm trying to present to you is really nothing but very simple illustration, which is really the relationship between community households, which is the man, and the environment relationship. And within that relationship, we can do a lot of things. Agricultures, we can do community-based tourism, which is part of the livelihood strategy. And most importantly, ensuring that there is a sustainability resources and sustainability return or sustainability, positive sustainability impact as a result of the livelihood strategy. In particular, I would focus on the social cognitive theory, which is again very important, no matter how important how the developments, the science, for example, my training was with University of Wisconsin's Milwaukee in USA, with the U.S. Navy on the liquid metal propulsion systems. But again, no matter how developed is the sciences, if we are not we were not able to motivate the communities or peoples to be able to employ the technologies or live a better life, then things will not happen. And so one of the very important theory is called social cognitive. Social cognitive is very simple in a sense that we are, as a humans, everybody brings along with cognitive capabilities and cognitive attitudes, cognitive tendencies, cognitive potentials, cognitive characteristics, and all those attributes in a community social sense. So that's a social cognitive, means the inferences between the societies and the individual cognitions in a sense that can influences the way they project themselves into sustainability context and develop and derive the strategy. And again, in terms of social, there again needed a lot of help from people, such as many professors has demonstrated how they have helped the communities and remote sensings and monitoring the situation. So civil participation is very, very important. And environment again has a lot of limitation, and we have the we will be covering the sustainability in the environment in the sense of ecological perspective, economics, and social culture, because any one of those dimensions of sustainability that are not integrated, that are being jeopardized, or there are because we want to take advantage of other domains of sustainability, the whole thing will fail. So sustainability got to be integrated. And not only in terms of the output, but again, it is part of the resources from the very beginning, that it becomes the inputs, process, and output. So sustainability is not only the outputs, it is very important thing is the input. The key issue, therefore, just let me recap captures and my sharing with you, and how I have I'll present to you with the real cases, and there are many other cases, but the cases that I'll present to you today, because of the time constraints, would be on the coffee based coffee and tea. So those are the community in the highlands, 1,500 to 3,000 meters high, cultivating coffee and tea, and also their ethnicity. So they have a lot of cultures and heritages, and they we found out that in order to motivate them for the continuing social positive social and culture changes that has impact not only to themselves but also to the tourists, and not in terms of the market of the tourism, but also can help motivate the community in other communities or the populations in general to better understand sustainability. So a lot of benefit. And the concept that I'll introduce to you will be balanced scorecard and business models. So hopefully our science colleagues can hopefully adapt those into the scientific development stages. Very important thing in terms of balanced scorecard is that if we want to get our financial and sustainability outcomes positively, we need to be able to influence our customers to perceive positively that there are certain value that they can that they can enjoy and can benefit, and so therefore they continue to come to the communities and engage and be happy with the tourism's community-based tourism. and get the experiences. That to do that, we need internal business process support. So a lot of activities the communities will have to do to make sure from the supply side and also the demand side and also the demand sides that they would need to be able to package up in terms of the allowing engaging the tourists to experience certain types of experience, such as demonstrating how bringing the tourists to the to experience the how they cultivate the coffee, and how do they ensuring that there are sufficient water resources, and how do they do the plantations on the teas, and how do they do so many other things that the tourists found importance value. And so these are called the internal business process. To do that, from the balanced scorecard perspective, is we also need to monitor how the communities learn and grow. So if the communities cannot learn, will not engage themselves in learning and growing, then they will not be able to continuously improve their business processes. And if they are not able to do the internal business processes, then they are not able to convince the customers to come and value the experiences, and therefore the financials will not be there. Insufficient money causing insufficient protections on the ecological healthiness, and also the maintenance and positive impact on the social and cultural perspective. So therefore, fact-based, measurement-based, it's very important. And this is very simple, because we can easily convince the community members that all you gotta do is just learn and grow. And then when you are able to learn and grow through the facts, then you are able to improve your processes, and therefore deliver the customers' values, and also helping on the various perspective of sustainability, which is profit, peoples, and the planet. And this balanced scorecard is very much similar, which is a strategy map. I mean, it is a map that that we do something about on the learning and growing. It will lead to something about internal business process improvement, and so on and so forth. So it is a strategy map, in a sense, directly directing the companies to have a sustainable and financial achievement and ecological achievement. And that really is parallels to the concepts of business models. So how do we? It is very, very useful for communities to be able to operate and design their business operations, and that business operations business model. It's not difficult. And all you got to do is just capture the four perspectives of the value, because what is eventually importance in business is to deliver value, both for companies and for the communities and customers, and which parallels to the concepts of balanced scorecard. And so learning and growth perspective and balanced scorecard or strategy mapping from the business operations a strategy perspective is that we gotta create value. So there are sources of value that we need to create, and that sources of value creations, and it's the fundamentals, important things to drive the business. And once we establish that value creations and sources in a positive sense and sustainable sense, it will therefore deliver value production. So we can produce a lot of value, experiential value, ecological values, whatever values, and then we deliver through marketing and promotions and inviting the customers to visit, and we deliver value to the customers, and value delivery to the customers, allowing us to capture all those values back, not only in the sense of profit, but also in the sense of better ecological qualities and better social life. And then the customers will pick those values and share with other peoples and develop the whole country, and bringing the awareness, spreading awareness of community-based sustainabilities and efforts in agriculture and community-based tourism in a more positive sense. And so this is very important. Social conditions, you can see in the learning, there are a lot of theories, a lot of things that we can adapt, but I'm just adapting the social cognitive theory in the sense that we are taking advantage of the humanistic and society collective interaction. So in the sense of attitudes and belief. very important in terms of community developing a business and ecological sustainability is we got to inculcate attitude and belief system that it is so important in the business sustainability. It is so important that we have to take care of the sustainable goal of the United Nations, and so they have to buy in, and that is the attitude and belief. And human capital is the developing human skills and the competence that are necessary to do many things. Again, you can see from the arrow is to be able to allow them to do the supply side of the community-based tourism and also the demand side of the community-based tourism. Supply side is not only the community-based tourism in the sense of tourist experiences, but also the cultivations, procedural-wise, organic farming, and we are teaching, giving an educational trip to the tourists. So the supply side of properly cultivating and the post-harvestings and harvestings and all those issues are necessary for educating and providing customers or tourist experience. Innovation is also a part of the cognition and a lot of other cognitive issue in the sense of managing the resources and managing the all the communities and so on and so forth. And with that, eventually will drive sustainability impact. So this is really nothing but just exploring, expanding the supply side. So supply side is production. So it is agriculture, farm production, and experiential production that the tourists, we want the tourists to experience. And again, the demand side activities would be marketing, branding, and consumer behaviors are demonstrate to you a very simple consumers and branding and marketing concept here, which is also very important because at the end of the day, no matter how important or the sustainability livelihood, again, it's also very important, which is to be able to sustain the shocking and the stresses in the ecology and so on and so forth. And that would do a good job with map up to do a value proposition. And which case of a particular concept that I would to do is the social entrepreneurship in the social cognitive theory perspective that that the community get together and they want to do a community-based tourism by social power, and so that's social entrepreneurship. So the concept is really social cognition, and which is very simple things to do. What you do is that we have the social resources and entrepreneurship, which is the business area and the community, and we list all the things that I have just demonstrated to you in terms of community development for community-based tourism, value management, pricings and promotion, monitoring, and all these business issues. And the social resources are the attitude, civil participations, and the community loyalty, and eventually with the concepts of community-based tourism in combinations overlapping each other, we should be able to deliver the C, which is the sustainability achievements. So again, there are various different ways we can demonstrate our concepts in a very simple illustration that the community's member can easily buy in, and so that because of this contributions of research, we are able to generate tribes, community-based tribes that they are so willing to do sustainability, which is the ecological sustainability, and also the socials and businesses, and so they form a team, and each of them brings certain money and to develop themselves. So this is like a way to motivate them and ensuring that they help us to preserve the water resources because it is in the highlands. So again, this is just to show you another theory, which is called the planter behavior. The behavior, which is the community-based tourism, the sustainable behavior, if you want, which is coming from a properly planted, which I have demonstrated to you, the balanced scorecard, and this theory particularly bring to you that if you want the community's members to actively participate in their behavior of sustainability and their businesses that can deliver sustainability, the planner behaviors or social collective facilitate in the sense that we have to ensure they have a proper attitude towards this sustainability and community-based tourism, and they need to have community loyalty, which is a very important social factors, and they must have the perceived behavioral control, meaning they must have the confidence that they are able to do the job. So if the community members feel that they are not capable to do the job, they will not do the job. And if they're not willing to do the job, then the speed of deployment from the government policy, and the speed of getting and the intensities of getting the sustainability to really present positive impact to the communities, as well as the downstreams of the communities, will be very difficult. So providing them the ability to control and have confidence, there are a lot of things we can do. We can monitor performance, allow them to see the balance scorecard, the strategy mapping really works, and allow them to engage as many people as possible, the civil stakeholders participation, and also the infrastructures providing to them. And this is just a different manifestations that on the social cognitive. So why it is so important in terms of social cognitive? Because this is the fundamental ways we can drive and we can motivate the community to be a part of our sustainability, the sustainability and life and supporting their livelihood situation. So I'll demonstrate to you a hill tribe cases, which is coffee and tea's livelihood. And you can see that this is, again, I have already demonstrated to you all the necessary variables that are very important, that I observe and interact and research with them, with the community for almost 2 years, and then we find out those are very simple. There are a lot of other things like civil participation, which I will not discuss. I used the neural network and together with the communities on identifying the importance role on civil participation, but I will not cover here. And so I would demonstrate to you some of the things that they have done. Resource management. So if you want to demonstrate, to lead, develop, implement a good community-based tourism, and at the same time livelihood, resource management, it becomes very, very important, because we gotta convince the tourists, we gotta sell our specialty coffee. And so these are the communities members in the highland. Plantings of specialty organic coffee, which do not use the chemicals, fertilizers, and which is helping the society, communities at the same time, providing a better taste, fruity taste, a better better taste to the coffee. And this is not straightforward, because we have to slowly develop the community. Getting up to the communities is not easy, and 2 years back, when we start to do things, and we have to slowly manage the logistical issue, which I have demonstrated to you to the community. Otherwise, they will not have the confidence to do that, and tourists also have no confidence to go to the communities. And this is their attitude and belief. They do a continuous, they go and learn from everybody's. And for example, they go and learn, train themselves about cupping, how to test the coffee, and they also learn from many expertise about how can they get a better specialty coffee. So they continues to go and challenge themselves with the context, and they get the rewards, and then fine-tune what happened to their coffee plantations or tea in that sense. So it's a continuous experimentations and learning and growth. Very, very important, not only as part of the value propositions that we can propose and deliver to the consumer, tourists, but also most importantly as the human capitalization in the collective sense that can pass on from generation to generation in the community. And supply side, community-based tourism activity. So they have to maintain well on their farmlands, and they also have to be very creative in terms of utilizing the resources of coffee and leaf and tea leaf or whatever, and use that resources to design various types of food based on local resources in the sense of self-sufficiency. And this is the other look into how they continues to learn how to plant in a more systematic and at the same time that doesn't consume unnecessary the water, allow the waters to be more circulated naturally, and they have continues to learn and also provide corporate social responsibility and learn from many places and slowly develop their product and delivered through certain creativities and postage, post offices, post office, and then slowly deliver all kind of experiences to the customers, including heritage, the cultural dancings, and eventually we should be able, and experiences of the customers, and eventually and also all this product exporting and demonstrating how they export the product and eventually deliver the sustainability as a whole. So I'll give you the example on these empirical example. So what we do, this was simulated by neural networks, at the same time simulated by structural equations modeling. So what we do is that we capture all the data from the community's members in terms of the social cognitive learning and growth, and then the supply side, the demand side, and the customer side, and the sustainability. So we can see that they do contribute significantly the variation that can contributed from all these various activities, and especially also the cognitive, socio-cognitive developments of resources, innovation, tourism resources, and the community-based management, human capitals, and including attitudes and beliefs. So, so if we really, trying to establish some scientific or things, and we want the community to participate, so I think very important thing is that we have to develop strengthening the learning and growth in a social cognitive sense, and then specific to whichever we want them to target, which is the business processes relating to what we want them to do, and presenting importance value, and not only not only in terms of the sustainability, ecological healthiness, but also is there any way we can exploit for economical purposes. So it is part of the communities incomes earning. At the same time, the customers will be able to spread the good news, and then slowly the whole populations in the country will at least get some degree of understanding of how important it is in sustainability. So this is the economic perspective, economic the empirical evidences achieving the economic impact positively. This is the cultural positive impact. This is the ecological positive impact, that they have better maintained the ecological environment. They have things like that. Again, this environmental issue is more coming from their attitudes and other activities, less with the tourist perspective. And this is the social impact. So in conclusion, as far as this balanced scorecard, which is a scorecard, a measurement, fact-based, objective-based, as much as we can. Again, social issues are very subjective, but if we can turn it into more data-driven, that would at least would be more objectively objective. So the practicality and usefulness of that balanced scorecard and strategy mapping and developing business model is that because of the learning impact, because of the learning and growth factors, and continuing allowing them to see the overall picture. So it is a very dynamic capability. Dynamic capability is a huge theory in terms of strategic management, because it can allow us to adapt and to the changes of the of the climate, changes of the society. So like all these professors have just talked about it, which is the continuous ability to adapt to the changes in the environment and in the landscape in the community. So these are very, very important. Sustainable livelihood as resource asset can go. And so again, I have already demonstrated to you the sustainability. It's both resources and both go. And so it is very important that we have to ensure that they are both input and output continuous learning. And again, these platforms of simple strategic mapping management in terms of sustainabilities and business model, it is also a platform of performance measurement. So if we can become and engage and establish that simple platform to be a platform not only in management but also in measurement, it will provide a channel for the community members to acquire the data, and so they can engage in better brainstorming and interaction, and they can better develop strategies and for not only the livelihood but in a sustainable way. And so therefore, in a sense, it is to establish a dynamic base for social entrepreneurship. And we found that this model is also very effective in social entrepreneurship, because as ship means the arts or the management. So we are actually providing a very simple management tool for the community to be able to address their business challenges, not only for this case but also for other cases, which are such as for the hot spring or for other types of the community base, including using as a platform for the venue for meeting, events, organization, which I'm now working on another projects with from the government. And so this model is really to do management platform for helping easily to address social problems and address business channel, such as by means of strategy mapping and business model, and therefore at the same time to sustain to create a sustainable change in the lives of the community, and to sustain the decent life independent of external help to aid. This is very important because civil participation is important, but again, we have to ensure that they can sustain it. That is the ultimate purposes. So the balanced scorecard structure of business model, when superimposed with the measurement, it becomes transparent reality, and so that it can also serve a very, very important destination governance system. And again, without the transparency in the way we govern and manage the destination, then the sustainability resources will be deteriorated and corrupted. So learning and growth highlights both tangible and intangible resources, which I have demonstrated to use things that you can see, like managing resources, managing waters, managing garbage, managing logistics. But again, there are a lot of intangible resources, such as the social psychological resources in the sense of attitudes and in the sense of their collective synergies and their loyalty to among each other. And these are very, very important. And over all pictures, it would be able to create systemic consciousness. This is another issue that I think all the scientific circles would like to do that, because one of the reasons that we are not having the synergy to promote and to engage more actively in this sustainability, the global climate, is because many of us do not have that consciousness in terms of that issue. Forget about the systemic consciousness issue, which is again is not an easy. Unless we are scientists, otherwise the systemic consciousness is probably very, very difficult because we lack of knowledge. Okay, so coming to the last part, which is very quick, is that the things that we have done, we can easily extend it to establish a destination's brand. So branding is very simple, because branding is like if you want to create a brand, you want to tell people that our community has done a good job in inviting people to come and invite the people to come and visit the community, and the policies makers to be attracted to the ideas, and science actively involved. It's very simple. We just one of the very simple idea and concept is called SOR. So we provide stimulation, all kind of stimulations that through the way we see things, the way we touch things, the way we engage things, and whichever channels of senses that we have, and that we will create the perceptions and affections and feeling, which is what lively, alive, organic organisms or human being is. And then we feel better, and we perceive better, and we form better attitudes, and we form a good understanding, and then we appreciate it, and we will respond positively in the sense of mentally or verbally and physically. That is how we establish this brand management. So you can see that we have done a lot of supply side. I have just demonstrated to you, and I have which includes one of the customer perspective, which is the tourist value proposition. What we got to do is combine with the destination personality and some of the tour guide facilitations and the value that we want to propose in a more detailed sense, experiential value, the functional value we would like to deliver to the tourists, and all these stimulations would then create feelings and engage the customers to learn. So the personality of the destinations could be very vibrant depending on whether we want to design and engage the community, to design the community in terms of, in the sense of vibrant communities or competence community, that tourists comes and they competently able to understand the coffee experiences and get excitements, and then with that of the tour guide facilitation through the caring of the tour guide, the interactive engagements and activities of the tour guide, it will be able to, these are stimulations, will be able to provide, lead to organism, which is the tourist learning and become satisfactions, and then they respond positively and intentions to revisit, so get their friends to revisit, and that's one spreading the news to another ones, to another ones, and to another ones, and to another ones, and eventually the brand management becomes the community becomes an established brand. And so other communities would then take on the same model and then continues to develop. So we are now seeing, because of the success in that one particular, three particular, so we have the communities, we have the tribes, and now we are seeing more people participating in the sustainable drive of the communities. And so you can see that the things that I have just explained to you on the balanced scorecards on the community side and strategy mapping on the community side can easily connecting to the customer side. I have the empirical evidences, but due to time constraints, it would not be I would not share with you, but again, they're all demonstrated in the computer, the statisticals and the neural networks simulation. That concludes my presentations, and again, thank you for giving me the opportunity to learn from you and to be able to share a part of the community-based initiative in undertaking livelihood at the same time sustaining sustainable achievement. Thank you.
Thank you, sir. Thank you for introducing to a whole new holistic approach of using, balanced scorecard, strategic management, sustainable livelihood with, community development and participation.
Thank you. Yes.
Now, thank you, sir. Thank you so much. And now on this note, I would like to introduce our fifth keynote speaker, Dr. Prakash C. Tiwari. Dr. Prakash Tiwari is the head of Department of Geography at Kumaun University, Nainital. He is also a disaster management nodal officer at Kumaun University. Dr. Prakash Tiwari specializes in mountain sustainable development and climate change adaptation, and has also worked with various national and international organizations in India and abroad in these fields. He has implemented a number of multiple institutional collaborative research projects sponsored by international organizations. He is globally renowned and proud recipient of international fellowship and awards. He is well traveled over the world and for his professional commitments as mentors in global graduate education program, for creating flexible, enduring and peaceful society at Hiroshima in Japan, guest professor at Leipzig University Institution of Ecological Urban and Regional Development at Germany, visiting scientist at School of Civil Engineering and Geosciences, University of Newcastle, UK, and many more into his credit. He has several research papers in reputed national and international journals and has authored many books. So on this note, I invite Dr. Prakash C. Tiwari sir, to go forward with the session of today. Sir, you are most welcome for today's session, sir.
Very good afternoon to all the participants and the organizers of this international event, mainly focusing on the sustainability. Thank you so much, Dr. Priyanka, for your kind word and warm word that you used to introduce me to the wider audience of national and international level. I'm also able to see Dr. Farooq, my friend, who provided me this great opportunity to be part of this very significant and important event. And I could not say no to him invitation anytime as ever. Thank you so much, Dr. Farooq, and thank you so much, Dr. Priyanka, for providing me this opportunity. Dr. Priyanka, please let me know how much time you will be allowing me to make my presentation and interact with the participants this afternoon.
Yes, sir. Sir, you take your time for presentations regarding
okay.
the
I will
question
finish.
and answers.
Okay.
We will continue.
30 minutes.
30 minutes. Okay. Just one moment. Are you able to see the presentation, the slide?
Yes, sir. Yes, sir. It is visible, sir.
Okay, thank you so much. We are living in a rapidly urbanizing world, and every day the urban population is increasing very alarming rate, particularly in the developing and less developed country. Although the urbanization has reached at a threshold level in the many European and other developed countries, from 70% to the 90% of the urban population living in the urban areas. But in the developing country like India, we have still 30% of the total population of the country is currently living in the urban area. But we have not been able to our urban areas in a sustainable manner as the other countries have managed with larger population living in that urban areas. And as a result, the urban areas are becoming the hot spot of climate change risk, particularly the climate change natural disaster, and both in the plains and the mountains. So since I have been working in the mountain, I have a lot of concern about the mountain, and the mountains are the global heritage. Himalaya is also the global heritage, the largest, youngest mountain of the world. The ecosystem services flowing down from the Himalayan mountain, sustaining nearly half of the world population living in the plains of South Asia, which is the home of the 50% of the world population. And the 50% of the world population that is living in the South Asian plain is some of the poorest people of the world, with subsistence farming is the only means of livelihood for them. And living at the bottom of the water tower of the world, that is Himalaya, they have access only 5% of the freshwater resources of the world. And although the urban areas are considered the focal point, the nodal center, the growth centers of development, as they generate the growth and they create the growth, and they are able to transmit the growth through the trickle-down effect in the vast surrounding rural areas. And that's why the urban areas are the heart lines, the itineraries of the development, not only in the mountain, but all parts of the world. But the way the urbanization is growing in the developing countries, particularly in the Himalayan mountain, we need to think about that. We really need that type of urbanization, and we need to have our cities climate resilient and climate smart cities, or we need to have a sustainable urbanization that could contribute to the development, to the growth of the entire hinterland, the vast hinterland of the urban areas. So I will be sharing with you some of the examples, some of my experiences of the impacts of urbanization in the Himalayan mountain, particularly from the two states, the rapidly urbanized state, the Himachal Pradesh and Uttarakhand. And I have had the opportunity of working on the urbanization of these two states in an international project funded by the US aid, and the funding was coming through the UCCR and Urban Climate Change Research Network, and the British Columbia was the US partner of this project, and Kumaun University, we participated in that project. So as you see, Himalaya is not only the most densely populated mountain of the world, but it is the most rapidly mountain of the world. And urban center revolve above 2,000 meters, only in the two mountain ranges of the world, the highest mountain range of the world, and these mountain ranges are Himalaya and Andes. And in no other mountain of the world, including Alps and Rockies, the settlement, particularly the urban settlements, are not located above 2,000 meters. So that is the uniqueness, specificity of the urbanization in the Himalayan mountain. And the number of towns and the urban population is highest in the Himalaya. So we are on the top in terms of the growing number of towns and the concentration of population in our urban area. And we have rapidly growing towns, particularly in the greater Himalayan ranges. So Himalaya are divided into three parallel running ranges. In the southern part, we have the Shivalik or the outer Himalayan mountain ranges that are up to the height, attain the height of 1,500 meters. Then we have the middle Himalayan ranges, we call it the lesser Himalaya, and that ranges from 1,500 meters to about 3,000 meters. And then on the extreme north of the Himalayan mountains are the great Himalayan ranges, which are mostly under snow throughout the year. But the urbanization now has been pushed to the greater Himalayan ranges, which constitute the source of some of the largest transboundary river basin of the world, and they constitute some of the largest glaciers and snow cover area of the world, and that constitute the source of the water and other ecosystem services, which is sustaining 50% of the global population. So that is a matter of great concern, the urbanization, why the urbanization is being pushed to the higher Himalayan mountain ranges. But unfortunately, that urban growth is unplanned, unregulated, and unsystematic. We don't have any urban land use planning. We don't have any land use policy where we can allow urbanization and where we can restrict the urbanization. So that is creating several types of environmental problems, particularly the urban areas are becoming susceptible to the climate change-induced natural disaster. And how the urban areas are growing so rapidly in the mountain. There are several regions. I am not going to discuss all at all. But one of the significant regions is the constraints of livelihood in the rural area of the Himalayan mountain, because the availability of agricultural land is severely limited. Approximately 50% of the total land is available for practicing agriculture. But the dependency on the agriculture is as much as 75%. 75% population of the Himalayan mountain is depending only 15% of the cultivated land. That is too meager proportion of the land on which that large proportion of people are surviving. And that's why the agriculture of the Himalayan mountain is totally subsistence agriculture. And due to constraints of the subsistence agriculture, but the large number of people, particularly the youth, are out migrating the region in search of the livelihood, means, and employment. So that is one of the important reasons why we are so rapidly and densely urbanized mountain in the world. And that's why all the urban areas are becoming highly vulnerable to climate change impacts, and particularly the climate change-induced natural disaster. I will give you one of the examples how rapidly urbanizing areas we have in the Himalaya. So you can see the state, the Himalayan state in the map of the India in our right-hand side in the screen. On the left-hand side, I have shown the urban areas, the major urban areas in the map of Uttarakhand, the Uttarakhand's town. And if you see in the extreme left bottom, so in the total Himalayan state, about 26% population is currently living in the urban areas. Only 26% against the average urban population of India, that is 30%, approximately 30%. But you see the case of Uttarakhand. So 30% population of Uttarakhand is living in urban area against the 26% total urban population of the Himalayan states of the country. It means the Uttarakhand, which is the youngest state of the Himalayan region, has attained very rapid and unplanned urban growth during the last 15, 16 years. That's why the urban areas are expanding like anything, and there is great urban sprawl in the very sensitive slope, in sensitive areas, in the river basin, in the steep slope, in the higher elevation. And this urban growth is increasing the vulnerability of the urban areas to several kind of disasters and natural risks. We conducted a study of some 500 villages all across the Uttarakhand. And as I told you earlier, that what are the region of the migration? Why the people are migrating from the villages to the other areas, urban areas, other places, other states of the country? So the important region, as I already mentioned, the constraints of livelihood in the mountain. Okay, the 37% population of the rural areas is migrating to the urban areas because of the constraints of the livelihood. And the poverty emerged as the second drivers of the out-migration in the Himalayan mountain. And declining agricultural productivity, of course, the productivity of agriculture is continuously declining in the Himalayan region, and mainly because of the depletion of the agricultural resources, encroachment of the productive agricultural land, and of course, because of the impacts of the changing climatic condition. But you can see here the decline in rainfall and extreme weather events have emerged as one of the very significant, important factor drivers pushing out the people from the rural area to the urban area. And also the decreased availability of water and irrigation, arable land and water, 2%. And of course, lack of services, facilities, education, health as 1%. So what I mean to communicate with you, some other traditional drivers of out-migration, climate change, and natural disaster has emerged. Some of the important factors compelling people to leave their homes to migrate to other areas. Where those people are migrating, in the left-hand side, right-hand side, you can see the 85% of the migrants are settling in the urban areas of the Uttarakhand, and 9 and 6% respectively to the other state and other areas. And some population is also moving from one rural area to other area. So this diagram clearly indicates that the out-migration is contributing to the growth of the urban population, urban areas in the Himalayan mountain. Are you able to hear me? Because I have very poor internet connectivity at my end. Okay? Hello?
Yes, sir. We can hear you.
Okay, very good. Very good. Thank you so much. Because my internet connectivity is not up to that level. That's why I need to ask you in between whether I am able to communicate with you or not. So in this transect, you can see the mid-slope and the ridges have been the main areas, the ideal areas for the evolution and growth of the rural as well as urban center in the historical time in the Himalayan mountain, particularly in the Uttarakhand state. All the rural settlement as well as the urban areas evolved and grew in the mid-slope area. Now, because of the transportation extension and the extension of the infrastructure and the promotion and marketing of the tourism on higher elevation, so urbanization is being pushed to higher elevation, which are covered by forests, constitute the source of the water, rivers and stream, and they have glaciers, they have very important hot spots of the biodiversity and other ecosystem services. So urbanization is being pushed up, moving towards the higher elevation, depleting the environment, disrupting the ecosystem services, as well as making the urban areas highly sensitive to several kinds of environmental impact, particularly to the impacts of climate change. In the same way, the urban population is now moving from mid-slope area to the valleys. You can see the terrace 1, terrace 2, terrace 3, three level of river terraces, the flat plains along the Himalayan river. You can observe when you drive along the river on the road, you can see. And these terraces have very thick soil cover, and they have year-round irrigation water available for irrigation. And these areas are highly productive areas in the mountain that contribute to the food security of the mountain as well as the livelihood opportunities for the people in the mountains. So they are very significant for the agriculture. In the historical time, no settlement, no urban area developed on these river terraces. They were used, these river terraces, only for the agricultural production. Now what is happening? The urbanization is moving down to the river valleys, particularly along the terrace 1, where the land is plain and it is very easy to align the road and other infrastructure. So the mid-slope settlements, urban areas are declining in terms of the population, and the population is increasing in the valleys and the upslope area. But unfortunately, the terrace 1 is the property of the river, and several times the terrace 1 infrastructure and urban settlement have been washed, totally damaged by the flash flood, as we experienced in 2013 in the Kedarnath disaster. The entire valley of Mandakini was totally washed away. The terrace 1 was totally collapsed and destroyed by the rise in the river level because of the high intensity rainfall, flash floods, and the outburst of the glacial lake, the Chorabadi glacial lake. So this is very important, whether we are going to have a land use policy, how to control, how to regulate the urban sprawl in the high mountains. Because both these areas, whether they are high altitude areas or the valley floor, they are very sensitive to the environmental changes. And that's why we need to look into whether we can allow the urban growth in those areas or not. Here you can see the picture of the Srinagar town, not the Srinagar where Dr. Farooq is at present. Maybe I think he is maybe in Jammu or Srinagar. This is the Srinagar of the Uttarakhand. And you can see how the township is growing and growing at the along the Alaknanda River. And part of this area was washed away in 2013. But if you have the opportunity of being there at present, you will see the more built up area has come up in that part. So either we are unable to understand the behavior of the nature, the behavior of the climate, or we are ignoring the signals which are being transmitted by changing climatic condition and increasing frequency and severity of the natural disaster in that area. So we are ignoring, and we are trying to invite another disaster of very high magnitude. So we don't have any policy, any planning, and any sensitivity about the managing our urban areas in a sustainable manner. Here you can again see how all the urban concentration is only and only along the rivers. So that's why this entire area is not only vulnerable to earthquake, landslide, but also the increasing frequency of river floods in that area. Here you can see another example from the Kumaun region of the Uttarakhand. So you can see these are all the example of the river terraces. River terrace 1, which is very close to the water level. So you can see how this productive land is being encroached upon by the unplanned, unsystematic urbanization in all the 4.
There is some technical issues. We'll wait for sir to rejoin again. Please hold on to your patience.
Please have patience. Soon he'll join. Please don't turn on your mics, please. Please be patient. He is into Himalayas. Hello, please wait. We are trying to solve the issue. If within 2 minutes, sir will not join, so we'll continue with our next talk. Okay. So we have to be patient as sir is stationed in Himachal and Kumaun, and that is a hilly terrain and having a low internet issue. So please be patient for 1 or 2 minutes. If he doesn't join, our sixth speaker will join for the talk. Please be patient. Good morning, sir. Leon, sir. Good morning.
Good afternoon. Actually, it's afternoon in Taiwan now.
Okay. How are you, sir?
I'm fine. Sorry, I
Yes.
did not join before this time because of my meeting, the previous meeting.
Okay. Okay, sir. So, Priyanka, we can continue up with our sixth talk. You can start the session for the sixth.
Okay, okay, okay. Thank you, sir. Uh, Now I would like to introduce our sixth speaker, Yuei-An Liou, sir, Professor Yuei-An Liou from the Center for Space and Remote Sensing Research, uh, National Central University, Taiwan. He has completed his master's and PhD in the year 1996 in electrical engineering from Atmospheric, Oceanic and Space Science, University of Michigan, USA. He has worked as a research assistant in mechanical engineering in National Taiwan University. He has started as a research associate at National Central University, Zhongli, Taiwan, and Central Space for Remote Sensing, and was raised to the post of professor. He excelled in academically and had several fellowships and awards under his belt. He is also a member of many societies, namely Foundation from Russia, Corpus Task Group Foundation, Earth Observation, members of Republic of China, National Committee for Global Biodiversity Information and Facilities, and he has also worked as an editor of several journals. I invite Professor Sir to give a talk on his topic. You are most welcome, sir.
Okay, so it's my time to give a speech now.
Yes, yes, sir.
Okay, then let me share the window. So can you see my PowerPoint now?
Yes, sir, it is visible, sir.
Okay, can you see the whole screen?
Yes, yes, sir.
Okay, great. So I display it so you can see better. Do you see the whole screen now?
Yes, 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 sir.
Okay. First of all, thanks the organizer for inviting me to give a speech here. It's really my pleasure and honor to deliver this speech. And my topic is eco-environmental vulnerability assessment from regional to global scale. I am from National Central University of Taiwan, as introduced by the chair. My talk, I will start with the background about the natural disasters and the definition of eco-environmental vulnerability defined in our work. And then the part 2 is about the generalized eco-environmental vulnerability assessment, EVA, framework. And such framework can be applied not only to the regional scale, national scale, to global scale. And also, it can be applied to certain specific topics of interest, such as typhoon or forest fire. And then I will conclude the talk in part 6. And if time permits, I would briefly describe the works done in my lab, hydrology remote sensing laboratory. So this is about background. In this page, I show some natural hazards or disasters occur this year. The left upper corner, that's the Australia forest fire that occurs starting from this year to this year. And on the right side is the China flooding, Yangtze River Basin rainfall cumulative distribution map. As you see that a lot of damage caused in these two events. For the Australia forest fires, the death toll reached 33, and for the China flooding, 121 people died, and 19 million people were affected. So natural disasters cause a huge damage to the human beings, and this on the left it shows that the extreme weather. 2 typhoons hit South Korea in a week. 3 typhoons hit North Korea in this year. These are all records in history, in recorded history. And on the right side, hurricanes Aurora and Macro coexist in Gulf of Mexico in last month. And this also the first time in history. And the wildfires occur on the west coast of USA, and of course cause a lot of damages. 13 states were in fire for some period of time, and just in last month, 3 typhoons hit Vietnam badly. As seen in this slide, for these 3 typhoons, 130 people died due to the 3 typhoons. And in India, this shows the India's vulnerability to disasters. Number 1, 68% of land is vulnerable to drought. Number 2, 57% land is vulnerable to earthquakes. Of these, 12% is vulnerable to severe earthquakes. Number 3, 12% land is vulnerable to floods. Number 4, 8% land is vulnerable to cyclones. So, and also apart from the above disasters, some cities in India are also vulnerable to chemical and industrial disasters and the man-made disasters. So we can see that the disasters occur without border everywhere, worldwide. So there's a need to study the vulnerability as defined in our papers. We consider components of exposure, sensitivity, and adaptive capacity. So this is defined in our papers as shown here, and so here it says that the EV is defined as the risk of damage to the natural environment or particular ecosystem because of any disturbances, including internal physical, structural features, and external dynamics. That is, we consider nature and human-made disturbances to our society. So that is the eco-environmental vulnerability defined in our study. And this page shows the generalized EVA framework. On the left side, EVA, Eco-Environmental Vulnerability Assessment, this is the end result. We can apply different methodologies like traditional AHP or machine learning And we can use the different spatial analysis to derive the variability. And for this, in this diagram, it shows that we consider different dimensions, several dimensions, like here, G1, 2, blah, blah, blah. And for each dimension, certain number of indicators are considered. So, given weights to the all the indicators, we were able to quantify the influence of each dimension to the overall vulnerability, and then sum up the influence of or impact of each dimension. We come out the overall or the total effect of vulnerability, and then we can quantify the vulnerability level, and then provide the assessment result to the authority for further actions. And as I said, I intend to show you that the framework for regional and national and for global studies, and also for specific cases. And in this page, it shows that the EVA for national case, and this is for Vietnam, as you can see that a variety of natural disturbances. And we consider all of this in the study, and then perform the analysis and divide the in the very heavy. But later we rename of the vulnerability levels as shown later. And this shows the natural disasters that occur in Vietnam. And we use satellite data for the analysis. So from year 1989 to 2014, we use dense data, DM, and also other parameters for other dimensions like hydro, meteorology, land resources, topography, social economics. So in each dimension, we consider certain number of indicators or inferential factors, and then to decide the vulnerability. So from year 1989 to 2014, as you can see, the vulnerability level becomes worse in due to the development of this region. So this is something that the old local authority need to do something to prevent the worsening status and improve the life quality. So in this page is a summary of this part of work. So from 1989 to 2014, and the percentage share of different levels of vulnerability from potential to very heavy. So as you can see, the lowest vulnerability level, the percentage is reduced significantly. And then the very heavy vulnerability, the total percentage is increased with years. So this is certainly not a good thing for the area. So that is for regional or national scale. As for the global scale, in this study, we utilize we consider five dimensions: socio-economics, natural hazards, hydrometeorology, topography, and the land resources. And for each dimension, the weights are given as shown here. And if we use the diagram that is used for the generalized EVA framework. So the previous page can be redrawn like this page. So we consider the 5 dimensions like natural hazards, socioeconomics, hydrometeorology, topography, and then resources. And for each dimension, we consider a certain number of indicators. For example, like natural hazards, in this case, we consider drought, typhoon, landslide, flood, and we give them each of them a certain weight. And then for the social economics, we consider population, income, distance, urban to the urban area. And then hydrometeorology, we consider soil moisture, precipitation, temperature, and the distance to hydrological network. And then topography, we consider DEM, slope constraint, slope aspect. And for land resources, we consider land use and cover and the NDVI. For this study, I think the challenge work would be to acquire the global data set. For example, like a drought, typhoon data set, or landslide. Take the soil moisture as an example. The global data set we acquire is from the measurements of SMOS, ESA's space mission, soil moisture, ocean salinity. So for this type of work, one of the challenges, the most challenging work would be to acquire the global data sets for all the factors that are considered in the assessment. And I'm glad that we are able to acquire certain the data sets, global data sets for certain dimensions of our concern. And if we are able to collect more data sets, such a framework can be redone, and then acquire more comprehensive assessment. This, however, this work would give us a concept of the global eco-vulnerability map distribution. So as I described in the previous page, in total 16 variables were considered. And so as shown on the top of 5 dimensions, 1, 2, 3, 4, 5 dimensions, and in total 16 variables are considered. So 16 variables. So in this, in the figure in the middle or center of the slide, it shows the 16 is actually 16 layers of a global map, and each map is a result of the each inferential factor considered, and then given the weights, we derive the global eco-vulnerability map like before, like below. And then we would assign them into the eco-vulnerability protection zones. And on the left side, we conduct a consistency ratio checking to assure that the quality satisfy our expectation. And also we perform validation by using PM 2.5 global distribution. This will be described later. So for the 5 dimensions, the global map seen in this page, you can see that how reasonable the results are based on these 5 maps. So not only for 16 variables, inferential factors, all of them can be shown in a global map, and also the 5 dimensions, and then the end result of the global eco-vulnerability label can be shown in the global map as well. as shown in this page. So this shows the global vulnerability distributions. Overall speaking, in Asia and East Africa, the vulnerability level is worse. This should be expected. And in this paper, we use use different names for the vulnerability, like a very low, medium, high, and very high. And later we would use these 6 level names for the later studies. So given the previous page, the global map, we can display the results in different way for further analysis. For example, this is shown in the histogram. And this page shows the result based on continental. So, and we can also use a country as for display. So it depends on our need. We can display the end result into different scale, and then for further analysis and for providing the relevant authority for taking further actions or measures. And this is versus the income. And this shows the national scale distribution of vulnerability, environmental vulnerability distribution. Okay. And this is the validation of the result. So on the left side, the figure A shows the global environmental vulnerability distribution. And so this map is derived by considering 16 inferential factors, and the B figure shows the PM 2.5 distribution. This PM 2.5 global distribution is acquired from MISR satellite. And then we select 100 random points for acquiring the right side, the figure on the right side, or C correlation. You can see that the correlation between the two maps is quite high, 0.82. And then this high correlation can tell us that the derived global vulnerability distribution or map is reasonable to some extent. And this, we redraw the global map into the environmental protection zones, and then and divide them into different levels for further actions or suggestion to the relevant authority for further actions. And we intend to publish the results in the website for people to access. And this is not complete, but it's in a good shape. And we welcome talents to work with to improve this global map. And so for I just described the use of the framework for regional, from regional to global scale, and it can also be applied to different natural hazards, like here for typhoon. So we perform the vulnerability assessment to for Vietnam. So this framework is similar to the previous one, but of course we need to use different indicators for this topic. And this page shows the weights of all of the factors used in the study, and this shows the map. And not only to Vietnam, but we also do it for Taiwan, as shown here, and also for forest fire. And this page it shows that we use the framework for Indonesia. And likewise, we need to use different weights for all different dimensions. Consider different dimensions for this study. And then this end result. So for up to this point, what I wanted to or the main focus is the presentation of the eco-environmental vulnerability assessment framework that can be generalized and then applied to a variety of applications based on the needs. So I think in India, such concepts should be very helpful for the environmental vulnerability assessment, and then for later on applications or policy design. And this are the three papers that I used for the previous for the presentation up to this point. And up to this point, the conclusion can be drawn here. Number one, human and nature bring more pressure on eco-environment in Asia and Africa, because in this region, human beings significantly depend on goods and services from ecosystem and natural resources. And this pressure would continue to increase with high rate of a growing population-intensive infrastructure development. Moreover, due to topographic features incorporated with the climate change effects, Asia and Africa are significantly influenced by frequent natural hazards leading to enhanced disturbances. Number two, advanced eco-environmental laws are introduced to assist the decision makers with specific strategies to lessen the negative impacts of human and natural disturbances, which can in turn benefit both human and nature. Number three, it would be important to use high-resolution data sets for identification of hotspots like Asia and Africa to find more details of causes with time series evaluation to reveal the changes and its driving forces. So there will be some future work to be done in order to refine the analysis and for better future. So I think I might have a little bit time. So after I complete the description about the eco-environmental vulnerability assessment from regional to global scale, so here I will briefly describe the research work that are done in my lab in recent years, primarily recent years. So my lab is a hydrological remote sensing laboratory, and in this page you see that we work on the drought analysis, flood, and crop loss, and typhoon or cyclone study research, and also fundamental land surface research, and also glaciology. And on the left side, that's about the urban heat island effect. And I also published a book, Radio Occultation Method for Remote Sensing of the Atmosphere and Ionosphere. And this is quite a page introduction of my lab, recent work. This would be more about the typhoon research. I think this is quite about typhoon or cyclones. Generally speaking, the number of cyclone or typhoon is not increased, but the strength is increased. That is something we need to be aware of. So this is not the main, and we develop a very interesting empirical model to describe the interactions between two cyclones or two weather systems. And we developed the empirical formulas to decide the threshold distance to tell us whether or not the two systems would, whether system would interact with each other. Many interesting things can be done, but I will not go into details. And this page shows our work. Actually, I was interviewed by AGU, American Geophysical Union, in August twice. And so the EOS reported my my team's work twice in August this year, and the links are given below, and the title of the two articles are given in this page. The first one was about typhoons getting stronger, making rainfall more often. So when the typhoon becomes stronger, of course, the damage will be more. And then the number two is about storms interact, but rarely merge into bigger tempests. But this is due to the limited area. There is no good environment for the two typhoons to merge. So these are a lot of interesting things going on, and I would like to have young talents or scientists to join us for the future work, because a lot of interesting things we can work together. And this shows the references of my my team's papers about the typhoon research. And this next is about urban heat island. Remote sensing can be applied for this type of work, and it's interesting. I show you this page, and we just use 2 years data. And in year 2016, actual temperature overall is higher than 2017 in Hanoi. However, the temperature appeared lower in the left side, the left figure, like the squares E, B, and F all in the table, and the temperature appears higher on the in the box of relative corresponding boxes in the right side of the figure, or in the table of the here shown on the right side here. The reason is that the green space, the trees are cut in these areas. So even the temperature is high in 2016, but over the areas where trees exist, the temperature can be reduced due to the green space. That's why even though the overall the temperature is higher in year 2016 than 2017, by having the green space in the nearby, the temperature actually is lower in the 2016 map than the 2017. And this is interesting in the result shown in our paper. So in the one page introduction of my team's work, all figures basically are adopted from the papers published in the figures are adapted from the papers that we published. Okay, this is about close to the end. For people who do not know Taiwan a lot, or not have limited knowledge about Taiwan, I think in this year, the TV channel in India has done the video to introduce Taiwan. So like this one, the common and uncommon about India, Taiwan by an India TV channel. Welcome to find that the channel to know more about Taiwan. I don't go into detail. Okay, so thank you for your listening. Welcome young talents to join us, and welcome international cooperation, especially from India. And here's my email address. So thank you very much for your listening. Now questions.
Thank you, sir. Yeah, thank you, sir, for giving the insightful talk on ecological environmental vulnerability assessment and using the geospatial techniques that you have used. Thank you so much, sir. So, sir, we will go forward with the session. Now, as Dr. Prakash C. Tiwari has rejoined us, so we will continue with his talk. Sir, you're most welcome. So, we will continue with your talk, sir.
Thank you so much, Dr. Priyanka, for allowing me to return back to this important meeting. Otherwise, I would have missed a lot of things. Thank you so much. And I seek your very sincere apology for getting disconnected because of the internet, poor internet connectivity at my end, although this is beyond my control. Thank you so much. So, are you able to see my slide? Hello?
Yes, sir. Yes, sir. It is visible, sir.
Okay, so I was sharing with you the example of the Nainital Lake, how the urbanized lakes are depleting, degrading, and collapsing with the growth of the urban population and urban built up area all across the Himalayan mountains. So this is one of the example of the Nainital Lake from where I am communicating to participating in this conference right now. So the depth of lake is declining because of the growing construction activities all along the lake area, and the debris and the sediment is finding its way only and only to the lake bottom, and that is decreasing the depth of the lake, and also the water volume and the water holding capacity of the lake is also declining. So that is a big question mark on the sustainability of the tourism. This is one of the major tourist attraction in the northern India. So whether this urbanization is going to be sustainable, whether the tourism, which is the main major economic activity of the town and the region, is going to be sustainable. So we don't have any vision, any concept about that, how we are making our urban areas sustainable and climate resilient in coming years. Here's you. There is another very small and beautiful lake very close to Nainital. So this is not an urban area. You can see the land use of that area. It is a village, a notified village, for a long period of time. And the uniqueness of this village is that it has 100% of its agricultural land is irrigated. The water for irrigation is not coming from this lake. It is coming from the other stream, which is flowing, which is originating from the adjoining forest. So 100% land is under irrigation. I think in the entire Uttarakhand, there are only few villages which have their total land under irrigation. And they are traditionally growing vegetable throughout the year and selling that vegetable in the Nainital town as well as the town located in the foothill region like Haldwani and Ramnagar. And their income level is very high compared to other villages who are growing the traditional food crop. But you can see how the productive and irrigated agricultural land is being encroached upon by the urban landscape. It is being encroached upon the urban landscape. A lot of apartments, tourists, big hotels, luxury hotels are coming up. And you can see in the background, already one lake, a small lake basin has already died because of the encroachment. And there is also risk to this beautiful lake in the coming year. If we are unable to control, to have a land use policy, urban land use policy, to regulate this growing urbanization in the Himalayan mountains. Here you see, I'm just discussing a few risks, how the climate change is accelerating the risk of the urbanization. If you compare the sum of the impact and risk of the urbanization with the risk of the climate change in this flow chart, you would be able that most of the risk of the urbanization are quite similar to those of the risk of the climate change. So it means that the unplanned, unsystematic, unregulated urbanization without any land use planning is triggering the risk of the climate change. So slow failure, because of climate change is leading to slow failure as the urbanization was also leading. Debris and mud flow, climate change, both urbanization and resulting in the river bed of the siltation of the lake beds, as you saw. flash flood, droughts, forest fire, and the other impact of the climate change is the glacial lake outburst flow, as we observed in the Kedarnath, which devastated the entire towns and villages all along the Mandakini River. So there are almost similar impacts of the urbanization as well as the climate change. It means the climate change is further triggering the impact of the urbanization, means our urban areas are becoming highly sensitive to climate change induced natural disasters. Further, the climate change is rendering our urban areas to highly insecure to water, and in the peri-urban area, this is causing the frequent crop failure. So the population, the food insecure population is increasing, the livelihood insecure population is also increasing, and there are series of health risks, but both in the urban and adjoining peri-urban areas. This is again increasing the trends of the out-migration as the urbanization is doing. And lot of implication for those who are engaged in the process of the natural resource development, and they are only and only women in that area. The study is coming not only from the India, not only from the Himalayan mountain, but all across the developing and less developed countries. The worst affected persons, the people from the climate change and natural disasters are the females. So we need to think about that, how we can have climate change resident urbanization in the Himalayan mountain. So I have few suggestions. The number one is that there is very few studies focusing on the assessing of the impact of urban development on the urban environment. No, only few studies have been carried out, and particularly there is vast knowledge gap in assessing, analyzing the impacts of urbanization on the natural environment. So this must be promoted by and encouraged by the state government as well as by the central funding agencies. And our towns are lacking in the hydrometeorological observation information. So the network of the hydrometeorological observation need to be strengthened within as well as in the surrounding areas of the important urban complexes. And we don't have any information about the ecosystem services which are being generated by the India. I share with you the example of the Simla town. A lot of water is being generated by the town itself, which is fulfilling its demand partially as well as fulfilling the water requirement for irrigation, drinking and sanitation of most of the villages, towns located in the downstream area. And the lake of Nainital constitutes the source of drinking water for about 95% of the population of the town, as well as some small rural settlement located in the vicinity of the town. So urban area constitute the source of prime ecosystem services, and the ecosystem values of the town must be assessed. The ecosystem services in terms of the biodiversity, the forest, the green spaces, and the soil conservation and the wildlife conservation need to be assessed, and the urban development policies should take into account the conservation, protection, and restoration of these ecosystem services. As I told you many times, we don't have any land use policy. We don't have any land use planning for any of the town. Of course, we have some building codes, some rules and regulation about the height of the building and the construction material that we use in the building. But these building codes and rules are never followed. But I am suggesting that we need to have, this is the right time, we need to have an urban land use planning framework for all the growing towns in the Himalayas within the frameworks of the comprehensive land use policy. Comprehensive land use policy, I mean a broader land use policy which make the provision for the development of the urban areas, for the maintenance and the restoration of the agricultural land. And within that framework, we need to have a urban land use planning means for the urban areas only. And then, of course, we need to have a plan, a framework, a timely consideration how we are going to make our urban areas climate resilience town. We have already programmed the smart city, but we don't have the program, the planning, the imagination, the vision for climate and disaster resilient urban areas, both in the mountain as well as plain. But we urgently need that, particularly for the mountain areas, for the Himalayan town. And one very important thing is that in some area, there are some studies are going on about the impacts of the climate change in the urban area. but they are not coordinating with the municipal corporation, the municipal council, the urban local bodies. So my suggestion is that the urban development planning should be based on the climate change adaptation and disaster risk reduction. Means the climate change adaptation and disaster risk reduction should be the integral components of the urban planning in all Himalayan city. Unfortunately, this is not happening. There are several national, international organizations which made a plan for the Simla city, Nainital city, and so many other cities which are very sensitive and vulnerable. But still the local administration, the local city council are not incorporating those recommendations of climate change adaptation and disaster risk reduction into urban development planning. So we need to reorient, rethink is that. And finally, I would require, we need a complete transformation of our perception of the urban areas and our policy and policy planning for the urban areas, not only for the government agencies, the NGOs, the people, the private sector, the restaurant and hotel sector, everything should come together. So we need to have a multi-stakeholder participation, planning, governance for the urban areas that need complete policy transformation. Thank you so much. And I have completed my talk, my presentation. And once again, I'm grateful to you for allowing me to rejoin this program. And in this picture, you can see we are empowering some of the rural women situated in the vicinity of the Nainital town, in the peri-urban areas of the Nainital town, to build their capacities in climate information, because this information is extremely lacking in that area. So these women have been trained, collecting data in every 24 hours, the temperature, rainfall, wind direction, moisture, and recording that data and analyzing that data and discussing that information every month in the meeting of the Gram Panchayat, the village council. And now they have the data of about 5-6 a year record with them. So they are able to take their agricultural decision based how the climate behaved in different seasons during the last 5-6 years. Thank you so much once again. I'm thankful to all of you. Thank you so much.
Thank you, Dr. Prakash Tiwari, sir. Thank you for giving us such an insightful information on urban growth in Himalayan regions and the processes and operations that is going on for sustainable development under the climate change regime. Thank you, sir. Now we will take forward this session of today. This is the last leg of the today's session.
Yeah, Priyanka, we can have a group photo right now before the presentation, so that sir are also present, all the speakers are there, and thereafter we'll continue our presentation.
Sure, sir. So I request all the participants and all the people who are here present, please turn on their camera so then we can take a picture. A moment. I request all of you to turn on your cameras. Thank you.
And thanks, sirs, for providing you valuable information time to this conference. With this, now we move to our second session, that are the paper presentation. Yeah, Priyanka, please.
Yes. Yes, sir. Okay, thank you, sir. Now we are moving on to the second lab. This is taking forward to our convention to the paper presentation, which is chaired by Dr. Vikram Kumar Ranga and co-chaired by Dr. Ashraful Alam and Dr. Satish Kumaria is the reporter. So we will continue with the presentation. Okay, I will just take out the names. The first presenter is D. Balaji. He will be presenting his paper, Geomedical Analysis of Primary Healthcare Center in Madurai East Block Micro Level Study. Is G. Balaji present here? D. Balaji, if you are present, please present your presentation. Yes, you are not audible. Your voice is not coming. He is logged on. Let's give him some 2 minutes time to log in again so that we can continue further on. Okay, we will wait for another 2 minutes and then we will move to another presenter. Okay, D. Balaji, please present and turn on your mic so that you can be audible enough. Present your screen. I think he's facing some technical issues.
And I'd like to thank Sir from Taiwan that he has given his valuable time and he has given an enlightful talk on various topics of remote sensing application in earth resource management with other speakers from various countries. And I would like to seek your cooperation from Suresh Gyan Vihar University regarding publications, regarding academic collaborations. And with this, I thank you, sir, for giving your valuable time and all the speakers who were present here, taking their valuable time and motivating us with their enlightened talk. Thanks a lot, sir.
Thank you.
Okay, yes, your presentation is visible, but your voice is not coming, Balaji. I think you have some problem in your mic, so please rectify the problem and then we can come back to you. We'll move on to next speaker. Okay, the next speaker is O. Muhammad Farzan. He will be giving his paper on mapping of glacial lakes outburst flood using GIS and remote sensing for Lahore and Spiti district of Himachal Pradesh, India. Is O. Muhammad Farzan? Yes. Please check your mic. Your presentation is there. Hello.
Mr. Mohammad Faizan, if you are there, then respond. It's your turn. So if you are there, then respond and it's your presentation. It's your time now. Mohammad Faizan, are you there? I think he is not there. But he is there. Yeah, Mohammad Faizan, you have joined in the meeting, but you are not responding. Are you there? Please, if you are listening our voice, then please start your presentation. Because we can see that you have joined in the meeting, but you are not responding. Maybe you are not listening our voice. Yeah, Mr. Faizan. Mr. Faizan.
Mr. Faizan, please unmute yourself. He's left.
Till left. Okay.
We will move on to next presenter, that is Vaibhav Deloi.
Vaibhav Deloi.
Yeah, he will present on spatial temporal water spread mapping of Satta Lake at Uttarakhand using remote sensing and GIS.
But I think he is not.
Vaibhav Deloi? Is Vaibhav there? If Faizan has joined back again.
मैं पहले ही बोला था इनको चलो जाने दो ऐसे ही होता है
Hello, ma'am. Some technical issue, ma'am.
Okay, no issues.
Okay.
Please present your
Okay, ma'am.
paper.
Mohammad Faizan, are you there?
Yes, sir. Yes, sir.
Okay, now we are going to share your PPT so you can present your work.
Okay, sir.
Yeah. Pranay, please share the PPT of Mr. Faizan.
Sir, can I access the PPT, sir?
Sorry? We have your PPT, so we can share and you can just present your work. And if you want to change the slide, then just say next.
Okay, sir. Okay, sir.
Okay, it will be convenient.
Sir, can I start, sir?
It will be convenient for us as well as for you also. So you can start, please.
Okay. Hello, everyone. This is Mohammad Faizan, B. Geoinformatics Engineering, third year, Tamil Nadu Institute of Remote Sensing, College of Engineering, Indiana University, Chennai. Today, my topic is mapping of glacier lake outburst flood using GIS and remote sensing for Rahul and Spit district of Himachal Pradesh, India. Sir, can you change the slide, sir? The table of content is first first is introduction, and second is study area, and third we move to materials and data sets, and fourth we have methodology, and fifth we have parameter incorporate in the study. In the fifth step we have the subtopic like average slope, drainage networks, and lake area, volume, depth, and land use and land cover. And sixth step we have mapping of the glacier lake. In the study, I have taken the two glacier lake, Deepak Ghat Glacier Lake and Samundara Tapu Glacier Lake. And finally, we have the result and discussion and conclusion. So next slide. First, we have the introduction. First, we have to know what is meant by glacier lake outburst flood. Sudden release of the water from the glacier lake is referred to the glacier lake outburst. This is the capability of the treating in the human life and damage to the environmental and utilities. Climatic change is the main reason for the glacier lake outburst flood. Climatic change will lead to the retreat of the glacier and creation of the new lake for the glacier. Glacier lake outburst flood are the common hazards caused by the climatic change across the Himalaya state of Himachal Pradesh. Himachal Pradesh, we all know Himachal Pradesh is the mountain state in the Indian Himalaya, occupies an area more than 5,500 square of kilometers. The tools and the techniques from the remote sensing and GIS MAC is possible to continuous steady analysis and targeting of the development and improvement at such site. Yes.
Yeah, you continue, please continue.
Actually, the main aim of this study to analyze the temporal variation in the glacial condition using the time series lake of 2005 to 2019 of the remote sensing data such as Landsat 7 and 8, mapping the major glacier lake in the Rahul and Spit district. Next slide, sir. Hello, sir. Next slide.
Yeah, next slide, yeah.
The study area, first we have...
Actually, please wait for some time because
the study area taken
network
for this...
connectivity. You will see the next slide after few seconds.
Okay, sir.
So please wait for that.
Okay. Actually, the study area taken for this study is Rahul and Spit district located in the northwest eastern Indian Himalaya state of Himachal Pradesh. Actually, you have seen the district occupies location this to this latitude to longitude and the geographical area 13,000 square kilometer. Area-wise, as you see, area-wise, it is the largest district of the Himachal state compared to the other districts. Other Rahul and Spit districts separated in the east from the Tibet region of the China, that from international boundary. Actually, Samundra and Deepak Ghat are the two main glacier lake in the Rahul and Spit district has shown the increasing year by year. It show the increasing the areas. So next slide, sir. Material and next we have moved to material and the data set. Actually, satellite data, the remote sensing data used for this study is the high resolution satellite data and the DEM. To carry out the analysis of the glacier lake from 2005 to 2019, the Landsat 7 and 8 data were used in the research. By comparing the all available data set for this study, image with maximum 10% cloud coverage and least snow coverage from the month October to November were selected for these studies. A total 12 Landsat images were downloaded from the USGS websites, and the month which Landsat image were downloaded October 11th and November is 1st. Actually, DEM is used for the calculating the some parameters such as maximum, minimum, elevations, slope, etc. A 30-meter DEM was created by the data provided by the shuttle radar topographic meter. We all know SRTM or second download from the USGS website, and the data were September 23 and 2014. So next slide, sir. Actually, in this screen, we have seen meteorology. First, we have downloaded the USGS website from the Landsat 7 and 8 imaginary. And then we have mosaic the imaginary, and we have taken the area of the interest, and then we have prepared LUSC map and NDWI map. With the help of the DEM data, we have same mosaic and subsec. We have prepared by using the slope map and aspect map, and we have this. And finally, we have got a result. So next slide, sir. First we all know the NDWI normalized differential index. Actually, the highest reflection use NDWI green and the NIR. So we have taken for the Landsat 7, we have taken band 2 minus band 4 and band 2 plus band 4. For Landsat 8, NDWI band 3 minus band 5 and band 3 plus band 5. Actually, the NDWI values varies from -1 to +1. The +1 indicates the water bodies, and the -1 indicates the characteristics of the vegetation and barren land and outgrown. Next slide, sir. Finally, we have step 5 parameters incorporate in the study. First, we have taken the average slope. Average slope, one of the essential element affecting the slope is usage of the area agriculture properties. So with the help of the ArcGIS, we have prepared the slope map and the aspect map. In the slope map, I have categories the 0 to 5, 5 to 15, and 15 to 30, 30 to 45, and more than 45. So here in this table, we have see the 5 to 15 is the highest percentage in the area. As we discuss, this discussion will be in the result. So next slide, sir. And next we have come to the drainage network. The study of the drainage network provides an idea about the topography, climate and geology, hydrological future in the region. We all know Rahul and Spiti district, largest district in the Himachal Pradesh, so it is mostly covered by the snow. We have lot of rivers, so they are the main three rivers in the Rahul and Spiti districts. So next slide, sir. And lake area, volume and depth. The area of the glacier lake is calculated using the field calculator tool in the ArcGIS after digitization of the lake from the satellite imagery. Actually, volume and the depth by using the Hubble formula. With the help of the Hubble formula, we have calculated the lake volume and the lake depth. V equal to 0.14 a power of minus 1 by 2. With the help of the two formula, we calculated the volume and the depth of the river. Next slide, sir. Finally, we have come to the land use and land cover map. The land use and land cover map with the help of the supervised classification technique using the maximum likelihood classification, because it is a most accurate and reliable classifier. But in this land use land cover map, 5 major classes such as snow, glacier, barren land, rocky surface, and forest, agriculture area, and water. The area of the each classes can be estimated using the field calculator tool in the ArcGIS. Actually, is shown in the table. So next slide, sir. Previously, I have discussed the land use land cover map. With the help of the ArcGIS, I have prepared the 4 years land cover map 2005, 10, 15, and the 19, as you see in the screen. As a left hand side figure, mapping. So next slide, sir. Finally, 6 mapping of the glacier lake. This all I have discussed in the previous section. All are mapping of the glacier lake outburst flood. I have taken the 2 glacier lake, Samundra Glacier Lake and Deepagar are the 2 main glacier lake in the Rahul and Spiti district, has both show increasing in their area. The area of the discus has been covered. The coverage separately, the 2 lake perform using the Landsat 7 and 8 imaginary from the 2005, 2010, 2011 and 2019. Deepagar Lake, it is suitable in the Chanda Basin from the Rahul and Spiti district of the Himachal Pradesh. It is located in this latitude to this longitude. The current glacier lake, as you see in the table, from 2005 to 2019, it is continuously increasing. So next slide, sir. Same from the same Deepagar Lake, Samundra also it is also increasing from 38 to from 2005 to 2019. It is continuously increasing. From 2005 has shown 84 in the acres. From 2019 it is 123. It is temporal variation. It is continuously increasing year by year. So next slide, sir.
Mr. Faizan, please sum up soon because we have other presenters. So please sum up soon and go to your conclusion part.
Okay, sir.
Yes.
Okay, sir. Okay, continue. Sir, you can change the slide, sir, from conclusion part. Actually, in the studies, okay. Finally, I have come to the discussion. In the study, glacier lake is mapping using the GIS and remote sensing. As you see, the 2 glacier lake, it is continuously increasing from 0.54 to 0.92 kilometers. From it is the lake area in this 2005, 10, 19. It is continuously increasing. So next slide, sir. Final conclusion. Actually, with the help of the remote sensing and GIS, allow us to develop the map which would not be possible through the field investigation. In order to understand the change in the location, the 2 glacier lake has performed. So therefore, it is important to research such lake in the detail using the high resolution satellite images in order to assess how the glacier lake is changes year by year. This will assess in the evaluating the potential hazards, also in mapping the some other new lake or beginning develop in the area. Thank you, sir. Thank you for giving me opportunity for presenting.
Yes, thank you, Fazan. It was a nice presentation.
Oh, thank
Now,
Priyanka,
I will call.
Priyanka,
Yes, sir.
Priyanka. Dr.
Yes, sir.
Varun and Dr. Ashraful are the chairman and co-chairman. So you can ask whether there is any question
Okay. Yes, sir.
if they are supposed to ask.
Yes. So, Dr. Varun Naya Mishra, sir, is there any questions for?
Vikram and Ashraful, is there any question? If it's all okay, we can continue with our next presentation.
Yeah, yes, it's okay. It was a good presentation. I don't have any questions.
Okay, sir. No question from my side, sir. We can move to next presenter.
Next.
Okay, the next presenter is D. Balaji.
Yeah, Mr. Balaji. So please first unmute yourself and start your presentation.
Yes, ma'am.
Yeah, your voice is clear now. Yeah.
Oh, okay.
Continue. Please continue.
Share his presentation.
Yes,
Please
sir,
share the presentation. Okay.
It takes some time. I'm already present. Share.
Yeah, Balaji, it's your turn. So you can start.
Oh, okay, sir. So full screens. Good afternoon to all. I have the presentation is geomedical analysis of primary healthcare center in Madurai East Block in micro level studying using GS. So I am the
Please, sound is not clear.
Working, sir. So good afternoon to all. Sir, I have the present study in the international seminars so geomedical analysis of primary healthcare center in Madurai East Block in micro level studying using that I have the Department of Geography, Madurai Kamaraj Universities. So and the next. I guess primary health centers also in the government hospital in the subdivisions of the in university primary healthcare centers. The health is common them in the all nations of the world. The health is enough the over the century as a concept of concept from individuals. The worldwide social economy encompasses the quality of life. The primary health centers, the one of the practical, scientific, the socially adapted method, technological uses for the settings. So, common in nursing centers use the primary healthcare centers, even the government hospitals subdivisions of uses for analysis. The subdivisions of primary healthcare centers, so many of the one government hospital each divided for the primary health centers more of the lands in Madurai East blocks in around in the organization the base of clinics. The next. The primary healthcare centers. The primary health centers for the two major themes delivery in one. The first one service should have the full range in the preventive, curative, the reconnaissance service and secondly, one the best to provide the primary health was majority of underserved the rural people and the urban poor that develop efficiency of primary health care. Service support then appropriate referral systems. The primary health care centers used for the rural area, remote adjacent area in analysis. The rural area they covered the medicines unapplied for the fever, the pregnancy lady using the analysis, the emergency use for the primary healthcare centers. Next. Next is my study area. The Madurai East blocks major in 13 blocks only. The Madurai is one of the center part of the Tamil Nadu. The Tamil Nadu, the East block in the southern part of the latitude and longitude. The next the attempt made the study about the healthcare delivery system prevailing to assess the most useful local people in the providing health service and student satisfaction level of people regarding the health service in infrastructure facilities available in primary healthcare center in Madurai East block. Next. The so study in the Madurai East block around 78 Panchayati village in Madurai East Block. The 78 village East Block showing the 6 primary healthcare centers only. The 6 primary health center used for the village admit and village area, rural admit area, and they used for the primary healthcare centers and used the anal areas. The next. So in the methodology, the study area used in the primary healthcare centers, the data collection for the 6 centers primary healthcare centers, the travel pattern in center in kilometer, the fever, pregnancy, cough, the emergency analyzed in the primary healthcare centers using analysis. The data analysis for the using analog the GPS find the location in analysis. The data integrated spatial analysis of your analysis. The GS used for analysis, nearest neighborhood analysis, the travel pattern analysis used in the analysis. The measure of result in the union, the planning in construction in the highly healthcare center in the block using the analysis. The next. Measure of the technique used. For the purpose, the 2 important techniques used as statistical techniques and a cartographic interpretation. It includes the mapping of the study area using the ArcGIS software and ArcView. The disease maps from the SSTN tool for the showing the nearest neighborhood analysis, the FUFR analysis using the kilometer always analysis, the travel pattern nearest near analysis, the interest between disease and the associated environmental factors in the analysis. The next. The result and the discussions. The most of the patient, the primary healthcare center, the patient, the travel pattern explained. The travel behavior, the male and the females, the special reference different the age structures. The travel behavior obtain the primary source of data of patient and the rural characters of the people. The study area consider 6 primary healthcare centers. One primary healthcare center is a sample by 20 questionnaires was collected from his primary healthcare centers. The total sample 120 was collected by the 6 primary healthcare centers. The analysis using the travel pattern analysis. The sample was economic background and various age groups. The secondary source of what data was obtained the hospital authority from the direct to healthcare demography data sources obtained from respective statistical office in Madurai districts. The next. The age-wise, sex-wise travel pattern in the Kallandari block PHC. The Kallandari block is the major important one PHC centers. The male or female, the travel behavior in the distance of the village Panchayati union, village Panchayati rural area adapted in the remote areas. The covering the primary healthcare centers nearest, you want the traveling the kilometer in the analysis. The sample percentage analysis for the average and X bar analysis using the simple correlation analysis. So in the male and the female and the age group wise analysis. The age group in the 0 to 15 analysis in the less than 9 in primary healthcare centers. 15 to 34 is the highestly in using for the female candidate in the pregnancy ladies most in primary healthcare centers. 35 to 64 analysis less than analysis, but the 64 in the common there in the aged people analysis in the aged in the sugar, the test diabetic elusive in the primary healthcare centers in analysis. The next. The Madurai Northeast block in the travel pattern in the analysis. So in the 6 PH in the Kallandari, Rajagur, Wattakade, Kilimangalam analysis, the travel pattern analysis. So many travel pattern analysis, the male travel pattern analysis, female travel pattern analysis. So many diagram is the RGS analysis, the travel pattern analysis. Then another one, the FUFR analysis. The FUFR analysis you used the kilometers. In the 78 Panchayat villages, the 6 PHs connectivity with the area in the remote area in the analysis. So in the analysis, next. The Madurai North East block, the female travel patterns. The female travel pattern, you most of the 15 to 34 ages analysis of the pregnancy lady. So in the primary health centers in the Wattakade, Rajakur analysis. Wattakade, Rajakur, Kallandari PHC in the most of the pregnancy ladies female travel pattern analysis. The analysis, the buffer zone analysis for the 3 kilometer buffer in analysis. The 3 kilometer they using for the analysis. So on the PPT is presented. Hello.
Please continue. There's some issues. Okay.
The analysis for the maybe. Hello. The primary,
Please stop presentation. Okay.
The primary healthcare center, most of the analysis in the analysis. So many other female travel pattern figures analysis. The female most the pregnancy only the adaptation the cesarean, so most of the primary healthcare center. The government hospital analysis. The government hospitals most of the emergency case only the hospitals. So in the subdivision hospital, the primary healthcare centers, so in the emergency for the fever, hawk analysis in the female travel patterns, the analysis in the Panchayati villages. Next. The age structure of analysis for the using analysis. The age structure for the 0 to 14 analysis for the less area in the analysis for the for analysis using the analysis. The less analysis 0 to 14 in the 1 to 40% of the children is the affected only pH is so highly affected for the 15 for 34 analysis for the highly affected in the Kalandari blockchain. Next for age group 15 to 34, the north block in using analysis, the east is the buffer analysis, the mother east block the most in the 15 to 34. The primary health center, the most of the remote area village covered for the analysis. I have conduct for the analysis for the eastern side for the one primary health center using for analysis. Next. 35 to 64 the aged people analysis.
Internal कोई से भी ज़्यादा वो नहीं था.
Hello. The aged people's analysis. The aged people analysis most of the diabetes patients, the sugar patients, the weekly based awareness the primary healthcare centers. The questionnaire based on the survey in the 64% in the testing conversion for the sugar patients most affected in primary healthcare centers. Next. Actually 64 okay. The age wise travel pattern in the primary health, the age category for the 0 to 14 and above 64 travel less than distance compared to the other age group. The main distance travel to primary health care 3.4 km to 2.98 in the respective area.
Mr. Balaji, sorry to interrupt, just I would like to say please conclude your work.
Last only minute, and the age group of 35 to 64 agent on the analysis. The age group of 15 for 34 higher main distance travel 5.1 km for 60.53 km. The people total award in the travel more than travel distance. The age for family 35 to 64 travel longer than in age group in primary healthcare centers. Next. The overlay analysis, the buffer analysis, over analysis, the 0 to 15, 15 to 34, 35 to 64 analysis in the overall travel pattern analysis. The travel pattern the remotely rural area based on our analysis was the eastern variable analysis. The used for the next is the buffer analysis. The buffer in the 5 km, that buffer zone is a 5 km yellow color is the 5 kilometers. Most of the people 5 kilometers using for the analysis in the primary healthcare centers using the analysis. The primary healthcare centers the basically analyze. Next. The over travel pattern figuring using overlay analysis. The Madurai East Bela Kalandari are main primary healthcare facility compared to the private health center in hospital in adapted 5 primary healthcare centers located in.
Please conclude, Mr. Balaji. Please conclude.
Okay, sir. Next. The summary and conclusion. The study concluded the GIS technology is proven the efficient collection present into the character. The Madurai East block, the urban character, the responded majority of the categories. 50% of old people, student, the children, non-worker, the category use the trade population. Likewise, 21.6% people fall under the daily wages. 25% people fall under the private sector in 330 government employee. The majority of the people are the unemployment or the dependents. Next. Thank you.
Okay, thank you. Dr. Vikram.
It was a good presentation, Balaji. I congratulate you on that. But you had written in your methods that you applied nearest neighborhood analysis. Where was that?
Nearest neighbor.
And what did you do in that?
I get on it. Hello, sir.
Yes, I'm saying in the methods, you had mentioned that you applied nearest neighborhood analysis.
Nearest neighborhood analysis, the travel pattern figure, the travel analysis only. The travel pattern is one of the major indicators. The 1 area kilometers only for 5 kilometers traveled used for the primary health care centers. The travel between the travel is a nearest near one travel 5 kilometers or 4 kilometers or 3 kilometers. The 1 kilometer surrounding for the primary health center is using for highly like about the in primary health center. The longly for the 5 kilometers per major for the primary health center in come side in the my PH in East Block only.
Okay, thank you.
Okay, thank you. This is a nice presentation, but I want to say something about that. This is the huge amount of statistics and as well as methodology is strong. But we should know about what are the reasons behind this, because cause and effect relationship is important. I think you may include this cause and effect relationship, why this is high and why this is low, what are the basic problem in this behind. So this research paper or research work will be good after if you include the cause and effect relationship in terms of geographical perspective.
Okay, thank you, sir. I have the disease more of the chikungunya, dengue, malaria patient, the mosquitoes, and after the in East Block, the sanitation used for that. I have affected in the 1 or 2 days or the fever house referred. The test, the blood test to use the test for the urine test, adapted test. The testing using for the affected the chikungunya or dengue or malaria, anyway disease only, you can government hospital they provide. That were not the primary health center. The primary health center using analysis for the small fever, hawk and pregnancy lady only used for the primary health care centers. The highly affected, the chikungunya patient affected, the dengue patient affected, the government hospital in Madurai, Rajaji Government Hospital in Madurai district only.
Okay, we can move next.
Okay, thank you. Nice presentation.
Next presentation then, sir. Can we, sir?
We can.
Yes, sir. Okay, the next presenter is Tanveer Shehnawaz, and he will be presenting on critical studies of ecological critical perspective in Hungary. So, is Tanveer Shehnawaz there?
Yes, ma'am, I'm present.
Yes, please present.
Okay. Good afternoon, everyone. Thank you, ma'am. I want to thank especially to the organizers because my department is English, background is literature. Still, I have been given the opportunity to present my paper. The title of my paper is Critical Study of. I don't have any PPT. I will read the paper. The title of my paper is Eco-Critical Perspective in the novel The Hungry Tide by Amitabh Ghosh. Eco-criticism is an umbrella term used to refer to the environmentally oriented study of literature and the art, and the theories that underlie critical method available to critics to analyze and is concerned with nature writing and ecological themes in all literature. Like pollution, global warming, climate change, deforestation, species extinction, and other ecological exploitation. Amitabh Ghosh, a famous Indian writer, is a leading post-colonial writer of present times, and his works have been analyzed as illustrations of postmodern and post-colonial writing. He has published a number of fictions and has received several awards, honors, and due recognition for his exceptional and exemplary contribution in the field of literature, especially fiction, non-fiction, travelogues, history, anthropology, and journalism. This paper is intended to explore the topic of eco-criticism in the novel of The Hungry Tide by Dr. Amitabh Ghosh. Amitabh Ghosh, The Hungry Tide is one of the novels which have been written in the current era. In The Hungry Tide, Amitabh Ghosh problematizes the strains between and inside human group, their particular relations with the regular world, and the additional desultory reality of nature that hampers and in all the while changed by humankind. The beginning of the novel is set on a train journey where one of the protagonists, Kanai Dotto, a city-based translator, encounters another protagonist, Pia Leroy, or Pia, and he understands by her appearance to be a foreigner despite her Indian tone. The travelers are designated towards a same destination, and they have a purpose to be accomplished, which is the central element of the plot. Kanai Dotto is a translator from Delhi, and he travels to Sundarbans to visit his aunt and get acquainted with the letter, which his dead uncle had left behind. Pia's purpose is revealed through the conversation, and she is to return to her native land from Seattle to find out about a rare species of dolphin as she works as a marine biologist. They depart at Lusibari after Kanai invites Pia to his place as a nice gesture. He is accompanied by his aunt Nilima and surprised to see the changeover of the entire place as he visits Lusibari after a long time. The water flow in the river has noticeably changed and also seems to be muddy. Persuasively, Nilima made Kanai read her entire document, which was in the form of a handwritten diary. She insisted him to read the entire letter for the sake of Kusum, who is dead and an old friend of Kanai in Lusibari. The letter consists of the record of the main events that took place in the year 1979. Later on, Nilima narrates the entire happenings of Morinjapi massacre where Kusum was killed. Nilima introduces Kanai to Fakir's family, and Fakir's son of Kusum, who is a local illiterate fisherman. Kanai comes to an understanding of how unsure the tide is in Sundarban after he interacts with Fakir's wife, Moina. Meeting held in the hospital gave him a perspective as throughout the meeting, Moina was keen about sending their son, Tutul, to school. Moina has deep objection towards her son to ride along her husband, and she has plans for his son to attend school in the near future. Entire conversation doubtless enthralled Kanai as he was clueless about the massacre and Fakir's family's plight. The narration gradually takes back to the memory of Kanai, where he met Kusum in the year 1970, and she was under Nilima's care as Kusum's family is broken apart. Kanai also recollects the performance they watched together the last time he saw Kusum. Parallelly, Pia has come to her native land to excavate a rare dolphin species in Sundarban. Forest Department of Sundarban grants permission for her research, and she seeks aid from the local fisherman. The forest guard offers to help her along with a boat pilot, Mezda. They set off for the destination in the woods, and they reach a particular spot as Mezda proposes that they could spot the dolphin. Pia could realize after a while that these people are not helping and they are just condescending. The reckless attitude of the men intimidated her as she almost drowns in the water. She calls off the entire works as the men are not reliable to help her in any ways. However, Pia encounters Fakir before, and they begin their pursuit in the search of the dolphin to a place called Gorjantola, where they encounter few Tiwari dolphins around the sea. She is overwhelmed as the day is not a failure, and she would mark certain amount of progression in her work. Moreover, the genuineness of Fakir, along with his son, is an added factor in seamlessly pursuing her work. However, the risk is like an inevitable factor as Pia almost lost her hand to crocodiles, which are also present in the water. Pia then decides to seek help from Kanai, who has already invited her to Lusibari. Nilima also offers to help Pia by allotting the Gusam, the guest house, for Pia's stay during her time of research. Meanwhile, the narration of the novel takes the readers through the letter and details the meeting of Nilima, Kusum, and Nilima. Refugees of Morinchapi were in great distress due to various causes and also explained in the letter. Later, Pia, along with Fakir and Kanai, set off to the steamer to continue her study, and Kanai decides to be as a translator between Fakir and Pia. Nilima shows her disapproval when Kanai prepares to leave along with Pia, as tiger kills people every week in Sundarban they are about to visit. This is a strong evidence that government prioritizes tiger over common people, and they are the actual victims. Further, they move towards the Gorjantola pool in order to begin the research. Kanai begins to translate as Pia starts to talk about how she developed interest towards study of dolphins. They encounter endless struggles throughout the stay in the pool. Kanai, along with Horan, decides to leave the place as Pia is able to communicate with Fakir better than the previous time. Kanai learns about a cyclone in the pool later, but he was unable to return to the place and rescue them. Unfortunately, Fakir is hit by somewhat large and he dies in the boat. Pia returns to Lusibari and narrates the whole incident to everyone. Pia also decides the name the project as Fakir. The disposition of the characters in the Hungry Tide by Amitav Ghosh has various factors that impedes their communication, and nature acts as a driving force in order to unite them, as if nature has been personified like man. Kanai's prime duty seems to act as a bridge between Pia and Kopi, but there is a gradual progress in the relationship, where Piali was able to comprehend the information communicated by Kopi. This stems up to the understanding of unity that nature has taught the characters in the novel. The portrayal of the character Fakir has also deepened the addition to the ecocentric narration of Amitav Ghosh. Fakir, the local fisherman, though kills animals for living, also plays indispensable role in conserving them. Amitav Ghosh strives to give ecological solution to the central issue of the novel by effectively connecting past and present. The dramatic sequence of the novel is insisted as there is instinctive call of attention is portrayed through the character Kanai. Post-colonial emphasis also deliberately insists that ecological balance as Amitav Ghosh vividly describes the past and the need for the present change in the environment. Nilima being the strongest post-colonial character.
Mr. Tanvir, Mr.
Yes,
Tanvir,
yes,
yeah, it's just you are reading your paper, so we are waiting for some concluding remarks. So,
sir.
Yeah.
Main among the arrive and the ocean is
because there is no PPT, so we are not getting what you are saying and what you want to tell. So please conclude your talk.
Okay. So displays and ousting are consistent dangers, and assaults by tigers are generally normal. Tigers such as demolish the dependability of life on the island with no notice. Amitav Ghosh, the hungry tide, always talks about the contention among man and nature with regards to the Sundarbans in India and Bangladesh. The novel mirrors the contention between the occupants and the oceanic and untamed life of the Sundarbans. On all levels of the story, in fact, the forces of the global interact powerfully with the local, be that in ecological, economic, or cultural terms. And in the end, an engaged globalism and an engaged localism emerge as co-constitutive and are posited together opposite of force of destructive national and regional politics. Thus, The Hungry Tide is one such novel which has immense amounts of such literature in correlation to nature. The protagonist himself studies nature and the tale tapers on that very note. Amitav Ghosh has remarkably included the elements of caution to every character deployed in the novel The Hungry Tide. Ecology has proved to be a striving force throughout the novel, which alters the way of life people lived in the past and also featured in the present. So there is fear instilled in the Sundarbans, which is depicted to be one of the bravest characters with willpower, fierce nature to safeguard her son's life. So The Hungry Tide takes place in Sundarbans, and it tells revealing relation between man and nature. In this way, The Hungry Tide suggests that all humans can do is to hope, pray, and live with respect and reverence for a place that can kill them as easily as it can provide the resources for human life.
Please conclude. Please conclude. Please conclude.
Okay, thank you, sir.
Okay, thank you. So Dr. Vikram sir, any comments on
Yes, I have a question. Tanvir Shenwas, this is actually a very nice and very interesting topic on which you try to present. But the thing is, since you do not have a presentation, it was very difficult to follow. So for the next time, what I can say is, when you are dealing with such a interesting topic, there are multiple dimensions to this topic. And it is one of the critical habitat of Bengal tiger. So this is a topic which has national importance or international importance. It has ecological implications. But the issue is that nobody was here able to follow what you were saying. So from the next time, it's fine. But from the next time when you present something, it should be that people who are listening to you, your audience should follow it.
Okay.
Okay, that was all from me.
Yes, sir. Okay, so shall we continue further on?
Yes, continue for the next presenter.
Yeah, Vaibhav Deloi. Vaibhav Deloi. Okay, we will go to next presenter, Ranga MPT. Rangana MPT. Are you there? Rangana? Okay. Anwar Muhammad? Anwar Muhammad, are you there? Yahir Kadif Meena? Is Yahir Kadif Meena there?
Yes, ma'am.
Okay. Yahir, please.
Okay.
Present.
Hello? Hello?
Yes, yes, you are audible. Please continue.
Okay. Welcome everyone. Welcome everyone to my presentation, which titled Facile Synthesis of Titanium-based Nanocomposite for Efficient Photocatalytic Degradation of Methylene Blue and Malachite Green Dyes. To give an idea about titanium-based nanocomposite, titanium-based nanocomposite material exhibit a wide variety of unique physico-chemical properties such as large surface area to volume ratios and high reactivity towards photocatalysis phenomena. Due to these properties, the titanium-based nanocomposite employed in various applications such as ion exchanger, these material can be used for water purification as ion exchanger in column chromatography. Also, these materials employed to be used as separator for mixer separation such organic pollutants or any dyes toxic, or as well as for biological mixture which it can discharge into the rivers or streams or groundwater. So in case of energy issues, these materials can be employed to be used as sensors for fire detecting or gas sensing. Finally, recently, this material, titanium-based nanocomposite, employed to be used for as a photocatalyst. Hence, photocatalysis considers as photochemical reaction at semiconductor surface using sunlight as freely available renewable source under natural conditions. By this photocatalysis, we can utilizing solar power to purification of water, either groundwater or seawater. So we have designed some nano material or nano catalyzed to be used for degradation of dyes from wastewater, and our objective was to prepare high efficient catalyst for removal of organic dyes by the combination of conductive polymers with inorganic materials, as well as to obtain new material having high porosity, electrical conductivity, as well as good optical and catalytic properties, which could facilitate better understanding on the charge transfer process in the nanocomposite system. How to design this material? This material has been designed by combination between the polymer, conductive polymer, as well as semiconductor material such as titanium phosphate, and the polymer conductive has been prepared by using oxidative polymerization of monomer orthoanisidine. In first step, the initial oxidative material potassium persulfate was added into the monomer at a low temperature less than 5 degrees centigrade to establish the conductive polymer polyanisidine. In another hand, the semiconductor material has been prepared separately by mixing the titanium chloride with the phosphoric acid at pH 1. In the final step, we have mixed the semiconductor inorganic part with the conductive polymer organic part together in the at low temperature to establish the final composite polyanicidate titanium phosphate. And in the in case of the samarium doped polyanicidate titanium phosphate has been prepared by adding particular amount of the samarium metal ions into the gel of the polyanicidate titanium phosphate. In case of the surface porosity enhanced, we have used surfactant Berg 35 to enhance the porosity of the materials, which it can also enhance the photocatalytic degradation of dyes. So here some characterization of the samarium polyanicidine titanium phosphate and polyanicidine titanium phosphate nanocatalyzed. We have characterized these two nanocomposites by using IR and TGA, DTA to study the thermal stability of this catalyzed at wide range of temperature from 30 degrees centigrade up to 800 degrees centigrade, and the material both of the catalyst was stable in this range. Also, surface analysis of two catalyzed has been also investigated by using SEM analysis as well as TEM analysis and EDX techniques. To study the electrical conductivity and electrochemical behavior, we have conducted these two materials by using four probe methods or technique, and the material was showing a good electrical conductivity. Hence, the electrical conductivity was increased with increasing the temperature in the range of temperature between 10 up to 140. And this behavior due to the thermal activated behavior improvement in the charge transfer between the semiconductor titanium phosphate and the polymer conductive material. Optical properties, the material and band gap of polyanicidine titanium phosphate and samarium polyanicidine titanium phosphate. Both of catalysts were showing good band gap as well as good optical properties. Hence, we have used diffuse reflectance spectroscopy to study the optical properties of both of nanocomposite, and from this analysis we can find out that the electronic structure and absorption capacity as well as the optical band gap of the nanocomposite, which will be helpful into prediction of the photocatalytic activity of the both of the catalyst. From the table, we can conclude that the sample from 1 up to 8 has various values of the band gap, and the highest values belong to sample number 3. We have selected this sample number 3 according to the highest capacity. Hence, the capacity was almost 1.8 milliequivalent per gram, and the band gap was almost 3.76 electron volt. EPR studies of the polyanicidine titanium phosphate and samarium polyanicidine titanium phosphate nanocomposite. To study the unpaired electrons, we have used this analysis EPR studies to find out the electron free, which it can be useful for photocatalytic degradation of dyes. Hence, hence in the presence of electron free, when the material absorbs the lights from the solar source or from any simulation source, the electron will immigrate from the valence band to conducting band. After that, the electron it can consumed by the oxygen and hydrogen present in the aqueous solution to produce the oxygen radicals as well as to produce hydroxy radicals, which are responsible for degradation of the dyes or degradation any organic molecules. From the EPR study, we conclude that the intensity peaks of the present in the polyanicidine enhanced by adding the titanium and samarium due to the electrons which are being trapped by titanium as well as by samarium centers. Also, the defect sites are created in the titanium surface, most probably by oxygen vacancies. And the oxygen vacancies is very important for photocatalytic degradation. Hence, the most of the H2O molecules can be absorbed by these vacancies. These surface sites are responsible for...
Please summarize. Please summarize.
Okay. Photocatalytic degradation of methylene blue and malachite green. In this study, we have used the visible light range to study the degradation of both dyes, and we have found out the percentage or the degradation efficiency of dyes by using polyanicidine titanium phosphate was 94%, and by using samarium doped polyanicidine titanium phosphate, the degradation efficiency was enhanced to be 96% with the rate constant 0.0137. This is the proposed pathway degradation of both dyes, and here the recyclability of the catalyst. Here the stability of chemical stability of catalyst, and conclusion. The mesoporous samarium polyanicidine titanium phosphate and polyanicidine titanium phosphate nanocomposite were synthesized by facial chemical in situ polymerization in micellar media. The nanocomposite, both samarium polyanicidine titanium phosphate and polyanicidine titanium phosphate, were characterized by various techniques. The samarium polyanicidine titanium phosphate shows superiority and high efficient recyclable photocatalytic activity for degradation methylene blue and malachite green dyes with degradation efficiency 95% and 91% compared with the polyanicidine titanium phosphate. This enhancement might be due to doping effect, and the samarium can enhance the partially filled 4F and the vacant of 5D orbitals, which can act as catalyst to promote catalysis. Thank you.
Okay, thank you. Dr. Vikramanga and Dr. Ashraful Alam, sir, any comments on them?
No, I do not have any questions.
From my side, have no questions. Please continue for the next. Yeah.
Okay. Okay, we will go on to the next. Pratik Singhani. Pratik Singhani.
Yes, ma'am.
Okay, please present.
Okay. Can I have a presentation, please?
Pranay, share his presentation.
Full screen, please.
Full screen, please. And you may start. You may start.
Okay. Good afternoon, everybody. Am I audible?
Yes.
Yes, yes, yes. You are audible.
Good afternoon, everybody. Today we'll be discussing about the health effects of particulate matter air pollution. Next, please. Okay, why should we care about the particulate air pollution? Because it is size. The size of particulate matter pollution, it is very, very less. We cannot see with our naked eyes. So it can deep into the lungs and cause very much disorders. And it can be COPD and emphysema and etc. These are all the activities which are previous. Please. Okay, I am presenting this only. What is briefly air pollution? Any undesirable properties which can detrimental effects on humans and as well as the environment whole. We can say that any pollutants like PM10, PM2.5, ozone, SOx, NOx are all the criterion pollutants which are identified by the National Ambient Air Quality Monitoring, which is a standard body which are state some limits of that pollutants. Air quality is basically it's very worsting in all around the globe, and it leads to the emission of the greenhouse gases and ultimately the global warming. It's a reason that health is basically the main effect of the air pollution. Next, please. Okay, my focus is to particulate matter. What is a particulate matter? Particulate matter is a airborne particulate matter which cannot see with our naked eyes. It is consist of solid, liquid, and gaseous pollutants. It may directly emit from the source, or it may be a precursor from the different chemicals also. This is on my left side. These are the electromagnetic image of this particulate matter. We cannot see with our naked eyes. It is very, very small, up to 10 micron, 2.5, up to PM1 nowadays. So sources of particulate matter, it's a precursor. We see in these VOCs, NOx, and SOx are or major criterion pollutant, but they are also leading a precursor role to formation of the particulate matter. Next, please. These are my sources of the particulate matter: mobile sources, stationary sources, area sources, and natural sources. These are the four major sources of the particulate matter. Mobile sources, which includes the transportation and mainly transportation category. Stationary source like industrial and power plants, etc. Area source. Here, my area source is a fuel station, or it's my printing area. It's a home. It's like where particular area which emits the particulate matter. And secondly, the natural sources. Natural sources is forest fires and volcanoes, and in which the carbon monoxide and particulate matter is, all of these are emitted. Next, please. Recently, WHO facts that I am just read out that 9 out of 10 people are breathing polluted air. Around 7 million people are dying due to the exposure of the polluted air. Around among the 700, the 4.2 million deaths are occurring due to the outdoor air pollution, and 3.8 million are occurring through the indoor air pollution. These are both categories given by the WHO. Next, please. Annual exposure of particulate matter 2.5. This is the 2.5 is the size. The mean annual population exposure I am considering about the India here. According to OECD, the mean population of from 1990s, it will be higher to up to 2015. From 59.9 microgram per meter cube, it will be higher to 74.3 microgram per meter cube. So it's also responsible for the various diseases like chronic, 25% of chronic obstructive pulmonary diseases, 16% of lung cancers, and about 17% of ischemic heart disease and stroke. Next, please. Secondly, the premature death is also, according to OECD, that in the year of 2010, outdoor air pollution caused more than 3 million premature deaths, with higher children and elderly people are more vulnerable, because in children the immune system is very weak as compared to our adults. The biggest rises in the mortality rate from the air pollution are forecast in India and China. The Middle East and like India and China are more vulnerable to the premature death because of the population rises, and many of other its developing countries, the resources is also less, the technology is also less. These are main reason behind deaths. Next, please. As you see in this graph, that premature death, this line is considering of 2010, and left side is of 2016. This assumption of OECD that the level in India, that India is more vulnerable for the premature death in coming 2060. Next, please. Kunzil and al. Carry out this one case study in this mice, that he take out the abdominal arteries and exposed to the filtered air and polluted air, and this has 3 strain. And as you see the blockage of the arteries, this is my left side is filtered air, and right one is the polluted air. The blockage of the arteries is seen in each and every strain. So this is conclude that the PM10 it's allowing the blockage of the arteries, and we cannot breathe properly. This is same case with human also. That's a kind of case study in mice. Next, please. What is the control devices? The best way to protect the air and processes. These are items and most commonly used by this industries and transport sector, that mechanical collector, electrostatic separator, bag house, green gases control like SNCPR technology, and each and every technologies are coming nowadays to improve air qualities. Next, please. And secondly, at layman language, at anthropogenic level, at human level, we can also reduce air pollution by limiting our family size, eliminate the toxic chemical uses at house, conserve the energy, reduce the waste. This is mainly municipal solid waste which we are burning in our open sites.
Summarize.
Okay. Next, please. These are the conclusion. The toxic substances are released by burning of plastics, open combustion, incineration, posing threat to surroundings and including vegetation and human health. Proper development of policy with respect to chemical exposure caused by the air pollution must be set in encouraging research in this direction. A sustainable step towards a tomorrow clean and healthier environment needs to be an hour. This would help to mass awareness of severity problem and go to for technologies can less risk hazardous and human health. With reference to this developing nation, the scientific community needs to think and cumulative environment exposure and human health. Next, please. Next. Thank you, sir.
Yeah, okay, thank you. Dr. Vikram Ranga sir and Alam sir, any questions on that?
Yes, I have a question for Mr. Pratik.
Yes, sir.
What you have presented could be fine in a book. So my question to you is, what you have done in it? Where are the maps?
Sir, this is my
the analysis you have done. Is there any correlation that you have done, or something else, some other analysis you have done, geostatistics or something?
Sir, actually, this is my data for PhD that I am not able to show in this presentation. Okay, sir, I'm using this correlation and if the data from this CPCB and all over the globe that having different scientists. So I am collating all the data and come up with a suggestion that how much polluted air is now vulnerable.
This CPCB data, is it online?
Yes, sir. Yes, sir. Nowadays they are putting online the SUFFER program. Now they are launched by the CPCB, sir.
CPCB. Okay, actually, in these presentations or in these kind of conferences, it's really nice if you present something that you have done your analysis or you brought out something new, because whatever you have presented is already known to the community, to the scientific community. But what you can give should be the topic of your presentation. What is your story? What you have found out?
Okay, sir.
Okay.
Okay, sir. Thank you, sir.
Okay.
Thank you. This is the nice presentation. I have a question is that you say that this is the effect of outdoor air pollution and this is the effect of indoor air pollution. You say some percentage also, but how you determine this percentage directly affect the outdoor air pollution or this one the effect of the indoor air pollution?
So basically the main air pollution is two types: indoor air pollution and outdoor air pollution. The indoor air pollution mainly arises from the cooking and burning of the fossil fuels, and that in urban areas that stove which are cooking on this. The WHO is this is a data from WHO, so it is like they are gathering data from that side.
But in your research work, how you implicate this one? Because maybe you select a small area or district, then how you calculate this? Or how you prove this? Hello.
You can proceed. He's not replying. The candidate is not
Actually,
replying.
Continue for the next presentation.
Any correlation or this kind of studies, but he has just shown something. He has collected some data. But anyways.
Okay, sir. Continue for the next presentation.
Okay, the next presenter is Biplab Audia. Biplab Audia, are you there? Biplab?
Yes, ma'am.
Okay, yes, please present your presentation.
Good afternoon, everyone. Myself, Sreenivas PG student, Department of Geography, Sidhu Birsa University, and second author is Riyad Sect, Panchakot Mahavidyalaya. My research topic is urban planning and smart cities in India. Introduction. Urban planning is a large-scale concept concerned with planning and development at all levels like architecture, infrastructure, economic and ecology. Urban planning is a technical process for development and use of land property, protect the environment and sustainable use, try to make a pollution-free environment. Urban planning and urban design is closely related of same the field. Urban planning protect urban environment and other related things that there is smooth life security in the urban areas. Settlement planning also related within urban planning. A smart city is an urban area use different types of electronic methods and sensors to collect data for city development. Next objective. To know about the smart city mission, to know the importance of urban planning, and to understand about the major urban planning and urban development programs in India. Next is the smart city selection process. The smart city selection process is two stages. To select the smart cities, step one, inter-state city selection on objective criteria to identify cities to be complete in the stage 2. Second step is all India competition to select smart cities for multiple round of selection. Next is smart city mission. National Smart City Mission is an urban renewal mission organized by Government of India. The Union Ministry of Urban Development is responsible for implementing the mission collaboration with the state government of the selected cities. This mission included total 100 cities and the project has between 2019 to 2023. This project launched in 2015, founding 98,000 crore on 7th September 2019. The 10,000 acre Aurangabad Industrial City AU-RIC in Aurangabad, Maharashtra was the first greenfield industrial smart city in India. Each smart city will create a special purpose vehicles SPV 48,000 crore for the smart city mission and a total funding of 15,000 crore rupees for the total mission of and urban transmission AMRUT approved
Please
by
don't read
cabinet.
the slide. Please don't read the slide.
Yes, sir. Nearly 31% of India's total population lives in the urban areas, and there are total 5 rounds for selection the winners of 100 smart cities. In the first round, 20 number of smart cities. Second round, 30 number of smart cities. Third round, 27 number of smart cities. Fourth round, 30 number of smart cities, and the last one is fifth round. Winner selection of 10 number of smart cities. Importance. There are many importance of urban planning and city planning. It is the art of giving safe design and structure to cities and towns. Urban planning and city planning and town planning plays a very important rules. The importance of urban planning or town planning are offer a better quality of life, make cities less effect efficient and renewable waste management system, better infrastructure, create good educational and health facilities, create many job opportunities and other economic opportunities. History, urban or city planning was emerged as a scholar discipline in the 19th century. The Great Britain, the first academic planning program began in 1909 at the University of Liverpool. In India, it is a old as it rich culture and tradition. There are flowing are the developmental stage of towns or urban and smart city planning. One ancient India Vedic period. Second one is in Indus Valley civilization. Third is Buddhist period. Fourth is medieval period, and fifth
Mr.
is
Biplab,
Mughal period.
kindly
Yes, sir.
present what you have done.
Yes, sir. There are some major smart city urban planning and development program in India. The Smart City Mission, Atal Mission, AM, RUT project, Pradhan Mantri Awas Yojana, Urban or House for All by 2022 mission, Pradhan Mantri Awas Yojana, Urban or Housing for Heritage City Development and Agglomeration Yojana.
Please summarize.
Jawaharlal Nehru National Urban Renewal Mission, Urban Transportation Swachh Bharat Mission, SBM, etc. Conclusion: urban planning created for city development and ensure peace of harmony between people and land use. Urban planning means in where a city from and function coverage. Urban planning or city planning develop and implementation plan and policies for development in the urban areas. Physical aspects like building, land use, roads are play an important role in urban planning. Some references are. Thank you.
Okay, thank you. So, Dr. Vikram sir and Dr. Ashwin sir, some comments, sir?
To Mr. Biplab, actually, he has also done the same thing what the previous presenter has done. They have just collected the data from government website. My question is, where is your work? What have you done? You talk about urban planning in smart cities. What you have done? What is your part in this? In all of this? Mr. Biplab, can you hear me?
I think, sir, it's just a kind of review. He didn't do any work. It's a kind of review. So,
I think we can go for the next presentation.
Yes, please.
Okay, the next presenter is Nishant Kumar Mahapatra. Nishant Kumar, are you there?
Yes, ma'am, I am present.
Yes,
yeah,
please.
it's your turn.
Good afternoon, everyone. Today, myself Nishant Kumar Mahapatra, and my topic is groundwater quality analysis around Champua block of Keonjhar district of Odisha, India. Then, first points to be discussed. Introduction, methodology. Sorry, I have repeated the point. Resultant discussion and conclusion. Then, next slide. This is the brief idea of my study area, which is situated in Keonjhar district of Odisha. It is just the eastern boundary of the famous Bani Keonjhar iron ore belt. This is situated 46 kilometers north from the district headquarters. It is surrounded by areas like Jhumpura, Joda block of Keonjhar district, Singhbhum iron ore belt, and Mayurbhanj district. The river Baitarani, along with its tributary Aradai and Narmada, constitutes the drainage system of the area. And the area have the hydrogeometric features like buried pediments, pediplains, valleys. According to it, constitute 95% of the area. Then comes to geology of the area. The area is mostly consist of hard rock terrain that is composed of Singhbhum granite, schist and gneiss. Singhbhum granite is may have it is a igneous rock, and schist and gneiss are very hard metamorphic rocks. So groundwater occurrence in the area is mostly due to the fractured and fissures through the rock formations, and we have found very less weathered residuum in the upper part of the rock. So next slide, please. Then comes to the methodology. I have collected water samples from 45 tube wells and 15 dog wells covering all over the area during the pre-monsoon period of 2020 using standard methods. The field parameters like pH, EC, TDS were measured in the field by using portable meters. Then samples are taken to the laboratory, and I measured the rest chemical parameters using the standard procedures as suggested by Apha, Trivedi Goel, Brown et al. And Hem. Then I have presented the sample data in suitable classification schemes and diagrams. Next slide, please. Next, this is my block outline, and these are the sample points which I have shown. Then next slide. These are the parameters I have tested, and these are their minimum, maximum, and average value. It is impossible to give all the data here, so I give only the minimum, maximum values. Then next slide. Then I have compared for the suitability of drinking purpose of the water, I have compared the water quality with the standard method proposed by Indian Drinking Water Quality Standard, that is BIS 2012 standard. And I have found the result, very few samples are exceed the acceptable limit of the standard, and there is almost no sample which are exceed the permissible limit. Next slide, please. Then these are the spatial interpolation map of different parameters. The first one shows the TDS value. Second one suggests the total hardness. Third one suggests the calcium, and fourth one suggests the magnesium. Next slide. And these are chloride, fluoride, nitrate, and iron value. This is made with the help of QGIS software using spatial interpolation technique. I use inverse distance weightage method for the work. Then this is the Gibbs diagram, which tells us about the effect of controlling factors on the water quality. And you see that most of the points falls on the rock dominance zone. That is, the quality of the water is mainly affected by the rock type of the area. Next slide. Then this is the Piper trilinear diagram, which we used to determine the hydrochemistry of the water. And you see most of the samples falls in the 1 and 3 zone, which indicates that alkaline earth elements, that is the calcium, magnesium ion, are the dominant cation, and the weak acids, that is the carbonate and bicarbonate, are the dominant anion in the area. Next slide. Then this is the chart dash diagram, which is you can say the extension of the Piper diagram. By plotting my sample points on the chart dash diagram, it also gives the same result, that the alkaline earth are the dominant cation and the weak acidic anion are the dominant anion in the study area. Then next slide. Then to determine the suitability of water for irrigation purpose, I have calculated various ion ratios like percentage sodium, sodium adsorption ratio, residual sodium carbonate, potential soil salinity, magnesium adsorption ratio, and Kelly's ratio. Due to limited slide, I can't give the formulas in the slides, and I put the values in standard classification schemes as proposed by different scientists.
Please summarize.
Yes, sir.
Please summarize your topic. Conclusion.
Yes, sir. It is almost over, sir. And I see the results that most of the samples are in the excellent to good region, falls in the excellent to good region for irrigation purpose. and finally the conclusion. So based on the drinking water quality standard as proposed by BIS, we found that most of the water are suitable for drinking purpose, except a few. And we found due to more calcium and magnesium ion in the water, we found some hardness, and very few area there is fluoride contamination, which I might think due to the impurities present in the granite rocks. And the Gibbs diagram suggests that the water quality is affected by the rock type of the area. The Piper and Chardas diagram suggests that the calcium magnesium are the dominant cation and the bicarbonate are the dominant anion of the study area. And from the irrigation parameters, we get that most of the water are suitable for irrigation purposes, except a few due to magnesium adsorption ratio and more TDS value. So almost the water of my study area is suitable for drinking and irrigation purposes, except a few. Okay, sir. Thank
you. Thank you. Dr. Vikram sir, Dr. Ashraful sir, any comments on it?
No, I do not have any questions.
Okay, so we can continue with the next speaker.
Yeah. This is nice presentation. We can conclude for the. We can go for the next presenter.
Okay, the next presenter is Subhashish De. Subhashish De, are you there?
Yes, ma'am, I'm there.
Okay, yeah, please.
Yeah, am I audible to everyone? Hello.
Yeah, you're audible.
Yeah. So can I get the presentation, please? So a very warm good evening to one and all present over here, and I'm thankful to Suresh Gyan on the topic. So my today is Room for Rivers, a sustainable alternative to conventionally engineered and structural measures for controlling catastrophic floods in Assam, Northeast India. Next slide, please. So currently I'm an undergraduate student at the Department of Geology, Cotton University, Assam. And here I present before you on this very topic. Next slide, please. So what we are going to do is basically learn a bit about what is Room for Rivers, its effectiveness in dealing with the calamitous floods in Netherlands, and why the state of Assam in Northeast should adopt it too. Then we'll go on to finding out about the disastrous Assam floods in a nutshell. Then we will also analyze that how the conventional flood control measures such as dams and embankments have miserably failed, especially in the states of Northeast. And ultimately, we will sum up by stating the sustainability that has been associated with the model of Room for Rivers and how it can actually help in mitigating Assam floods. And we can also try to establish the estimated and expected results. Next slide, please. So the fundamental aspects associated with the Room for Rivers models are this. So basically the Room for Rivers model was adopted by the Dutch ministry and the Dutch people when there has been catastrophic floods in Netherlands. So after the 1990s calamitous floods in Netherlands, the Dutch government decided to work on a program, and they ultimately formulated a project named as Room for Rivers, which ultimately started functioning from the year 2007. So these were basically functional in working for 4 rivers: Rhine, Meuse, Wal, and Isel. So basically the Room for Rivers model was trying to create landscape that would work as sponge in events of extreme floods. At the same time, they were basically trying to create room for rivers so that during extreme events of calamitous floods, there is a natural way for the runoff to go away, and that it does not take off any life or cause any bad human effect. So the aspects that are associated with the room for rivers are the deepening of the summer bed. So in the deepening of the summer bed, we see summer bed basically refers to the main river channel, whereby the process of dredging, the main area is excavated, as a result of which more room is provided for the river to move during times of extreme flood. The second one is dike relocation. The previous one, please. The previous slide. Yeah, the next one is dike relocation. When we relocate a dike, in Assam also we have like more than 2,000 dikes, and when we try to relocate the dike from one place to the another, what we are doing indirectly is we are creating more space between the dike and the flow of river, as a result of which more space for flood water is created. Another most important thing is that we are lowering the floodplains when we are accepting the model of room for rivers. When we are lowering the floodplains, what we do is basically excavate the floodplain, which is full of silt. Now, likely the rivers in Netherlands, also the Brahmaputra in Assam brings a lot of silt, and if we can implement the same model here, it would be really very helpful in mitigation of floods. Now, another most important aspect of the room for rivers model is that, which we can implement in the state of Assam, is remove all the obstacles and the high water channels that are present in between the flow of the river, and is giving catastrophic results during times of extreme flood, which is generally during the time of monsoon. So the Water Resources Division website generally has the flood data up till the year 2006. So I basically approached, next slide please. So these are basically the diagram that show as to the various processes associated with the room for rivers. Next slide please. So when we talk about the catastrophic Assam floods, I think everyone knows about the Assam floods. According to the October 2020 data, around 123 people were killed, 5,474 villages were affected, and so on. So the Water Resources Division website in Assam has the data of floods till 2006. But when I approached the executive engineer of the Water Resources Division, asking him prior data prior to the year 2019, he gave me the following data, that 78.522 lakh hectares of land in Assam, out of which 31.05 lakh hectares are flood prone. The flood prone area of the country stands at 10.2% of total area of the country, but flood prone area of Assam is 40% of the total area of the state, which is exactly 4 times the national mark. So it's a very catastrophic and very serious mark. In 2015, he also gave us the data that in 2015, a little less than 1,000 persons died of floods and rain related issues. But in 2019, 2,500 persons had lost their lives according to the government data. So shows in this time of highly modernization and urbanization, with various flood hydrological research going on, Assam is still not able to cope up with the floods by making use of the old conventional ways. Now, this calls for the implementation of an extremely new model, that is the room for rivers. Now, the Dutch model for the room for rivers is sustainable and self-sufficient model, and actually can help mitigate the catastrophic floods in Assam. Next slide, please. So these are basically the pictures in areas of Dhemaji and Lakhimpur that are the districts situated in Assam during the times of June to July in 2020. Next slide, please. Okay, dams and embankments are long untold story of disaster. So this basic engineered way to cope with flood have actually cost Assam and cost India a lot of money, but eventually have been very weak in controlling the humongous floods in the state of Assam. So according to our analysis, we have clearly established a various facts.
Summarize, please summarize.
We have also tried to talk to the senior researcher who has been tried to deal with the transboundary water relations. He has told us one of the major drawbacks of the dams and embankments is that it stops the silt from coming. And as we know that Assam is largely dependent on agriculture, the dams and embankments that actually stop the silt actually affect a large portion of the agri economy, and people are found in miserable condition. Secondly, the embankments mostly in Assam are earthen embankments, and they're not concrete embankments, as a result of which they mostly cannot control when the floods come in full force, and as a result they break. Another most important thing that we have found out via this research is that there is a thing called levee effect. So basically, according to the levee effect, what happens, or the embankment effect, when people see the construction of many dams and embankments, they have a sense of unwarranted sense of safety. This, yes, when floods will come, will be safe. As a result of which, they start moving near the river banks, and unfortunately, when the floods hit, they lose their lives.
Please conclude. Please conclude.
Yeah, yes, sir. The last.
Please conclude.
Yes, sir. So the room for rivers, how can it mitigate Assam floods? Because it is cost-effective and self-sustaining model. It has an extremely low failure rate, 1 in 10,000 years. There is no waterlogging, no devastated farmlands, no diseases. Goes hand in hand with ecology. Next slide, please. So these are the two maps that shows before and after the room for rivers implementation in Netherlands. Next slide, please. So these are the floods in Assam. As you can see, the severity of the floods, the blue line shows. The next slide, please. So these are my references. Next slide. Yeah, thank you, everyone. And I would like to seek your suggestions and your valuable feedbacks, and you can contact me at my email listed below. Thank you so much.
Thank you, Subhashis. Dr. Vikram Ranga sir and Dr. Asfar sir. Hello. Yes, sir.
Like
Any comments, sir?
Subhashish for a very nice presentation, but I have one suggestion for him.
Yes, sir.
If you think that this Holland model can be implemented in India, then you should try to pick one river and then show us how much area will be affected. I mean, how much area will be saved, how many lives will be saved, how much volume of water will be directed to the sea instead of going into the residential areas. That you should try to do.
Okay, sir. Okay. I'll keep this in mind, sir.
This is from me.
Dr. Ashraful sir.
Okay, continue for the next.
Okay, we will go to next presenter. The next presenter is Riaz Ahmed Amir. Is he there? Riaz Ahmed Mir. Riaz Ahmed Mir, you are there? Okay, we will
Yes,
go to the...
I am online.
Okay, Riaz Mir, please present.
Please, can you share me my presentation?
Yeah, please.
Good evening to all. I am Riaz Mir from Srinagar. So my topic of the talk is recent dynamics of Kolhai Glacier, Kashmir Basin, Western Himalaya. Next, please. Is it changed? Hello?
Please see to the screen. Yeah, it's changed. Please see to the screen.
So, nothing is changed on my screen.
It will take few seconds. So please be patient. It will take few seconds. Yeah.
Okay, sir. Actually, I am doing it on 2G internet speed in Valley. So I will try to correlate my this transmission with this transmission.
So what you can do is parallelly open the slides in your
yes.
presentation,
I
and
will try to
be matching with your speed.
Okay. So after this first present slide, I am going to next slide, background. So I would like to recall that Himalayan region actually covers more than 40,000 square kilometer of area that affects the living of over 300 million people living in this region. And we also know that climate change is going on, and this is one of the greatest threat for the existence of these glacial resources in the region. There are so many studies which suggest that climate is the main factor causing the glacial loss, but there are also studies which suggest that there are so many other factors like topography, debris cover, some morphometric parameters that affect the glacial loss. That is, we see the heterogeneous pattern of glacial loss in the region. Next, please. Kolhai Glacier is the biggest glacier present in the Kashmir Valley. That is the main source of River Jhelum. Jhelum River is the backbone of the economy of the people of the Kashmir Valley. And this glacier is named actually after the Kolhai peak, that is goddess of the light, that is called in Kashmiri language. So this is also reported to be the fastest melting glacier in the Himalayan region. People have worked extensively on this glacier. Am I audible?
Yes, audible.
Yeah, you're audible. Continue.
Hello? Am I audible?
Yes.
Yeah, you're audible. You continue, please. Continue.
People have worked extensively on this glacier. People have studied this glacier from last century. There are studies on geomorphology, paleoglaciation, recession areal loss, and research studies have focused on modeling the glacier contribution to the leather stream that is coming from the Kolhai group of glaciers. And there are also studies that have tried to study the influence of climatic parameters and response of this discharge with respect to the glacier shrinkage in this area. So here I come to the study area. This is an overview of our study area. Here you can see the middle figure. You can see this is the Kolhai group of glaciers. There are so many small glaciers around this large glacier that is the main Kolhai glacier. And here you can see, if you can see on the western side of the slide, there are the two sub-catchments or basins, that is Sindh catchment and Leather catchment. This glacier is actually located exactly at the water divide of these two sub-catchments of Jhelum Basin. And here you can see we have divided this glacier into two parts, that is Kolhai 1 and Kolhai 2. And here on the eastern side of slide, you can see the close view that is of Google image. You can see how this water divide is being demarcated on this, which we have demarcated after using the automated technique using Oster dam. So here people have actually studied this whole glacier and attributed this glacier to the Leather catchment. But here we have tried to study the response of these. First, we have tried to divide this glacier into two parts and then study how these glacier parts of this main glacier respond in this ongoing climate change. For this purpose, we have used satellite data sources and some ancillary data like SOI maps. And we have carried out so many techniques of the glacier mapping, like manually, and we have used different FCCs. We have used automatic techniques, high resolution Google images. We have also carried out detailed estimation of errors and for the accurate and correct demarcation of this glacier. And why we have carried out this extensive mapping on the, I will be discussing that in later slides. Next, please. So here I came to the results. Here you can see these general characteristics of these two parts of this main Kolhai glacier. Here there are some
He has disconnected.
He got logged out. We will wait for him for some time.
So can we continue with the next presentation?
It's not a network issue. We can continue for the next presenter.
Okay, so I will.
If he joins, we will allow him for presentation if he joins.
Okay, sir. So the next presenter is Saima Farooq. Saima Farooq, are you there? Is Saima Farooq, are you there? Okay, the next presenter is Gyan Prakash Sarkar. Gyan Prakash Sarkar, are you there? Gyan Prakash Sarkar. Okay. The next presenter is Sadia Mazahari. Sadia Mazahari.
Yeah, it's Sadia Mazahari, not Sadia Mazahari. I'm here, present here.
Yes, Sadia Mazahari.
Yes, I'm present.
Yeah.
Oh, wait, just let me increase my volume. Yeah, can you please show my presentation on the screen?
Yes.
Okay, thank you so much. Good evening, everyone. So the topic of my presentation is land use, land cover changes in Sajnam catchment, Lalitpur district, Uttar Pradesh using remote sensing and GIS techniques. So first of all, I would like to say that I have made my presentation very precise. So I would just like to give a brief introduction about my topic and my area. So what is land use? That land use is referred to number of operations that are carried out by humans on land so as to produce benefits from the natural resources. Whereas land cover is defined as the type and state of vegetation, for instance, forest, grass cover, and which has even widened up to include human structures like pavements, buildings, and other aspects of natural resources such as type of soil, biodiversity, etc. And remote sensing plays an important role in acquiring spatial and multi-temporal data through space-borne remote sensors. And it is quite useful in analyzing land use and land cover changes, for instance, from arable land to impermeable surfaces, etc. Please, can you change my slide? Thank you. So the study has been carried out in Sajnam catchment. It is situated in Lalitpur district in Uttar Pradesh, in the region of Bundelkhand, and it provides an insight to land use, land cover changes using remote sensing and GIS techniques. And this area comes under 24 degree 10 minutes north to 25 degree 14 minutes north latitudes and 78 degree 10 minutes east to 79 degree 00 minute east longitudes. While the geographical area of the district covers 5,039 square kilometers of total. The study has been carried out by multi-temporal IRS data of 2005 and 2015, which has been visually interpreted to derive thematic maps on drainage, land use, land cover, dam, and slope. And the information from dam which I get was that dam and slope map have been generated from Aster. That I have generated from Aster, and the elevation that is shown by the area ranges between 351 to 559 meter above mean sea level, while slope map shows that the major part of the area falls under gentle slope category, because the area has been divided in a gentle, moderate, steep, very steep. So this area comes under gentle slope category. And the software which I have used utilize GIS, ArcGIS, EDA, Simagine, and Saga, and other. Can you please change my slide? Thank you. This is the location map and base map of the area. This is the clipped, this area is the base map of my area. Can you please change the slide? Yeah, this is the clipped catchment from the topographic map that I have get from Survey of India, and this area comes under 54 by L and 54 by 10 topo sheet. topograph. Can you please change my slide? Thank you. This is the satellite data of IRIS P6-3 of 2005. And in next slide, I'll show the data of 2015. Can you please shift the slide? Can you please change the slide? Hello? Yeah, thank you. So what I have analyzed is that I have done analysis on categories like cultivated land, uncultivated land, dense forest ridges, water bodies, wastelands, etc. So the land use land cover analysis of the study area reveals a wide variety of different categories of land use land cover that I already named, that cultivated land, uncultivated land, dense forest ridges, water bodies, wasteland, settlement. And this shows that the catchment is mainly dominated by uncultivated land, that I will show in my next slide. And cultivated land and dense forest. No, please back the previous one. Okay, thank you. So cultivated land, dense forest. So uncultivated land, cultivated land, and dense forest. These this area is mainly dominated by these three categories, while settlements and wasteland are also recognized in association with water bodies and cultivated fields. Can you please shift the slide? Thank you. So here you can see in this map which I have digitized, that the yellow part, that is the yellow part shows the cultivated land, green shows the forest area, brown shows the settlements, uncultivated shows by beach color, blue showed by water bodies are showed by blue color, and the last one is wasteland. It is the analysis of 2005 data set. Now can we go to the next slide? Yeah. So what I have found, you can see that in a decade, that is in a 10-year difference from 2005 to 2015, what I have found that cultivated land has been increased, and the forest area is less or more is almost equal, and water bodies is almost equal. So what I noticed mostly, what I have analyzed, that the cultivated land has increased so far. Can we shift the slide, please? Yeah. So what I concluded that the land use land cover changes that I have done by LULC analysis, that is land use land cover analysis of 2005 and 2015 IRIS P6-3 data sets, suggest that uncultivated land, dense forest, ridges, and wasteland has been decreased, whereas cultivated land, water body, and settlement has been increased from year 2005 to 2015. The study demonstrated that the Sajnam catchment is dynamic in nature, as it has shown remarkable land use land cover changes during last 10 years. Hence, effort should be made to bring uncultivated land into cultivated land through various land soil development methods, as this area is typically known for recurring droughts and scarcity of water during last couple of decades. And conservation efforts are also required to achieve sustainable development of natural resources. This area also the problem of this area is mainly water scarcity. There's low rainfall, droughts are occurred, and what I concluded is just in front of you, and thank you so much.
Thank you, Shadia.
Thank you, sir.
This is one of the good presentation, but I have some observation is that in your study area map, where you use only one scale, and in India perspective, have no scale and latitude, longitude, but if you use the software and prepare the map, so you should mention the scale as well as the latitude,
Yes,
longitude?
yes. Actually, sir, I would. I saw. I'm sorry to interrupt you in between, but as I got the mail that I have to make my presentation very precise, so I did not put all that figures in my presentation. I would like to say that the scale which I used is 1:50,000 scale I used, and I thought whatever all these details like the topo sheet number and the area, latitude, longitude, and the scale. I will just speak on the spot. So
Okay. Another thing is that land use, land cover, and then the changes you can calculate, but you should may represent the table in terms of how many land use, land cover changes in the agricultural perspective, in forest, and in basically the temporal changes. What kind of temporal and how much these changes and what kind of effect in our society as well as the environment, it may be included in your paper. It will be appreciate for the and understanding for the all people. And another thing is that at present time we use the GIS and remote sensing in term of land use, land cover perspective, but accuracy assessment is important. How much accurate you work in that perspective, what are ground truth validation is important. So you may include the ground truth validation. That will be the helpful for the all perspective research as well as your perspective. Thank you.
Thank you so much. Thank you so much, sir. I'll just keep it in mind, and I have done it on my dissertation, but I have not put it here. Just I just made my presentation so precise that was just the reason. Thank you so much. I'll keep it in mind for the next time. Thank you just for your valuable suggestion. Thank you so much, sir.
Welcome.
Yes, please go ahead.
Okay,
The
next is Nakib Burhan Rahmani.
Yeah, Mr. Ramani, if you are ready with the presentation.
Please, if you're ready, present.
Yeah, yes. Yeah, Mr. Ramani, one request, just try to conclude it within 10 minutes. So we will complete all the sessions on time.
Okay.
Yeah, you can continue, please.
Good afternoon, everyone. I'm Chief Mentor student in IT Warangal. First of all, I want to say thanks to the organizer for this opportunity. And my topic
Please, all other participants, mute your mic, please. It's disturbance.
Okay, my topic is about climate change impact in water resource case study area, watershed in Afghanistan. And I'm going to the next slide, brief introduction about climate change and what is the model which I used in that our project, and what is the result which I get in this. Yes, sir. Climate change impact, which is how the brief change in the parameter of the weather, like temperature, precipitation, and stream flow. I work only in this three parameter, which is changes in my case study area in Chak watershed in Afghanistan, and the model which I used in this project, it is soil and water assessment tools for seaming distribution model, and the data which I provide, it is remote sensing data all, and that for calibration and validation I use SWAT-CAP. And climate change variation, it means state of climate variability of its property, and it is also climate change. We can use in this model for long period, for 10 years, and for more than 10 years we can analyze the climate change in this model. And also we use for predicting for future climate change, and from 2020 to 2015 two model, which is a general circulation model and RCM model also. The remote sensing, all data which I provided, it is remote sensing data, which is the GIS provide a platform for our hydrological model. The main object of my research is climate change. Another is which model I use. It is SWOT model and stream flow. I only working by stream flow. What is the change in our study area in Chak water sheet? It is increase and decrease. This is the main point in my research. Next slide, sir. I ignore that literature review because the time is not. Okay, this is methodology. We are using two types of data. One is geospatial data, and now geospatial data. The geospatial data is which necessary for my project for climate change impact, and for SWOT model, it is DIM data, land use, land cover data, and soil map data. And now geospatial data, which is the observed climate data, which is including precipitation data, precipitation maximum, minimum temperature data, and also river humidity and another, and climate data for historical and future prediction also after bias correction. And SWOT model, after SWOT model, we are which we get the result, we are going to for calibration the SWOT cap, which we are giving the result by giving the pitted parameter and analysis climate impact, the final. Okay, next slide, sir. Next slide. Study area, which the water sheet, the Chak water sheet is one of the imported water sheet. It is integral to the local economy of Afghanistan, and it is located area is 5,831 kilometers square, and it is the plan with steep slope, maximum from 4,000 to 2,000, and it is including to the rock and valley. That it is very important for three provinces of in Afghanistan, where the Rugar and Kabul province. It's how economically issue and industrial growth in the climate change. This next slide, sir. Which data I get it from where and which data I used for our project. It is DIM data by 30 meter resolution from USGS, and also land use land cover data, which is I made by from Ministry of Agriculture in Afghanistan, and weather data from the local station, which is Sanginusta hydrological station, precipitation, temperature, wind speed, and solar radiation and river humidity. It is also provided by Ministry of Water and Energy Source from Afghanistan, and for future prediction, we for 13 global station data downloaded from by 0.25 resolution, which is only including precipitation and temperature, and also soil data by FAO data, and observing this monthly data, which is from Sanginusta. It is a station from Afghanistan from 2006 to 2018. It is also provided by Afghanistan, which is already keeping in the Ministry of Energy and Water. Next slide. It is the type of our result and type of the soil in our area, in our study area, which is 4 types of soil by different texture, clay, and silt and sand, which is including in our study area. Next slide, sir. The model which I use, it is a SWOT model, your soil and water assessment tools, which is the semi-distribution contribution like fair unit hydrological quality and quantity model. We can use this model for hydrology, weather, sediment, and also soil temperature, growth claim. It is working in the ArcMap platform. It is using also in QGIS and ArcGIS, and easy for predicting. And we can analysis and assessment the very long period hydrological data. It is the model which I use. It is SWOT model. The main Pakistan is SWOT model. This 4 menu and 4 which I show in the image, like or SWOT, start the project, which data I adding to the station, the station data, and also land use, land cover data. Before we ran our SWOT model, we read all the data by hydrological data, land use, land cover data, or geospatial data, and then put to the our SWOT, EOQ SWOT, and run the SWOT model. And next slide. This is the result of SWOT. It is showing the hydrological response unit, which the count number is showing, which the value is most of the rainfall to upper the runoff.
Summarize fast.
Okay, go to next slide. This is also the result depiction for the value, but it is not the main conclusion. Go to the next slide, sir. All this is the SWOT cap or calibration I use, which algorithm and that is the result of SWOT cap, like ORCSWIR, Nash coefficient, and also the P factor, R factor. And this is the pitted parameter which I for calibration and global analysis. Also, I done in my project, which is the runoff cover number is more sensibility. The model which was used for future prediction is GCM or RCM model. Next, which is CCMS4, and also BCC CSM 0.15. This is two model I downloaded, both RCP with both RCP after the bias corrected data. The output of the ORCSWOT, which this is the poor data like subbasin, watershed subbasin, and next we have land use, land cover map, and next we have the drainage reaches, and the type of the land and the type of the soil, which is all this is extracted from the ORCSWOT. And the result, the most important thing is in the climate change impact in this area, in the Chak watershed, it is the positive climate change, because here is the temperature is decreasing, and also stream flow and precipitation is increasing. It is really a good and news for our area, and the maximum minimum temperature variation is from 1.8 to 2.2, and like it here is also showing in the month of the June, July, and October, the black line is showing the historical data, but the poor model and both scenario or CFI 4.5 and 8.5 is showing the temperature, the maximum temperature is decreasing for 1.8 to 2.8 degree different. And also in the seasonal analysis is also showing in this next slide, sir.
Summarize
here
fast.
Is also
Summarize fast.
Precipitation is also decreased from 50 mm to 136 mm, and this poor month, March, April, May, and July. Sorry, sir. Go to the stream flow. Next slide.
Conclude. Please conclude.
Next slide. This stream flow analysis is cumulative. This cumulative is important. Seasonal analysis also showing the stream flow is increased. All my result is the stream flow. One thing is the final conclusion is in my all study, temperature is decreasing and stream flow and precipitation is increasing from 50 to 138 and this is the summary, the final result which I used, which model I used, SWOT model, which algorithm for calibration ICP2, and the model for future prediction is RCM, GCM, and it's completed, sir. Next, finish. Thank you, sir.
Thank you. Dr. Vikram Ranga sir and Dr. Ashraful sir.
Yes, it was a good work. Please go ahead with the next presentation.
Okay, the next presenter is Dr. K.R. Padma.
How many presentations left? Sorry to interfere. For today's
Sir, those who have already sent our PPT, if they have been already finished giving their presentation. These are the presenters who have not sent their PPTs but are present here and are ready with their presentation.
Okay, so I can see Dr. Padma, she has responded to our chat box for the
Yes, sir.
candidates who are willing to present today. And there is another one from
Lucia
Lucia
Plantup.
Plantup. So we can stop with this two presentation for today's session because I don't
Yeah,
think that anybody else are there for presentation today.
yeah. Okay, sir.
So we can
So,
exhaust the list for today's presentation
after this
after
Plantex,
this two presentation.
Can I start, sir?
Yeah, please.
Okay. The impact of climate change on agricultural production, which is a short review. I am Dr. K.R. Padma, who is working as an assistant professor at Shri Padmavati Mahila Vishwavidyalaya, along with my co-author, Dr. Don. I am presenting this paper. So generally, we all know that the change in the nature's law is inevitable, and because of this, all the agricultural production is being changed a lot, and the crop production is being decreased, and farmers are facing many problems due to this climate change. And the climate, if you take it, is the primary determinant of the agricultural productivity. So the fundamental role of any kind of agricultural in human welfare concern is that so every federal agency or trying to improve the agricultural productivity. So interest is being motivated in order to study about the research on the climate change and agriculture over the past decade. So my point of view is that this climate change, if we study the proper concentrations and enhance the productivity based on the agro ecosystems, we can increase our productivity. So we must know the difference between the weather and climate. Both are not the same thing. So weather, if you take, it's a very short term and can rapidly change, and also very difficult to predict. So climate is the basic reason for the agricultural productivity, where you have to concentrate on the temperature, rainfall, how much of the wind, sunshine, solar radiation, and the carbon dioxide level based upon the photosynthetic activity. So all this will be concentrating on the agriculture, that is the crop yield. So climate, if you take, it's a long-term weather patterns, and it is important that in order to increase your food productivity, both the weather and the climate are playing the key factors. So both are open. So both are necessary for the high production vulnerability. So basically, the other things that is affecting the greenhouse gases is that deforestation, burning of crop residues, and the nitrogen fertilization, raising large herd of cattle and other ruminants. So these are all the things that are affecting our climate, and also other factors like abiotic factors, biotic factors. So some effects of the climate change. So because of this climate change, there is like a tsunami can be there, floods can be there, droughts can be there. The crops get damaged due to the sudden climate change. And because of this, the agricultural productivity will be decreased. So predicted climate change impacts on the agriculture. So climate change, they have a direct impact on the crop growth. So both the physical as well as the morphological growth. Indirectly, it is affecting the soil fertility, irrigation availability, and the socio-economic concern is that the farmers' response is that the trade and other things get decreased. So all these factors are important in the agricultural productivity. So the rainfall is also important. How much amount of the rainfall is going to fall, that is also important. The amount of the regularity of the rainfall always varies with the location and the climate types. So based on this potential impact of the climate factors, basically one study was studied in the rice production in Pakistan, where they have shown that the overall temperature increase or predicted to reduce the rice yields. So we have to maintain the temperature. Everything has to be in a proper manner so that you can produce a good amount of the agricultural yield. So agricultural role is important in mitigating this climate change. So what steps can we take? First we have to understand the changing the planting dates. According to the climate, we have to change the planting dates, planting different varieties or crop species. So resistant varieties we have to maintain, developing new drought and heat resistant varieties, improve the crop residue, and better pest and disease control for the crop. So if you these all the things we need to implement in order to adapt with the changing climate change. So the other important thing is that we need to reduce the stress in the plants. So heat stress, rice production systems, we need to, so if you reduce those stress, so the grain quality will be increased. And adaptation to the climate change. So based on the climate change, you have to grow the new varieties, that is drought or heat resistant varieties, new farm management practices. So these are the things that needed to be included in the new farm management systems. So based upon the climate change, you can go for the integrated system. Integrated system is both important by conservation of the agriculture. You can increase the food energy systems and increase the crop production, not only the crop, but also the livestock production efficiency can also be increased. So both has to be go in hand. So integrated system of farming is the one best method. So it is also based upon the climate also. So the crop and livestock systems, so fish and the crop you can grow. These are the integrated food energy systems. So this food and energy crops, if you use, you can cultivate not only the fishes but also the good agricultural productivity of the rice crops. So even several strategies and several smart village programs have been initiated to grow the integrated farm participatory approach and build on local knowledge and plans about this. Use modern ICT tools and capacity strengthening and technology targeting. So my basic conclusion is that so climate change is always a reality, but what we can do is adaptation strategies can help to minimize this negative impact. So my best plan is that you go for the integrated farming systems. So this integrated farming system indeed is going to give you the higher agricultural yield, as well as the food and energy ecosystem is also being increased. So with the help of the research funding, other policy support, you can start this new strategy planning, which is a very good impact on the agricultural production. So save our earth. Thank you.
Thank you, ma'am. Thank you, Dr. Padma.
Thank you.
Our next presenter is Lucia Plantaka. Lucia Plantaka, you are ready, ma'am?
Yes, I'm ready. Should I share the presentation?
Yes, please. Yeah.
Okay, here it is. Can you see it?
Yeah, it's visible.
Okay, thank you. So my name is Lucia Plantak. I'm coming from Faculty of Geotechnical Engineering, University of Zagreb, from Croatia. And I will say something about contribution to improvement to the methodology of measuring of flow in water courses, case study on river Plitvica near Varaždin in Croatia. So we all know that limnographs are used for continuous measurement of water levels on water course. The disadvantage is that they are located in small number of locations on the river, and these locations are often distant from each other, and that is the problem, that there are no continuous measurements between them, or even no measurements at all. The relation... Yes? Okay.
Continue, please continue. Continue.
Okay. The relationship between the measured water levels and the flow of the water course in its cross-section is represented by the stage discharge relationship called rating curve. To obtain a hydrogram, that is a flow change diagram at time, it is necessary to measure the flow on daily basis, which is very expensive and impractical. Most often, different software packages are used for modeling of the flow conditions within the water course, which simplifies the actual real conditions. continuity of the measuring is required to obtain the real situation, despite the fact that it is difficult due to the cost and a lot of required time. So, position of city of Varaždin is in Croatia, and in Varaždin there is a river called Plitvica, and here you can see the point of measurement, and the measurement